Causality and modern science. Note to the reader. The reader is asked not to attach to the words causality and determinism in the text the meanings he has customarily assigned to them. Definitions of these and other key terms are worked out in Part I of the book. The few elementary mathematical and logical signs occurring in the text should not put anybody off, since they are usually explained in plain words. Unless explicitly stated otherwise, italics in quotations belong to the authors quoted. References to books are given in the text in a sketchy form. Details will be found in the bibliography. Preface to the Transaction Edition. Preface to the Transaction Edition, Causality Redux Causality R. When this book RST appeared, in 1959, most experts believed this book RST appeared, in 1959, most experts believe that causality was a dead subject. In fact, it was widely believed that causality a dead subject. In fact, it widely believed that the quantum theory had killed the hypothesis that every event is the quantum that had killed the h that ev is caused by a preceding event. End. This view came as no surprise to the caused by a preceding evt view came as no sur to the followers of Hume, in particular the positivists and Kantians. For follow W of Hume in par the positi and Kantians f them phenomena, appearances, are all there is, and causal con them phenomena, appearances, are all there is and causal connections are mere conjectural, since all we perceive are successive necked ions are mere conjectural, since all W perceive are successive contiguous appearances. Contiguous appearances. Ironically, Werner Heisenberg, one of the fathers of quantum ironically W.E.R. Heisenberg, one of the fathers of quantum mechanics, explained his famous uncertainty principle using a causal mechanics explained his famous unsur principle using a causal reasoning. In fact, in discussing his famous hypothetical micro-reasoning in discussing his famous H microscope, he stated that the attempt to localize a particletical BYY shining scope he stated that the attempt to localize a PARB shining light on it kicked the particletical in an uncontrollable fashion, so that light on it kick the PAR in an uncontrollable fashion, so that both the position and the velocity of the particletical were altered by both the position and the v of the PARW altered by unknown amounts. So, the demise of causality was attributed to unknown amounts, so the demise of causality W attributed to the f-khaki of causation. The f-khaki of causation. Likewise, discussions of chance haunts or randomness can hardly likewise discussions of C or randomness can hardly dispense with causal considerations. For example, when playing ing or pence with causal considerations example when PLA or analyzing a game of cards one makes sure that the pack K of cards analyzing a G of cards one makes sure that the pack of cards has been shoved repeatedly and blindly so as to destroy whatever has been shoved and blindly so as to destroy weight F order there was at the beginning, one causes disorder, or increase order there W at the beginning, one causes disorder or increase in the entropy of the system. So, at least in this case, causation in the entropy of the system. So at least in this case causation begets its chance. Beg see hence likewise, when agree treat many random micro-events sense happen in likewise when ag many random micro-ev happen independently from one another, causal macro-patterns emerge. For from one another causal macro-pattern emergency ef example, as a piston compresses a gas, the number of molecular example as a piston compresses Ag as the n of molecular impacts increases, and so does the pressure. Likewise, as the popu impacts increases and so does the pressure likewise as the population of a social system increases, individual deviations tend to lation of a social system increases deviations tend to balance one another, and social regularities emerge. For instance, balance one another and social regularities emergency ef instance. 15. Preface to the Transaction Edition. Preface to the Transaction Edition 1616. Although individual incomes are variable, the average income of although Indi incomes are variable, the average income of the industrial workers in the United States has remained practically the industrial work in the United States has remained practically unchanged over the past 3 decades. UNC hang over the past 3 decades what had of free will? Does it not refute causality? Not at all, argued W of free will. Does it not refute causality? Not at all, argued Donald O. Hebb, the psychologist-thologist who renewed biopsychology. Donald O. Hebb, the PSYC who renew biopsychology, cognitive and affective neuroscience, half a century ago. The HOC, cognitive and affective neuroscience, half a century ago. Occurrence rents of free will only refutes the behaviorist contention that cur of free will only refutes the BH contention that all responses are caused by external stimuli uli. It only shows that the all responses are caused by external stim. It only show that the brain can act spontaneously, that is, in the absence of environmental brain can act spontaneously, that is in the absence of environmental stimuli. Uli. Free will, stated Hebb, is control of behavior via byy thought. Stim f will, stated Hebb, is control of BH thought. Half a century later, cognitive control has become a hot topic. In half a century later, cognitive control has become a hot topic in cognitive neuroscience. It is the study of one of the main functions cognitive neuroscience. It is the study of one of the main functions of the prefrontal cortex in higher vertebrates, and it makes use of the prefrontal COR in higher vertebrates, and it make use of fMRI, functional magnetic resonance imaging, machines. fMRI, functional magnetic resonance imaging, MAC social scientists interested in rational choice theory, and social scientists interested in rational the and philosophers working in action theory, have argued that we do many philosophers W in action the have argued that W do many things for reasons, not causes. For example, given a choice between things for reasons not causes example givac bit 2 or more alternatives, we estimate their respective expected TW or more alternative ESW, estimate their respective expected utilities, and pick K the most convenient among them. Perhaps, but utilities, and pick the most convenient among them. Perhaps, but what is the choice mechanism, Hainism? Presumably it is a neural process. What is the C-mech? Presumably it is a neural process occurring ring in the prefrontal lobe, and as such subject to the causal occur in the prefrontal lobe, and as SUC subject to the causal laws was characteristic of systems of neurons. In other words, when law C of systems of neurons in other W words, when weighing reasons we use causation instead of avoiding it. W reasons W use causation instead of AV it. In sum, we have abandoned radical causalism, but, far from be in sum, W have abandoned radical causalism, but, far from becoming indeterminists, we have enriched determinism with new, coming indeterminists. W have enriched deter with new non-causal, determination categories. And we are still on the job non-causal, deter categories, and W are still on the job of characterizing our basic concepts and hypotheses concerning ning of C our basic cons and H concert causation. The appendix reports on some of the work published causation. T appendix report on some of the W published after the publication of the RST edition. In particular, it contains after the publication of the RST edition. In particular it contains MYY own definition of the causal relation in the language of state, MO definition of the causal relation in the language of state spaces. Spaces there here are German man, Hungarian Aryan, Italian, Japanese, Polish Olish, Russian Ushan, TRGER Hung Italian, Japanese PR, and Spanish translations of this book. Preface to the third edition. XXXX Mental Psychology agrees, Piaget, 1930, in Helder, and Piaget, 1958. Even ethologists find reasons for suspecting that all vertebrates are capable of forming representations of causal links. After all, An animal that followed David Hume's view that there is no causation but only accidental constant conjunction, would be ill-equipped to face the challenges of its environment. So, there must be something in causalism, surely not the whole truth but a good portion of it. Hence indeterminism cannot be an adequate substitute. We may be persuaded to give up the causal principle, but in the end we come back to some form of it, even if a considerably diluted one. As Anne in Jane Austen's Persuasion discovers, reason may prevail for a while against our instincts, but love conquers in the end, particularly when reason is found to be quite unreasonable. Indeed, it is perverse to claim that causality is altogether mythical, that kicking the ball does not cause it to move, or that listening to propaganda day in and day out does not cause us to change our beliefs and act accordingly. To claim that these are just constant but otherwise accidental conjunctions is not just artificial, it is a plain mistake. 3. Causality and contemporary science consider a sequence of events often regarded as a model of acausality, light absorption. When a quantum physicist calculates the probability that an atom will absorb a photon, he treats this event as the cause of the atom jumping to an excited energy level. That is, he calculates the probability that such a cause-effect relation obtains. He admits then that there are causes and effects even if he does not accept the assumptions that every event must have a cause, and that every effect has a single cause. Moreover, he could argue that, although the quantum theory is basically stochastic, it also has a causal aspect summarized in the Hamiltonian operator. The commutator of the Hamiltonian with a coordinate equals the corresponding component of the force acting on the microthing. Likewise, not everything is random in biology. True, mutation is a chance event and gene recombination is random as well. XXI, but this is only half of the story. The other half is that such randomly constituted genotypes are selected by the environment, and this selection is anything but random. In fact, those organisms that are unfit are eliminated and so leave no offspring. For this reason it has been rightly said that the environment is the anti-chance or causal aspect of evolution, Dobbs-Hansky, 1974. What holds for physics and biology holds also, mutatis mutandis, for the social sciences. Surely chance is rampant in human affairs. If it were not, we might be able to predict accurately the future state of our economies. But causation is no less a factor. Every person counts on certain causal links when intent on causing someone else to do this or that, or on preventing somebody from causing him to behave in a given manner. Surely, as in the case of physics, we can often modify only the probabilities of certain causal relations. But this may suffice for practical purposes and, in any case, it shows that causality is anything but dead in social science. For the comeback of causality, the philosophical climate I encountered when I started to write this book a quarter of a century ago has altered considerably with regard to the causal problem. For one thing, we have come to form a more balanced view of science. We no longer believe that all of the natural sciences are ultimately reducible to physics, and that the latter is practically compressed into the quantum theory with its attendant indeterminacy. Even the so-called indeterminacy relations have received a number of non-indeterministic interpretations, CPO Bunge, 1977a. For another thing, the Hume-Contmach estate is bankrupt. Most positivists are dead and very few philosophers follow in their wake, a deplorable fact considering that the antipositivistic reaction has been pushed so far that it has often turned into a reaction against science and even rationality in general. In any case, the positivistic prejudice against causality and, in general, against ontology, is no longer in force. Ontology is back and doing rather well considering that it had been. Preface to the third edition. Preface to the third edition. XXII pronounced dead so many times over the past 2 centuries. In particular, the investigation of the causal problem has become respectable once again. A perusal of the philosophical literature will leave no doubt as to the vigorous comeback of the causal problem during the 1970s. There are not only hundreds of journal articles but also a number of distinguished monographs on the subject. First of all, we have Wallace's scholarly and massive work, 1972, 1974, undoubtedly the most exhaustive and authoritative historical philosophical treatment of the subject. Then we have Mackey's profound criticism of the positivist doctrine of causation, and examination of the role of causal thinking, 1975. An alternative, though also non-positivist view, is found in the provocative book by Hare and Madden, 1975. Svechnikov's monograph on physical causality, 1971, tells about the interest of the problem among dialectical materialists. Von Wright's work, 1971, emphasizes the role of causality in action theory. Finally there is Supp's quixotic attempt, 1970, 1974, to formalize and rehabilitate Hume's non-causal doctrine on causation. In short, the student of the causal problem has now a good starting point, something he did not have a quarter of a century ago. 5. The two aspects of the causal problem. Like many other important philosophical problems, the causal problem is actually a whole cluster of problems. This set can be partitioned into two subsets. I. The ontological problem of causality, i.e. what is causation, what are the characteristics of the causal link, to what extent are such links real, are there causal laws, how do causation and chance intertwine, and so on. 2. The methodological problem of causality, i.e. what are the causation criteria, how do we recognize a causal link and how do we test for a causal hypothesis. Every one of these subsets has a variety of problems. Just think of the difficult methodological problem of disclosing XXIII causal relations beneath statistical correlations, cf. Blaylock and Blaylock, 1968. Moreover, the membership of every one of the above subbelusters of problems keeps changing in the course of time. But somehow none of them ever gets depleted, even though once in a while a hasty philosopher will proclaim the final solution to the causal problem, perhaps without having bothered to propose a careful formulation of the causal principle. This is not surprising in philosophy. At some time or other, matter, motion, space, time, law, chance, and many other metaphysical categories were decreed dead until it was eventually discovered that they refused to lie down. Likewise, the problem of induction has been pronounced solved or even dissolved, although it is still very much alive among scientists. And at other times the problem of interpreting a theory in factual terms was proclaimed either finally solved or altogether insoluble or even meaningless. Philosophers seem to be poor forecasters and accident-prone. We seem to abide only by one law, namely Murphy's. If anything can go wrong, it will. This book focuses on the ontological problem of causality. It analyzes causal links and processes as well as non-causal relations among events, with a view to finding out the range of validity of the causal principle. And in the process it analyzes a number of doctrines on causation. It thus offers a philosophical analysis of causation and of causal doctrines, but does not pay much attention to the methodological problem of causality. There is still much to be done. In particular, there is room for a full-fledged hypothetical deductive theory of causation framed with the help of exact tools. Let me explain. 6. Causation as event generation. There are four main modes of conceiving of causation: to deny it, to equate it with uniform succession, to identify it with constant conjunction, and to regard it as a, or even the, way events are generated. This book takes the latter view. More precisely, it formulates and defends the following theses. I. The causal relation is a relation among events, not among properties, or states, let alone among ideas. Strictly speaking. Preface to the third edition. Preface to the third edition. XXIV causation is not even a relation among things. When we say that thing A caused thing B to do C, we mean that a certain event, or set of events, in A generated a change C in the state of B too. Unlike other relations among events, the causal relation is not external to them, as are the relations of conjunction, or coincidence, and succession. Every effect is somehow produced, generated, by its cause, S. In other words, causation is a mode of energy transfer. 3. The causal generation of events is lawful rather than capricious. That is, there are causal laws or, at least, laws with a causal range. 4. Causes can modify propensities, in particular probabilities, but they are not propensities. In the expression event X causes event R with probability P, or the probability that X causes R equals P, the terms causes and probability are not interdefinable. Moreover, strict causality is non-stochastic. 5. The world is not strict, J-causal, not all interconnected events are causally related. Causation is just one mode of determination. Hence determinism need not be conceived narrowly as causal determinism. Science is deterministic in a loose sense, it requires only lawfulness, of any kind, and non-magic. 7. The state-space approach to the causal relation to say that the causal relation is a relation among events is insufficient. Nor does it suffice to add that the causal relation is irreflexive, asymmetric, and transitive. We must specify further, but not so much that the desired generality may be lost. The way to deal with things and their changes in general, without presupposing any particular laws, is to adopt the state-space approach. For a system of ontology conceived this way, and details on what follows, see Bunge, 1977b, 1979, consider any concrete thing whether particle or field, atom or chemical system, cell or organism, ecosystem or society. We may assume that everything is, at each instant, in some state or other, relative to a given reference frame, and that no thing remains forever in the same state. One way of describing states and changes of state is as follows. XXV draw the list of all, known, properties of a thing, and represent each property by some, mathematical, function. Such a list, or n-tuple, is the state function of the thing, call it f. The changeability of the thing is reflected in the time dependence of f. As time goes by, the value of f at t, i.e. f, t, moves in an abstract space. This space is called the state space of the thing x, or s, x, for short. Any event or change occurring in x can be represented by an ordered pair of points in s, x, and visualized by an arrow joining those points. The collection of all such pairs of states is the event space of x, or E, x. The set of all really possible, i.e. lawful, events in, or changes of, thing x, i.e. x, is a subset of the Cartesian product of s, x, by itself. The statement that event E happens in or to thing x is abbreviated, EEE, x. A process in thing x is representable as a sequence, or list, of states of x or else as a list of events in x. A convenient representation of the set of all changes occurring in a thing x is obtained by forming all the ordered pairs t, f, t, of instants of time and the corresponding states of the thing concerned. Such a set, or h, x, equals t, f, t, itet, can be called the history of x during the time span t. Consider now two different things, or parts of a thing. Call them x and e, and call h, x, and h, y, their respective histories. Moreover, call h, y, lx, the history of e when x acts on e. Then we can say that x acts on y if and only if h, y, dash equals h, y, lx, i.e. if x induces changes in the states of e. The total action, or effect, of x on e is defined as the difference between the forced trajectory of y, i.e. h, y, x, and its free trajectory h, y, i.e. a, x, y, h, y, lx, and h, y. Likewise for the reaction of e upon x. And the interaction between x and e is of course the union of a, x, y, and a, y, x. Finally, consider an event e in a thing x at time t, and another event e in a thing e x at time t. The events and the times are takery relative to one and the same reference frame. Then we can say that e is a cause of e just in case, a, t precedes t and, b, e is in, belongs to the total action A, x, y, of x upon E. In this case E is called an effect of E. Having defined the notions of cause and effect, we may now Preface to the third edition XXVI state the strict principle of causality. A possible formulation is this: every event is caused by some other event. More precisely, let X be a thing with event space E, X. Then for every E, X, there is another thing Y X, with event space E, Y, relative to the same reference frame, such that E, Y, causes E. It is a thesis of the present book that the principle of causality is never strictly true because it neglects two ever present features, spontaneity, or self-determination, and chance. The matters of space, time, contiguity, continuity, etc., can also be handled with the help of the above notions. Moreover, it would be interesting to formulate all possible doctrines of causality within the state-space framework. This would facilitate their mutual comparison as well as their confrontation with the most general principles of science. This is just one among many open problems in the field of causality. 8. Conclusion: the causal problem, which was generally regarded as buried once and for all when this book first appeared, has become topical once again. True, we are no longer causalists or believers in the universal truth of the causal principle, we have curtailed it. However, we do continue to think of causes and effects, as well as of causal and non-causal relations among them. In particular, we can often compute or measure the probability that a given event will have a certain effect. Instead of becoming indeterminists, we have enlarged determinism to include non-causal categories. And we are still in the process of characterizing our basic concepts and principles concerning causes and effects with the help of exact, i.e. mathematical, tools. This is because we want to explain, not just describe, the ways of things. The causal principle is not the only means of understanding the world, but it is one of them. Therefore beware next time you hear that causality has now finally been eliminated. Foundations and Philosophy OJ Science Unit. McGill University, Montreal H3AIW7, Canada. Mario Bunge. The problem of causality has again become prominent in relation with the quantum theory. In fact, all recent quantum field theories include the principle of antecedence: there is no output before there is an input, and most of them also include the principle of contiguity, or local interaction: every action is exerted through some medium, example a field. The former hypothesis is often called causality condition, although it can be argued, as is done in Chapter 3 of this book, that it is logically independent from the principle of causation, or regular production of the effect by the cause. Likewise, the principle of local interaction is often linked with the causal principle and is even called condition of microscopic causality, although it is not a necessary ingredient of the latter, as I have tried to show in Chapter 3. In this way, many physicists have come to adopt a curious dual attitude towards causality. When confronted with the elementary theory, first quantization, they tend to say that causality is finished, but as soon as they pass over to the advanced theory, field theory, they begin by stating what they misname causality conditions. The above questions are not merely terminological. Any discussion of determinism and indeterminism in modern science will be misguided if it involves confusions such as those of antecedence and contiguity with causation, and determinism with Laplacian determinism. I have tried to clarify further these points in two articles that may be regarded as supplements to this book, Causality, Chance, and Law, in American Scientist, Volume 49, 1961, p. 432, and Causality, a Rejoinder, in Philosophy of Science, Volume 29, 1962, p. 306. The latter is reproduced in the present edition as an appendix. Preface to the third edition PR to the third edition XXX, and the former is included in my new book, The Myth OJ Simplicity. The differences between lawfulness and determination are dealt with in my Kinds and Criteria of Scientific Law, Philosophy OJ Science, Volume 28, 1961, p. 260, and the incompatibility of the law of continual creation of matter out of nothing with the genetic principle, a component of determinism lato sensu, in My Cosmology and Magic, to appear in the first issue of the New Monist. I have taken the opportunity of this new edition to correct a few misprints in the original edition and to add a couple of footnotes. Buenos Aires, October 1962. Mario Bunge. This is an essay on determinism, with special emphasis on causal determinism or causality, for short. To some, causation and determination and consequently causalism and determinism are synonymous. But to most people, determinism is a special, extreme form of causality and even a particularly displeasing one, for it is wrongly supposed to deny man the possibility of changing the course of events. I take sides with the minority that regards causal determinism as a special form of determinism, namely, that kind of theory that holds the unrestricted validity of the causal principle to the exclusion of every other principle of determination. The rational ground for regarding causality as a form of determinism, and not conversely, is that modern science employs many non-causal categories of determination or lawful production, such as statistical, structural, and dialectical, though they are often couched in causal language. In this book, the causal principle is neither entirely accepted nor altogether rejected. My aim has been to analyze the PR to first edition XXXI meaning of the law of causation, and to make a critical examination of the extreme claims that it applies without restriction, causalism, and that it is an outmoded fetish, acausalism. I have tried to do this by studying how the causal principle actually works in various departments of modern science. However, I hope I have succeeded in avoiding technicalities save in a few isolable passages. The book is, in fact, addressed to the general scientific and philosophic reader. The chief result of the above mentioned examination is that the causal principle is neither a panacea nor a superstition, that the law of causation is a philosophical hypothesis employed in science and enjoying an approximate validity in certain fields, where it applies in competition with other principles of determination. A byproduct of this analysis is a fresh examination of various topics in metascience, ranging from the status of mathematical objects to the nature and functions of scientific law, explanation, and prediction. A systematic rather than a historical order has been adopted. However, owing to the fact that probably all of the ideas on causation that have been thought are still extant, and assuming that genuine interest in ideas always leads to inquiry into their historical development, I have usually mentioned some of the historical roots of the most important ideas dealt with. More exactly, I have recalled some of their Western roots, a limitation that it would be difficult to exculpate. A further, and more severe, restriction concerns the kind of illustrations that have been chosen. I fear that physics has here got the lion's share. I might try to apologize for this preference by claiming that, after all, physics is the lion of the so-called empirical sciences, which is probably true, but it will be more honest to grant that the one-sidedness in question, which I hope is not exaggerated, is just a sign of a professional deformation. Error seekers should find this book particularly rewarding. I myself regard everything in it as controvertible and consequently as replaceable or improvable. In contrast to dogmatic commenting and arbitrary speculation, scientific philosophy is essentially critical and self-correcting, requiring that its assertions be put to the test. Philosophy, I believe in common with Prefacephus to the third edition PR to the third edition XXXII an increasing number of people, deserves to be called scientific solely to the extent to which its hypotheses are somehow testable, whether directly, by their logical compatibility with a given set of principles, or indirectly by the verifiable consequences such ideas may have on practical human activity and on scientific research. This book should satisfy no orthodoxy. If it did, I would regard it as a failure. Not that I have tried to seek novelty for the sake of innovation, but I claim that no single philosophic school has ever afforded a satisfactory provisional solution of the problem of determinism. Moreover, it might be argued that we owe no single contemporary philosopher an analysis and systematization of the categories of determination comparable to Aristotle's. On the other hand, valuable elements for a modern scientific approach to the problem of determination can be found scattered in various modern philosophies of science and ontologies influenced by science. I should be satisfied if this book were to add some amount of fruitful controversy over the much debated question of causality, stimulating if only as a reaction some fresh thought on the inexhaustible problem of determinism. Moreover, I hope that it may give rise to new ideas resulting in the improvement of what is said in it. Buenos Aires, December 1956. MB. Part I. A clarification of meaning. 1. Causation and determination. Causality and determination. The bewildering confusion prevailing in contemporary philosophic and scientific literature with regard to the meanings of the words causation, determination, causality, and determinism, obliges us to begin by fixing the terminology. A certain nomenclature will be proposed in this chapter, and the place of causal determination in the frame of general determinism will be sketched. 1.1. Causation, causal principle, and causal determinism. 1. The threefold meaning of the word causality. The word causality has, unfortunately enough, no fewer than three principal meanings, a clear symptom of the long and twisted history of the causal problem. The single word causality is in fact used to designate a category, corresponding to the causal bond, b. a principle, the general law of causation, and c. a doctrine, namely, that which holds the universal validity of the causal principle, to the exclusion of other principles of determination. In order to minimize the danger of confusion, it will be convenient to try to keep to a definite nomenclature in correspondence with such a semantic variety. Let us designate by a. causation, the causal connection in general, as well as any particular causal nexus, such as the one obtaining between 3. 4. A clarification of meaning, flames in general and burns produced by them in general, or between any particular flame and any particular burn produced by it. b. Causal principle, or principle of causality, the statement of the law of causation, in a form such as the same cause always produces the same effect, or any similar, and preferably refined. 1. It will be convenient to restrict the term causal law to particular statements of causal determination, such as flames invariably cause burns in the human skin. Finally, c. causal determinism or causalism, and often simply causality, the doctrine asserting the universal validity of the causal principle. A few formulations of the kernel of this theory are: everything has a cause, nothing on earth is done without a cause, nothing can exist or cease to exist without a cause, whatever comes to be is necessarily born by the action of some cause, and everything that has a beginning must have a cause. In short, while the causal principle states the form of the causal bond, causation, causal determinism asserts that everything happens according to the causal law. II.2. Causation, a purely epistemological category if relation, or an ontological category. As here understood, causation is synonymous with causal nexus, that connection among events which Galileo I described as a firm and constant connection, and which we shall try to define more accurately in Chapter 2. But what is the status of the category of causation? Is it a form of interdependence, and has it consequently an ontological status? Or is it a purely epistemological category belonging solely, if at all, to our description of experience? Causation and determination, causalism and determinism. 5. The modern controversy over this question began with the skeptic and empiricist criticism. According to modern empiricism, the status of the causation category is purely epistemological, that is, causation concerns solely our experience with and knowledge of things, without being a trait of the things themselves, whence every discourse on causation should be couched in the formal, not in the material, mode of speech. Point 2. Thus Locke III proposed the following definitions: that which produces any simple or complex idea, we denote by the general name cause, and that which is produced. Effect. Thus finding that in that substance which we call wax fluidity, which is a simple idea that was not in it before, is constantly produced by the application of a certain degree of heat, we call the simple idea of heat, in relation to fluidity in wax, the cause of it, and fluidity the effect. Moreover, like Kant after him, Locke held the causal principle to be a true principle of reason, a proposition with a factual content but not established with the help of the external senses. The conception of causation as a mental construct, as a purely subjective phenomenon, was emphasized by Locke's followers Berkeley 4 and Hume 5 as well as by Kant 6. But, whereas Locke had regarded causation as a connection, acknowledging production as its distinctive mark, his followers 6. A clarification of meaning have held that causation is only a relation 7 and moreover one relating experiences rather than facts in general. Hume emphasized this point particularly, on the ground that it would not be empirically verifiable that the cause produces or engenders the effect, but only that the experienced event called cause is invariably associated with or followed by the experienced event called effect, an argument which is of course based on the assumption that only empirical entities shall enter any discourse concerning nature or society. The empiricist doctrine of causality will be examined rather closely in the course of this book, especially as it is a widespread belief that Hume gave the final, or almost final, solution of the causal problem. For the time being we shall merely state the opposite thesis, namely, that causation is not a category of relation among ideas, but a category of connection and determination corresponding to an actual trait of the factual, external and internal, world, so that it has an ontological status although, like every other ontological category, it raises epistemological problems. Causation, as here understood, is not only a component of experience but also an objective form of interdependence obtaining, though only approximately, among real events, i.e., among happenings in nature and society. But before we can ascertain whether causation is a category of determination, and long before we can hope to show that, while being so far used in both science and philosophy, it is not the sale category of determination, we shall have to examine what is meant by determination. 1.2. Toward a general concept of determination I.2. I2 meanings of determination, property, and constant connection. Let us take a glance at the different uses of causation and determination, two concepts that are frequently regarded as causation and determination, causalism and determinism 7 equivalent 9. Although some philosophers have acknowledged their difference. In actual use the word determination designates various concepts, among which the following are particularly relevant to our discussion: a. Property or characteristic, b. Necessary connection, and c. Process whereby an object has become what it is or way in which an object acquires its determinations in sense. A. In its first acceptation, determination is synonymous with characteristic, whether qualitative or quantitative. This is what determinatio meant in post-Roman Latin, and in this way it is used in various European languages, notably in German, determination and Bestimmung. In this sense, that is determinate which has definite characteristics and can consequently be characterized unambiguously. When applied to descriptions and definitions, determinate is used as an equivalent of precise or definite, in contradistinction to vague. Thus Locke 11 called determinate or determined the ideas which Descartes had described as clear and distinct, and Claude Bernard 12 termed intermins the facts collected without precision, those ill-defined facts constituting real obstacles to science. But in science the most frequent use of the word determination that is relevant to our concern seems to be that of constant and unique connection among things or events, or among states or qualities of things, as well as among ideal objects. Thus, for instance, machines that run regular and reproducible, hence fully predictable courses have been called determinate. Their successive states follow one another in a constant and unique way to the exclusion of new, unexpected states, contrarily to indeterminate machines, whose states are only statistically. 8. A clarification of meaning determined and constitute moreover an open set, that is, 1 admitting new elements. Is, if by necessary is meant that which is constant and unique in a connection. 14 then in sense, b, the word determination amounts to necessary connection. If the form of a necessary connection is known, then some features of certain relata will be inferable from the knowledge of certain other relata. Thus, for example, the relation twice, that is, y equals 2x, enables us to derive unambiguously the value of e when that of x is specified. Analogously, an equation such as x, 1 equals 0, 1.1, is called determinate because it has a unique solution, xi. On the other hand, the equation x plus j, I equals 0, 1.2, is called indeterminate because, although it expresses a rigid interdependence between x and e, a further datum, that is, a further equation, is needed in order to solve the problem. As it stands, equation 1.2 admits infinite solutions. In other words, the problem is not uniquely determined, although every particular answer, such as x equals, y equals I, far from being lawless, will fit the law x plus y, 1 equals O. Therefore, probably a better name for such equations would be that of partially determined, or incompletely determinate, in contrast to those of the former type, which are fully determined or completely determinate. 1.2.2 Constant unique connections need not be causal when turning to the sciences of nature and of society. The variables x, y, may symbolize properties of concrete objects, and functions like y equals j, x, may consequently designate relations among qualities or among intensities of qualities. Thus thermal expansion of a metal rod occurs, approximately, in accordance with the law L, T, equals L, O, I plus at, 1.3. 13 Ashby, 1956, An Introduction to Cyberphysics, p. 24. 14 Margina, 1950, TK Nature QF Physical Reality, p. 407. Causation and Determination, Causalism and Determinism 9 where L, 0, stands for the length of the rod at the temperature T equals 0, A being the coefficient of thermal expansion. This law is usually regarded as an instance of the causal principle, namely, as the mathematical transcription of the causal law heating causes the expansion of metals. To test this causal interpretation of 1.3, let us write it in the following, mathematically equivalent form, L, T, L, O, at equals L, O. The right-hand member certainly represents the relative value of the effect, that is, the relative expansion. But the left-hand member, at, contains not only the intensity of a quality belonging to both the agent and the patient, namely, the temperature T, but also A, which denotes a thermoelastic property, a disposition, characterizing the piece of metal and having nothing to do with the specific nature of the extrinsic agent, fire, warm water, radiation, producing the modification, expansion, concerned. In short, while the second member of our relation does represent the effect, expansion, the first member does not represent the cause, heating, at least not in an equally satisfactory way. Hence, 1.3, is a fully determined, constant and unique, relation, that is, it stands for a necessary connection among the qualities length and temperature, and the disposition expansibility, but it does not reflect the causal connection between the heating agent and the effect it produces. This should suffice, for the time being, to suggest the inadequacy of the functional view of causation, which will be dealt with at length in Sector 4. In case the foregoing example was not found modern enough, we might recall Einstein's famous law of the numerical equivalence of the mass m of a body and its energy E, where c symbolizes the velocity of light in vacuum. This, too, is a relation expressing a necessary connection among properties of a physical object. One can, and usually does, say that the numerical value of one of the properties is determined by the 10a clarification of meaning value of the related property. But, clearly, when used in this way, the word determination does not convey the activity and productivity inherent in causation. and it could not be otherwise, as neither temperature nor mass are physical agents, events, or phenomena, but are instead qualities of physical objects. In other words, since qualities and dispositions have by themselves no productive virtue, the laws, 1.3, and 1.4, are not causal laws although they express necessary connections. Hence the word determination is used in connection with them in a sense which is more restricted than that of causation, namely, in the sense of necessary, constant and unique, relation between properties. This point is seen even more clearly if, in the function y equals f, x, the independent variable is made to denote time. For example, the velocity v, t, acquired by a freely falling body after t seconds have elapsed is v, t, equals gt plus vo, g, and vo being constants. One can say that v, t, is determined by t, but not, of course, in the sense of being produced by it, since time has no productive virtue of its own except in a highly metaphorical sense. Both the unique connection between v, t, and the hypothesis that such a connection is constant, invariable, enable us in principle to predict the value of the velocity after any prescribed time has elapsed. In general, in this restricted sense, determination means possibility of calculation and consequently of quantitative forecast. The same applies to the law, 1.3, of the thermal expansion of a metal rod. Although it does not contain time, it enables us to predict the value L, T, when L, O, X, and the temperature T are known. Analogously, Einstein's law, 1.4, enables us to predict, for example, the energy required to dissociate a molecule if its mass defect is known. The apparent paradox of prediction with the help of laws that do not contain time is dissolved as soon as it is recalled that time enters our use of such laws. But the meaning of the laws of nature is not restricted to the possibility of calculation on their basis contrary to what some causation and determination, causalism and determinism empiricists have maintained. 16 Indeed, if determination has an epistemological status, it is because it has an ontological support. Thus, if we can predict the intensity of the property y from the value of the associated property x through the relation y equals f, x, it is only because, and to the extent to which, such a mathematical relation has an objective counterpart. In the sciences dealing with concrete objects we are not interested in calculating for the sake of calculation, but in calculating what we assume to have some relation, even if remote, with real events and processes. That is, meaningful and useful calculation follows in these sciences, as contrasted to mathematics, from the assumed factual validity of the law statements with the help of which calculation is carried out. I 2.3. A third meaning oj determination, way oj becoming. From the foregoing we conclude that the word determination, as used in science, has a very restricted meaning. It means less than causal determination, for though it denotes constant unique connection, which is certainly a characteristic of the causal bond, it lacks the essential ingredient of productivity. In other words, the current scientific meaning of the word determination does not coincide with the third acceptation of it which we have recorded, namely, the way, act or process, whereby an object acquires a property. In this sense, not only that which is fully qualified, hence susceptible to unambiguous description, is determinate, not only that which has definite characteristics, but also that which has acquired them in one or more definite ways. This addition may at first sight seem ocious, but it is not, for, according to indeterminism, there may be determination in senses, A, and B, but not in sense, C. Indeed, according to the propounders of accidentalism or tachism, as C.S. Peirce called it, things do have definite characteristics, but they acquire them in a lawless, hence unpredictable, way. Nothing determines what they are, events popping up here and there without any antecedent or contemporaneous condition. Among the simplest forms of determination in sense, C, stands the acquisition, by concrete objects, of quantitative characteristics without the emergence of new qualities but, instead, through continuous evolution. This is the type of determination envisaged by mechanical determinism, which regards qualities as fixed and consequently takes only quantitative changes into account. Poincare's description 16 of this particular type of determinism, which he called el hypothese determinist, is worth recalling owing to its conciseness, clearness, and wide acceptance. 1.7 According to Poincare, on the deterministic hypothesis the state of the universe is determined by an excessively large number, n, of parameters which I shall call xl, x2, xn if the values of these n parameters are known at any given instant, and their time derivatives are also known, then the values of the same parameters at a previous or at a later time can be calculated. In other words, these n parameters satisfy n differential equations of the form dx dt equals if g, xl, x2, xn, t equals I, 2, n. But not every pattern of change fits the foregoing scheme. Things may acquire their determinations in ways other than the one envisaged by the science of mechanics and by mechanistic ontologies. There are in the world qualitative changes besides quantitative variations, so that mechanical determinism is but a subclass of what I shall call general determinism, or determinism lato sensu. Determination need not be effected through quantitative variations only, as mechanical determinism holds, and it needs 16 Poincare, 1908, Thermodynamic, p. 9. 17 For a similar definition of deterministic system, see Russell, 1912, On the Notion of Cause in Mysticism and Logic, p. 188. Causation and determination, causalism and determinism 13 not be brought forth by external compulsion alone, as causal determinism claims, nor need it be unique or well defined, as both causal and mechanical determinism hold. All that is needed in order to maintain determinism in a general sense is to hold the hypothesis that events happen in one or more definite, determinate, ways, that such ways of becoming are not arbitrary but lawful, and that the processes whereby every object acquires its characteristics develop out of pre-existing conditions. The essential components of general determinism will be described more precisely in Sector 1.5. 1.2.4 Chance, alien to determinism? Even chance, which at first sight is the very negation of determination, has its laws, and accidents emerge from pre-existing conditions. Consequently chance has a place in what we are calling general determinism. Thus the appearance of a head in coin throwing, far from being a lawless event, and far from emerging out of nothing, is the determinate result of a determinate operation. Only, it is not the sole possible result, it is not a unique outcome of a given process, or, as may also be said, it is not a well-defined result. Coin throwing is a determinate process because, a. Far from being unconditional, it requires the meeting of definite conditions, such as the existence of a coin and of a throwing person, or machine, a horizontal surface on which the coin may fall, a gravitational field, and so forth. B. Far from yielding completely indeterminate, arbitrary, lawless results, coin throwing yields just heads and tails, and this, moreover, in accordance with the definite statistical law stating that, in the long run, the number of heads will nearly equal that of tails if the coin is well balanced, whereas if tossing a coin produced at times heads and other times elephants, newspapers, dreams, or any other objects in an arbitrary, lawless way, with no connection at all with the antecedent conditions, then it would be an indeterminate process. In games of chance, the final results arise out of definite conditions in accordance with definite laws. They cannot consequently be used to illustrate or to support indeterminism. Preface to the third edition. Preface to the third edition 1414. Causality. Causality. Causation and determination, causalism and determinism 15. State 1. Incident particle. State 2. Scattered particle. Fig. I. Scattering of a particle by a field of force. The deflection of the particle is not uniquely determined, for several paths are possible, but at any rate it is caused by the force deriving from the potential v, x. Causes and effects, but rather the rigid causal nexus among them. By calculating and by interpreting such transition probabilities P12, we imply, a. that the transitions are not arbitrary and do not arise out of nothing, but follow from definite states under the action of definite forces, so that, for example, we can ascertain with certainty that an electron will not radiate unless it is accelerated by an external field. B. That the transitions are not necessary, in the sense that state 2 does not develop regularly and unambiguously from state I. There is only a certain probability P12 for this occurrence among many other possible transitions, which means that in a large number, n, of cases, the transition I-+2 is almost certain to occur about np12 times. In short, the usual interpretation of the quantum theory actually does not eliminate determinism in the general sense, moreover, it retains a certain dose of causality. But it does drastically restrict the Newtonian form of determinism, according to which all physical processes boil down to changes of position determined by both the previous state of motion and externally impressed forces, the paths of the point masses concerned being precisely defined, fully determined, trajectories in space-time. It may also be said that Newtonian determinism is sublated in quantum mechanics in its orthodox interpretation, since it is found to obtain on the average. On the other hand, the positivistic philosophy built on, and partially built into, the usual interpretation of the quantum theory, eliminates determinism but, then, also indeterminism in the ontological sense, that is, in connection with the behavior of the things themselves, as they exist whether observed or not. It asserts, instead, a kind of empirical indeterminacy which, however, does not exclude definite statistical laws. In point of fact, the logical empiricist interpretation of quantum mechanics 19 declares that the quantum indeterminacy refers exclusively to results of observation, not to matter itself, a term which it regards as a meaningless metaphysical fiction. The root of this empirical indeterminacy is easy to see. The bond between two successive states of an atomic system is taken to be the observer, who acts freely with respect to the system. In other words, the behavior of the observer is regarded, in this interpretation, as independent of the object of observation, but not vice versa. The properties of the observed system are those which the observer decides to prepare or to conjure up, to employ the term introduced by a renowned physicist. In the absence of direct objective connections between the consecutive states of a physical system, it is no wonder that every form of scientific determinism in the ontological sense is lost, with the sole exception of statistical determinacy. This sort of indeterminism is clearly a consequence of the subjectivistic doctrine about the almost arbitrary intervention of the observer, who is regarded as the very conjurer of atomic scale phenomena. Quantum indeterminacy is, then, a consequence of the idealistic hypothesis inherent in modem positivism. 20. This point will concern us again in Sector 12.5. In some recent interpretations of quantum mechanics, not even the causal principle is entirely forsaken. Thus in Bohm's presentation 21 of the quantum theory, Newtonian determinism, with its causal ingredient, is partially restored by the assignment of a physical meaning to the wave function t/, which in the usual interpretation performs only a mathematical function. A force equation is derived, according to which the acceleration of a particle is the effect of the joint action of the external forces and of a new, internal, force depending on the causation and determination, causalism and determinism 17 if J field surrounding the particle. And the statistical distribution of the results of a measurement is not regarded as an unintelligible ultima ratio, but is explained as the outcome of a definite interaction between the physical system in question and the measuring device, a further physical system. In this way quantum jumps cease being elementary, unanalyzable, phenomena, chance at the quantum level ceases to be an ultimate and is instead analyzed into further categories of determination. But the statistical determinacy peculiar to quantum mechanics is not thereby eliminated or explained away, it is shown to be the outcome of lower-level processes. More on the recent revaluation of the causal problem in connection with quantum mechanics will be found in SECS 12.5.2 and 13.4.2. Whether we accept some causal interpretation of quantum mechanics or not, we see that this physical theory, in either of its interpretations, does not dispense with determinism in general but at most forsakes the Newtonian type of determinism. We also realize that, whether chance is regarded as a radical ultimate, as Peirce and Eddington thought, or not, statistical determinacy has to be accounted for by every philosophy of modern science. It is no longer possible to state dogmatically that chance is but a name for human ignorance, or to declare the hope that it will ultimately be shown to be reduced to causation. Chance is a peculiar type of determination, and its relations to other categories of determination are worth investigating. 1.3. The spectrum of categories of determination. Since we wish to characterize causal determination as neatly as possible, we have to point out its place in general determinism. As here conceived, causation is only one among several categories of determination. A surely incomplete list of such categories appearing in the ontology of modern science is the following: quantitative self-determination, determination of the consequent by the antecedent. Illustrations: A. The successive positions of a freely moving macroscopic body are uniquely determined by 18. Clarification of meaning: its pos eidolon and velocity at any prescribed instant of time. B. The spontaneous transformations of an isolated thermodynamic system are such as take it to states of increasing entropy. Quantitative self-determination is the category of determination prevailing in the continuous unfolding of states that differ from one another in quantitative respects only. In some cases, notably in thermodynamics, quantitative self-determination may be shown to emerge from processes characterized by other categories of determination, among them causation. Causal determination, or causation, determination of the effect by the efficient, external, cause. Illustrations: A. If a bullet is fired against a window, the glass is broken. B. If an electromotive force is applied to the ends of a piece of metal, an electric current is set up in the metal in accordance with Ohm's law. The causation category is particularly conspicuous when the main changes are produced by external factors. Interaction, or reciprocal causation, or functional interdependence, determination of the consequent by mutual action. Illustrations: A. The orbits of the components of a double star are determined by their gravitational interaction. B. The functioning of every gland in the human body depends on that of the remaining glands. Mechanical determination, of the consequent by the antecedent, usually with the addition of efficient causes and mutual actions. Illustrations: A. Forces modify the state of motion of bodies, but motion may exist before the application of the forces. B. The streamlines in a fluid are determined by the latter's previous state, by the external forces acting upon it, by internal friction, viscosity, and by internal pressure differences. Statistical determination, of the end result by the joint action of independent or quasi-independent entities. Illustrations: A. In the game of dice, the long-run frequency of the event throwing two aces in succession is I-36. B. About 1/2 of the newborn children are females. As in the case of other categories of determination, statistical determinacy may emerge from processes on deeper levels, in which still other categories of determination are involved. Causation and determination, causalism and determinism. 19. Structural, or holistic, determination, of the parts by the whole. Illustrations: A. The behavior of an individual, a molecule in a fluid, a person in a social group, is determined by the overall structure of the collection to which it belongs. B. The functioning of an organ is partially determined by the needs of the whole organism. But, of course, the whole, far from being prior to its members, is in turn determined by them. Teleological determination, of the means by the ends, or goals. Illustrations: A. Birds build their nests in order to safeguard their young. B. Standardization is adopted in industry in order to lower production costs. Needless to say, goal-directed structures, functions, and behaviors need not be purposefully planned by anybody. Dialectical determination, or qualitative self-determination of the whole process by the inner strife and eventual subsequent synthesis of its essential opposite components. Illustrations: A. Changes of state in matter in bulk are produced by the interplay and final predominance of one of the two opposite trends, thermal agitation and molecular attraction. B. The contrasting economic interests of social groups determine changes in the very social structure of such groups. In opposition to quantitative self-determination, internal dialectics involves qualitative changes. And, needless to say, it has nothing to do with logical contradiction. Further types of determination would certainly be recognized as a result of deeper analysis. At any rate, causal determination appears as only one among various ways of determination, as one of the types of lawful production, or nomogenesis. Hence causal determinism, or causality, which is placed between the two extremes of fortuitism and fatalism, is but one variety of determinism. Along with other types of determinism, causality is subsumed under general determinism. I.e. connections among different types of determination. Any clear-cut distinction among types of determination involves the assumption that they are irreducible to one another, that is, that none of them can be regarded as a mere mixture of other forms of lawful production, every one of them being characterized by a peculiar newness of its own. That this is the case can be seen from the respective definitions of the categories of determination, and will be shown with the help of more detailed analysis as occasion arises. At this point I only wish to point out, first, that the above-mentioned determination categories, however mutually irreducible they are also connected with one another, constituting a hierarchy of types of determination, and second, that, as a consequence of this connection, no type of determination is found to operate in all purity, to the exclusion of all others, save in ideal cases. To illustrate my first contention, take mechanical determination, which is a peculiar combination of purely quantitative self-determination, in this case inertial motion and reciprocal action, which can often be polarized into cause and effect. Or take statistical determination, which emerges, with characteristics of its own, as a result of the interplay of a large number of elements that are individually determined in accordance with other types of determination, mechanical, or teleological. The various types of determination are genetically connected with one another, and the higher types are dependent on the lower without being entirely reducible to them. No type of determination can be assigned a territory where it operates to the complete exclusion of other types of lawful production. True, one might try to characterize different sectors of reality according to the relative predominance of the various categories of determination, but no clear-cut stratification would result from this. Take, for instance, the domain of life processes, which vitalists claim is unambiguously and exclusively characterized by final causes. Biology seems to use a certain amount of teleology, which is harmless as long as it is cleansed of its traditional unscientific associations, but it also needs the category of determination by virtue of inner processes, that self-determination or freedom which is found in all the corners of the material universe, and which living beings possess to a supreme extent. Biology also needs, in addition, holistic determination, the German Ganzbestimmung, since one of the characteristics of life phenomena is the organize. Causation and determination, causalism and determinism too like partial subordination of the parts to the whole. It further needs statistical determination, as actually the adequacy of means to ends is never necessary but only statistical. Besides, biology cannot dispense with reciprocal action, which within the organism is characteristically synthetic or integrative, and which plays such an eminent role in evolution through selection, and, of course, biology cannot forget efficient extrinsic causes, as living beings are never entirely free from the compulsive and often almost one-sided actions of their environment. Thus the entire spectrum of categories of determination seems to be used in biology and, a fortiori, in the cultural sciences, which ontologically, not historically, presuppose biology even if they are not reducible to it. A detailed investigation of the interconnections among the various forms of determination would show more clearly that they can be ordered according to their increasing complexity, in such a way that all but the first two, quantitative self-determination and causation, can be rooted to the lower types. We would thus have a scale of degrees or levels of determination, each characterized by a peculiar trait of its own, but grounded on the lower levels. Hence it is not a question of choosing one type of determination at the expense of others, by decreeing that the chosen category shall reign undisputed in all sectors of reality. Like all monistic solutions, this one is too simple to be adequate. Unlike dogmatic philosophies, the philosophical examination of modern science requires us to realize that a rich assortment of types of lawful production, or determination, is actually employed in the description and explanation of the world, that they all have an ontological counterpart, though not necessarily in the same sectors of reality or to the same extent in all sectors. This rather proofless sketch of a theory of levels of determination was only meant to point out the modest but as yet indispensable place of causation in the wider context of general determinism. 1.5. The essential components of all types of determinacy, productivity and lawfulness. 1.5.1. The principle of lawfulness or orderliness. If the philosophic concept of determination is wider than both the usual acceptation of this word in science and the causation concept, then causal determinism can only be a special type of determinism in the broad sense, although most authors 22 identify them. But what are the essential marks of determinism in the broad sense? According to some philosophers, determinism only states that everything depends on conditions and happens only when these conditions are met. 23. But the dependence upon conditions might be regular or not. If conditionalness is regular, i.e., if it fits definite, not necessarily unchanging, patterns, then it seems preferable to call it lawfulness, that is, conformity to law. 24. And this is the type of conditionalness we are interested in, because it is what science seeks to establish. Now, the principle of lawfulness may be worded as follows: there are laws. 25. And the principle of universal lawfulness, a stronger postulate, may be taken to read thus: every single event is lawful, i.e., is determined in accordance with a set of objective laws whether we know the laws or not. Or, again, every single fact is the locus of a set of laws. 26. Note that, in this wording, the principle of universal lawfulness does not assert that facts are determined by laws, but in accordance with laws, or simply lawfully. Thereby the idealistic doctrine is avoided, according to which natural and social laws are not the immanent form of facts, but prescribe them of extrinseco. 27. There is no rule of causation and determination, causalism and determinism. 23. Laws do not determine anything, they are the forms or patterns of determination, and this is one of the reasons why determinacy is not synonymous with lawfulness. Thus, for example, the constraints to which a dynamical system is subjected contribute to the determination of its motion, but Gauss and Hertz's principle of least constraint does not determine the motion along the corresponding least curvature path, it is just the form of the action of the constraints on motion. The principle of lawfulness, however, does not require that every individual phenomenon should always occur in the same way whenever certain conditions are fulfilled. Universal lawfulness is consistent with individual exceptions, with occurrences in a given low percentage of cases. Individual irregularity in some respects is consistent with collective regularity, i.e., with the individuals concerned fitting a collection having laws of its own, qua collection. Statements of statistical law apply to situations in which there are several alternatives, and exceptions are nothing but the least frequent alternatives. Moreover, the property of being exceptionless, or, rather, almost exceptionless, belongs not so much to facts as to statements about facts. Indeed, statements of statistical law are often made with a high accuracy, and the probability of their being true can be increased almost indefinitely. Finally, the principle of lawfulness is not committed to a specific form of determinism, such as causal determinism, or mechanical determinism, contrary to what Peirce 28 stated in a famous paper which is still held in awe in some quarters. In short, since the chief aim of science is the search for, explanation, and application of laws, if we wish to build an ontological theory of determination having a scientific ground. 24. A clarification of meaning. We have to qualify bare conditionalness as the peculiar mark of determinism. We have to admit that not mere conditionalness but regular conditionalness, that is, lawfulness, is an essential component of general determinism. Still, lawfulness is insufficient. 1.5.2. The genetic principle. Although it is commonly held that determinism is nothing but the belief in the absolute necessity of laws, 29. Determinism should mean more than lawfulness. In fact, despite Schopenhauer's naive belief to the contrary, laws are conceivable which could govern the appearance of things, or the emergence of properties, out of nothing. Moreover, statements of such laws, and even their precise mathematical formulation, have been propounded by the inventors of the so-called new cosmology, or steady-state theory of the homogeneous universe. This theory involves the hypothesis of the continuous spontaneous creation of matter ex nihilo. 30. And this is not precisely what is usually meant by respecting scientific determinism, even in its widest sense, for the concept of emergence out of nothing is characteristically theological or magical, even if clothed in mathematical form. In order to build a definition of determinism both elastic enough to admit new categories of determination and strict enough to exclude irrational and untestable notions, such as creation out of nothing, I propose to combine the principle of lawfulness with that of productivity, that is, the ancient principle according to which nothing comes out of nothing or passes into nothing. 31. An alternative formulation of this principle is, there are neither absolute beginnings nor absolute terminations, but everything is rooted to something else and leaves in turn a track. Causation and determination, causalism and determinism. 25. In something else. For the sake of brevity, this old materialistic principle will be called the genetic principle. The genetic principle is consistent with the principle of lawfulness, on which it puts a restriction, but is independent of it. In fact, everything might be the outcome of a process and might in turn give rise to other events, yet not in a lawful way. Thus, if we were to believe intuitionists, the processes of artistic and intellectual creation are lawless, even though every stage in them is the outcome of a preceding state of the individual and has in turn definite consequences. 32. Needless to say, the genetic principle is rejected not only by theologians but also by subjectivist philosophers, whether idealistic. 33. Or sensationistic. 34. It is essential for them that the world, even if fluent, be barren without the assistance of some psychic entity. That is, both transcendentalism and subjectivism may grant that events follow one another, but not that they are produced by one another. They may deny lawfulness, as Plato did, or grant it, as Hume did. What they cannot accept is the hypothesis that there is, in the external world, a power of originating anything. Transcendentalists and subjectivists tend therefore to reduce determination to succession, whether uniform or not, without production. 1.5.3. The principle of determinacy. Our definition of general determinism will then be the following. Determinism in the large sense is that ontological theory whose necessary and sufficient components are the genetic principle, or principle of productivity, according to a clarification of meaning which nothing can arise out of nothing or pass into nothing, and the principle of lawfulness, stating that nothing happens in an unconditional and altogether irregular way, in short, in a lawless, arbitrary manner. The two principles can be conjoined to yield the following sentence: everything is determined in accordance with laws by something else, this something else being the external as well as the internal conditions of the object in question. This statement may be termed the principle of determinacy. It is a philosophical assumption of science confirmed by the results of scientific research. It clearly cannot be refuted, since future investigation is expected to confirm it wherever it may now seem to be falsified. Any theory of structure or change or both respecting the principle of determinacy will hereafter be called deterministic. The causal principle is a particular case of the principle of determinacy. it essentially obtains when determination is effected in a unique or unambiguous way by external conditions. General determinism, as here conceived, allows for causal, mechanical, statistical, teleological, and other kinds of determination, such as the qualitative change brought about by the increase or decrease in quantity, the so-called struggle of opposites, etc. The sole kind of determinism excluded from our definition is fatalism, because it violates the principle of lawfulness, since the al-1 determination by virtue of some fatum is presumed to occur no matter what the prevailing conditions are, and entails moreover a transcendent agent, see Sector 4.3. The richer kind of determinism outlined in the foregoing description requires only productivity, or genetic connection, and legality, or conditionalness and regularity. General determinism does not restrict a priori the various forms that change and the scientific laws of change may assume. 1.6. Causation and determination, main views. As is well known, the most diverse stands have been taken with regard to the causal problem, from the flat rejection of the causation category to the assertion of its coinciding with determination. All of them belong to one of the following: causation and determination, causalism and determinism. 27 classes: causalism or paneitism, semi-causalism or hemiitism, and acausalism, or anaitism. Although we shall examine them all in detail in the course of this book, it will be convenient to give here a brief characterization of each of these groups of theories and of their main varieties. Causalism. A. According to the traditional theory, often wrongly credited to the founders of modern mechanism, causation is the sole category of determination, so that science is coextensive with causality. On this view, no scientific law or explanation is possible that does not hinge on the causation category. This is probably the most widespread belief, from Aristotle, who wrote that what is called wisdom is concerned with the primary causes and principles. 35 to Claude Bernard, who gave the name determinism to the proximate or determinant cause of phenomena. 36. B. According to the rationalistic doctrine, the causal principle is a necessity of thought, Denknotwendigkeit, and a priori regulative principle, hence a presupposition rather than a result of science. This is the opinion of Leibnizians, to whom the causal principle is nothing but a form of the principle of sufficient reason. Schopenhauer took this belief over from Leibnizianism. It is also the belief of Kantians 37, who assert that a clarification of meaning causal bond is synthetic, in the sense of being verifiable in experience but not derivable from it nor further analyzable, and that the causal principle could never be refuted by any possible experience. It is nothing but the demand of understanding everything. 38. Semi-causalism. A. The eclectic theory recognizes the validity of causation in certain domains, for example, in macrophysics, along with the unrestricted validity of other categories of lawful production, such as the statistical or the teleological ones, in other domains, without, however, establishing links among the diverse categories of determination and without acknowledging the possibility that several of them may concur in one and the same process. This gnomic pluralism is quite widespread among physicists. 39. B. According to the functionalist or interactionist theory, the causation category is a particular case of the interaction or interdependence category. On this doctrine, it is always a sheer abstraction to disentangle simple, linear, cause-effect bonds from the universal interconnection or interdependence, Zusammenhang, which has an organic character. This abmelon is typical of romantics and is shared by most dialectical materialists. Causation and determination, causalism and determinism. 29. C. General determinism, or neodeterminism. The theory advocated in this book asserts in this connection that causation is only one among several interrelated categories concurring in real processes. On this view, the causal principle has a limited range of validity, being no more and no less than a first-order approximation. Acausalism. A. The empiricist theory reduces causation to external co-unction or success, ion of events, or, rather, to the concomitance or the temporal sequence of experiences, it may grant the lawfulness of phenomena but asserts the contingency of qualities and of the laws themselves, regarding the latter as nothing but rules of scientific procedure. Empiricism holds that the notion of causation is an episode in the history of ideas, an outdated fetish that is gradually being replaced by functional laws, Mach, or by empirically found statistical correlations, Pearson, or, in general, by probability laws, Reichenbach. According to Russell Forty, the law of causality, like much that passes muster among philosophers, is a relic of a bygone age, surviving, like the monarchy, only because it is erroneously supposed to do no harm. b. The indeterminist doctrine denies every lawful link among events and qualities. In particular, it does not recognize the existence of causal bonds, and asserts that events just happen, and that qualities are mere idiosyncrasies, or characteristics that, being loose, might have been different. This extreme development of empiricism does not seem to have been systematically defended by anybody. 1.7. Conclusions. As may be gathered from what has been said in the foregoing, the target of my arrows will not be the causal principle but only the claim that causation is the sole category of determination and that, as a consequence, the causal principle enjoys an unlimited validity. In fewer words, I will not argue against the notion of causation but against causalism. The theory to be worked out in the following pages belongs. A clarification OJ meaning therefore to the group of theories named in Sector 1.6 semi-causalism. It is specifically characterized by the following theses, which it will be my purpose to substantiate in the course of the present work. Causation, efficient and extrinsic, is only one among several categories of determination. There are other types of lawful production, other levels of interconnection, such as statistical, teleological, and dialectical determinacy. In real processes, several categories of determination concur. Purity in types of determination, such as purity of causation, is as ideal as any other kind of purity. The causation category, far from being external to other categories of determination, is connected with them. Thus multiple causation leads to statistical determinacy, the latter may in turn lead to quantitative self-determination, and reciprocal causation is interaction or interdependence. The causal principle holds approximately in certain domains. The degree of approximation is satisfactory in connection with certain phenomena and very poor with regard to others. Causal determinism, without being altogether erroneous, is a very special, elementary, and rough version of general determinism. Before examining in more detail the pros and cons of the doctrine of causality, and before suggesting how to repair it, we shall have to recall and analyze some of the statements of the causal principle. Formulations of the causal principle. In the present chapter we shall be concerned with listing and analyzing some typical definitions of causation, that is, we shall examine various statements of the causal principle. Such an examination of definitions is indispensable in every rigorous approach to the causal problem, although it is entirely overlooked in many works on the subject and, indeed, in every scientific treatment of philosophic questions. For, although philosophizing is not restricted to framing and discussing definitions, the lack of precise, that is, sufficiently precise definitions facilitates wild speculation. 2.1. Definitions of cause. 2. The Aristotelian teaching of causes. Almost every philosopher and scientist uses his own definition of cause, even if he has not succeeded in formulating it clearly. The earliest and most systematic codification of the meanings of this thorniest of words we owe to Aristotle, who elaborated Plato's scattered ideas on causality. According to the Stagirite II and to the peripatetic schoolmen, a sin is opposite to this, namely the purpose or good, for this is the end of every. 3.1. 32. A clarification of meaning of cause was not sufficient for the production of an effect, whether in nature or in art, industry. 4 kinds of cause were instead needed, namely, the material cause, the scholastic causa materialis, which provided the passive receptacle on which the remaining causes act and which is anything except the matter of modern science, the formal cause, causa formalis, which contributed the essence, idea, or quality of the thing concerned. 3. The motive force or efficient cause, Causality, that is, the external compulsion that bodies had to obey, and the final cause, causa finalis, was the goal to which everything strove and which everything served. The first two were causes of being, the efficient and the final causes were causes of becoming. The Aristotelian teaching of causes lasted in the official Western culture until the Renaissance. When modern science was born, formal and final causes were left aside as standing beyond the reach of experiment, and material causes were taken for granted in connection with all natural happenings, though with a definitely non-Aristotelian meaning, since in the modern worldview matter is essentially the subject of change, not that out of which a thing comes to be and which persists. 4. Hence, of the four Aristotelian causes only the efficient cause was regarded as worthy of scientific research. Some of the grounds for the Renaissance reduction of causes to the Causality were the following: a. It was, of all the four, the sole clearly conceived one; b. Hence it was mathematically expressible; c. It could be assigned an empirical correlate, namely, an event, usually a motion, producing another event, usually another motion, in accordance with fixed rules. The remaining causes, on the other hand, were not definable in empirical terms, hence they were not empirically testable. D. As a consequence, the efficient cause was controllable; moreover, its control was regarded as leading to the harnessing of nature, which was the sole aim of the instrumental, pragmatic, conception of science advocated by Bacon and his followers. As has been usual since the beginnings of modern science, we shall hereafter restrict the meaning of the term cause to efficient cause, or extrinsic motive agent, or external influence producing change, in contrast to other kinds of cause, such as final, internal, or causa sui, etc. The classical definition of efficient cause was, of course, put forward by Aristotle. It is the primary source of the change or coming to rest. Example: the man who gave advice is a cause, the father is cause of the child, and generally what makes of what is made and what causes change of what is changed. 5. The efficient cause is, in short, the agent producing some change in what is, erroneously, imagined to be a patient, upon which the cause acts ab extrinseco, from the outside. 2.1.2 Galileo's definition oj cause. Modern thought, while retaining the externality of causation, has preferred other definitions of the efficient cause. One of the clearest of them all was given by Galileo, who defined the efficient cause as the necessary and sufficient condition for the appearance oj something, that and no other is to be called cause, at the presence of which the effect always follows, and at whose removal the effect disappears. 6. Hobbes, 7, in many ways a follower of the great Florentine, distinguished carefully between the causa sine qua non, or necessary cause, and the complex of sufficient causes, which may alternatively produce the same effect. Galileo's definition is at first sight satisfactory, especially as it has not only an ontological but also a methodological meaning. Indeed, it states a practical criterion for deciding whether a factor is a necessary cause or not, namely, its removal. But a closer inspection shows its inadequacy in the following respects. First, the definition involves an indefinite number of factors, as it includes in the cause anything or event that could make some difference to the result or effect, and, since indeterminateness or haziness is inconsistent with causal determinacy, the above definition of cause does not look adequate. Suppose we used it in the context of the theory of the universal causal interconnection, too often erroneously called determinism, then, since every event would be regarded as the effect of an infinity of events of the most diverse kinds, Galileo's definition of cause would lead to its identification with the state of the whole universe immediately preceding the event in question, which is actually how Laplace conceived of causes. But this would render the concept of cause practically worthless, for causal analyses would then be impossible owing to the infinity of factors, all of about the same importance, presumably constituting the cause. And the empirical test of causal hypotheses would be equally impossible, since the removal of any of the infinite factors would make some difference. hence would require the control of an infinity of parameters. The second reason why Galileo's definition of cause is no longer entirely correct is that in a sense it is too general, so much so that it may apply to statistical, dialectical, and other processes, since what it states is the set of conditions, both necessary and sufficient, for the occurrence of an event of whatever kind, produced by a process of any sort, whether causal or not. Galileo's definition is, in fact, a statement of regular conditionalness which in Sector 1.5 I was recognized as a necessary component of all kinds of determinacy. The vagueness of the definitions of causal bond current until formulations OJ the causal principle 35 about 1 century ago has prompted the framing of more precise, and consequently more schematic and abstract, formulations of the causal principle. Let us examine some of them, but let us begin by stating the general conditions that any adequate formulation should meet. 2.2. General features of any formulation of the causal principle. The following sentences are sometimes regarded as correct formulations of the causal principle: C, therefore E, R. E because C. These forms are not, however, adequate to pour causation into. First, they have the forms of explanatory statements. The terms therefore and because in them may suggest that a reason rather than an agent is involved in the causal bond. In the second place, they assert not only a bond between C and E but suggest also the existence of both. As soon as the values of the symbol C and E are specified, the forms 1 and I become propositions that may be understood as singular factual statements. Now scientific laws and, a fortiori, principles of scientific ontology are not singular factual statements in the sense that they refer to matters of fact. They are, on the other hand, general hypotheses, and, moreover, of the conditional form. It was recognized long ago that a scientific law does not express what happens but what would happen if certain conditions were met. 8. The hypothetical status of law statements, that is, of the conceptual reconstructions of the patterns of being and becoming, is apparent from the fact that they apply to more or less idealized models of reality, even though they are supposed to refer to concrete pieces of reality. In other words, the referent of a nomological statement may be real, but its range of exact validity consists of a set of ideal cases only approximately coincident with real situations. Consider, for instance, the most general physical law, namely, the principle of conservation of energy, which can be stated in the following way: if a system is isolated, its total energy is conserved. Or, in the subjunctive, if a system were isolated, its total energy would be conserved. These propositions are deemed to be universally true, except perhaps in the case of quantum virtual transitions. Even if perfect isolation in every respect is nowhere to be found, the principle does not assert the existence of isolated systems, and consequently it does not contradict the assertion of their factual inexistence. In general, while statements of matters of fact, singular factual statements, like the sun is shining, can be categorical, law statements are hypothetical. It follows, then, that an adequate statement of the causal principle should not involve the assumption that C actually exists but should instead say that, if C is the case, then E will also be the case. In short, the statement must be a conditional. The emphasis should be on the relation rather than on the relata, as Russell has untiringly insisted, and on the conditions for the occurrence of facts of a certain class, rather than on the facts themselves. And the conditionalness peculiar to scientific lawfulness renders the use of hypothetica is desirable whether in the indicative or in the subjunctive moods. In short, law statements in the non-formal sciences should begin with if. Let us then try the following form: FC, then E, 2, or simply, FC, E.10. In either of these equivalent hypothetical sentences, C and E can be read as designating singulars belonging to any classes of concrete objects, events, processes, conditions, and so on, to be specified as occasion arises. Every specification of the class of facts will, of course, lead from the empty scheme, to a specific law statement. Needless to say, C and E, that is, the referents of the symbol C and E must differ from one another in at least one respect. Let me insist on the warning that C and E should be taken as representing different specific objects, or, rather, particular features of concrete objects, insofar as these objects belong to definite classes. But C and E should not refer to particular things or properties, if the causal principle is to be concerned with differences among existence rather than with existence, with becoming rather than with being. And C and E should refer to a limited number of features, and not to the unlimited richness of real events, if the principle is to take on a verifiable form. That is to say, C and E stand for kinds of individual, specific, concrete events regarded in definite respects. If preferred, C and E designate specific events insofar as they belong to classes, else we would not be dealing with the skeleton of a general law, but with a bare statement of fact concerning singulars. Now, from a logical point of view, C and E may be regarded either as individual or as propositional variables. In the former case, 2 is an incomplete framework, whereas in the latter it is just a compound proposition. It may be convenient to regard C and E as kinds of free variables, but then, in order to obtain from 2 a proposition, a statement with a definite truth value, hence a sentence capable of being verified or refuted, we have to specify the range of the terms involved, i.e., we have to affix a quantifier to 2. This will now be done. 2.3. The constant conjunction formula of causation. Let us then regard the formulations of the causal principle as stating relations among variables C and E, symbolizing kinds, classes, of facts, or rather definite features of facts. Now, with regard to a relation there are the following possibilities: that it holds sometimes, whether in a fixed or in a variable percentage of cases, or that it holds always, i.e., for all the values of the variables. The usual interpretation of the causal principle is obviously inconsistent with the former alternative. The causal connection is supposed to hold universally, hence, the causal principle must assert the exceptionless repetition of E whenever C is the case. Consequently, the word always, the all operator, must be added to 2, if it is to become a statement of the causal principle. This leads us to the sentence: if C, then E always, 3, or, what is equivalent, for all C and E, if C is the case, then E is the case. 3. This general conditional is often regarded as the precise formulation of the vulgar statements same cause, same effect, or every event has a cause, and this cause is always the same, which have the shortcoming of emphasizing the sameness of causes and effects instead of the constancy of their relation. Needless to say, the word always in 3 must not be taken as meaning forever, but in all cases, or without exception in the given universe of discourse, or generally. The time concept is excluded from 3. We are still in the realm of being, or, if preferred, in the domain of timeless logical relations. We are not yet in the domain of process. An analysis of 3 must now be performed, in order to ascertain whether, and to what extent, it does convey the core meaning usually attached to the causal principle. It turns out that the following concepts are contained in 3: conditionalness, what may be called existential succession, and constancy. Let us treat them separately. Conditionalness. From an ontological point of view, the terms IFC state the clause S, or condition S, for the occurrence of E. In other words, they assert that E occurs provided C happens. But conditionalness is not peculiar to causal lawfulness, it is a minimum requirement to be fulfilled by any kind of law, whether of the causal type or not. Lawfulness may, indeed, be defined as regular conditionalness, see Sector 1.5. The unlawful, on the other hand, is by definition the unconditional or arbitrary, that which exists or happens no matter what the conditions or the circumstances are. LL. Formulations of the causal principle. 39. Remetry, or existential succession. The effect E will appear only provided the conditions summarized by C have been fulfilled, not however necessarily after C. To employ a term of which traditional philosophers are fond, the cause is existentially prior to the effect but need not precede it in time. Indeed, so far nothing has been said of a time delay between C and E. Formula 3 does not contain time, a point that will be dealt with in detail in 3.2. The priority of cover E, the unsymmetrical dependence of the effect upon the cause 12 together with the uniqueness pointed out above, is conveniently symbolized in the form CIE, which should not, however, be understood as logical implication, since the causal connection is a synthetic, not an analytic, connective, and has consequently nothing to do with logical, analytic, necessity. Point 13 Constancy. If C is the case, E will ensue invariably. This is what the all operator always in 3 means. Our statement does not assert that the existence of C may entail that of E, or that, given C, E will ensue in a certain percentage of cases. It asserts, on the contrary, that the connection obtains invariably. Now, constancy and uniqueness make up necessity as defined in Secretary I.2. I, hence, 3, asserts that the causal bond is conditional, unsymmetrical, and necessary. Yet should the concept of necessity be included in an adequate formulation of the causal principle? The traditional answer is, of course, in the affirmative. Still, nowadays we would hardly accept any of the traditional meanings attached to the word necessity, which are repugnant to both modern science and modern philosophy. Indeed, the traditional and also the popular notion of necessity identifies it with either a. Unconditionalness, that is, the quality of that which occurs under all circumstances, whether or not certain conditions are met, or b. Passive obedience to an external or even transcendent power that does not lie in the very nature of things, or, finally, c. Want not too different from human needs. Empiricism duly reacted against these anthropomorphic views, reducing the valid use of necessity to mean lack of exception, 14 or regularity in the sense of prestatistical science. But there is no point in employing two words for designating a single concept. If the notion of necessity is stripped of its anthropomorphic and fatalistic associations, it reduces either to efficient causation as Spinoza 15 had implicitly proposed, or to constancy and uniqueness, as agreed before. So far, so good. The statement if C, then E always is shown, upon analysis, to contain three notions that are usually associated with causality: the conditionalness peculiar to lawfulness, the existential priority of the cause over the effect, and lack of exception. But are these traits enough to describe causation unambiguously? 2.4. Criticism of the constant conjunction formula of causation. 2.4.1. The uniqueness of the causal bond, neglected in the previous formula. The first objection that can be raised against 3, as an adequate formula of causation is that it does not account for the uniqueness of the causal bond. It does not say that there is A, B, C, C, E. Fig 2. A. The causal nexus is unique. B. The same final statistical distribution F can be attained from a number of initial states. C. Several means may be employed by an organism to attain a given goal G that is invariant under changing conditions, within limits. A one-to-one correspondence between C and E. Indeed, in IFC, then E always, the term C may denote any of the sufficient causes, hence the formula makes room for multiple causation, see Sector 5. I. On the other hand, simple causation is characterized by the I reciprocal correspondence between the cause and the effect, that is, the relation between C and E is such that there is a single E for every C and vice versa. The existence of E follows, not necessarily in time, in a unique or unambiguous way from the existence of C, or, again, E is a single-valued function of C. Unlike conditionalness, which is a generic trait of scientific law, uniqueness, or lack of ambiguity, is absent from certain kinds of law, such as statistical regularities, which establish many-to-one connections between causes and effects. Uniqueness is a characteristic, though not an exclusive, trait of causation. The uniqueness of causation, often described as the rigidity of causal determination, is to be contrasted to the supplesse of statistical determination, largely insensitive as it is to precise details, such as the initial states of the individual components of a mass of gas. This unambiguous character of the simple causal bond is also to be contrasted to the so-called plasticity of teleological determination, in which a given goal may be attained through a whole range of alternative means, see Fig. 2. If only necessary and sufficient, instead of just sufficient, factors are to be regarded as antecedents in a causal connection. Preface to the third edition. Preface to the third edition 4242. The then always has usually been regarded by empiricists as exhausting the meaning of causation, hence as the correct statement of the causal principle. Thus 19 wrote that every general proposition of the form C causes E is equivalent to a proposition of the form whenever C, then E, where the symbol whenever must be taken to refer, not to a finite number of actual instances of C, but to the infinite number of possible instances. And Reichenbach 20 in another influential book, stated that by a causal law the scientist understands a relation of the form if-then, with the addition that the same relation holds at all times. In agreement with the empiricist tradition, he held that the meaning of the causal relation consists in the statement of an exceptionless repetition. 21 As may be seen, contemporary empiricists have not improved Hume's definition of the causal relation as constant conjunction, as the constant union betwixt the cause and effect, 22 which would give us what James 23 called a world of mere witness, of which the parts were only strung together by the conjunction n. 2.4.3. Inadequacy oj the constant conjunction formula. It is high time to put the constant conjunction view of causation to the test. This can be done by giving values to the bound variable C and E, seeing whether the resulting singular propositions are actually causal or not. Take wars cause worries, on the one hand, and red apples are sweet, on the other. The former is an openly causal proposition, whereas the latter asserts a correlation, for nobody would be prepared to regard a quality, like redness, as the cause of another quality, like sweetness. Still, both propositions fit the general formula IFC, then E always. This counter-example should suffice to indicate that the Humean formula of causation is not specific enough to be regarded as an adequate conceptual reconstruction of the causal bond. The chief reason of the inadequacy of the Humean formula is that it is too weak. It expresses a relation, not a connection. By the assertion that if C, then E always only a constant relation between two terms is meant, an invariable correlation between events that are loose and separate, conjoined but not connected as the Humean description runs. The Humean formula expresses, indeed, the conditionalness, unsymmetry, and lack of exception that characterize the causal link, but it accounts neither for the uniqueness nor for the genetic character of the relation between C and E. It does not convey the productivity or efficacy of causation. It does not, in short, say that the effect happens to be produced by the cause, but only that it is regularly conjoined to it. The correlated variations of the elements in a structure fit the Humean formula of causation. Yet, a law of correlation is not a causal law, because it does not state that a given entity, or a change in it, is produced by another entity, or by a change in it, but just that the two are regularly associated. Thus hair on the one hand and teeth or horns on the other are often correlated with one another. 24 The two arms of a lever are rigidly associated, but are not causally connected with each other. Similarly, the sides and angles of a triangle determine each other in a rigid, unique, way, yet not in a causal way. In either case the genetic, productive element is absent, and this productivity is chiefly what renders the cause-effect connection essentially unsymmetrical. There is more to it. Most statements in pure mathematics fit the if-then-always formula. And it would be hard to assign to mathematics the job of accounting for causal connections. Uninterpreted mathematical formulas do not refer to the external world, but constitute a world by themselves. Mathematical objects are certainly a product of human activity and may be correlated with material processes by way of rules of correspondence, but in themselves mathematical objects lie outside change, they are immutable, and in particular they have not the power of changing on their own account. 25. Productivity is as absent from mathematics as from the Humean formula of causation. Besides being ontologically defective, Hume's celebrated criticism of the efficacy of causation can be shown to be circular. 26. In fact, it rests on the following assumptions: a. Sense impressions are the sole relata to be considered as fits an empiricist theory. b. Sense impressions are momentary, that is, unrelated to either past or future. c. Since the past is no longer actual, it cannot act upon the present, so that every event is a fresh entity having no connection with entities existing in the past, a consequence which, if consistently developed, should lead to the conclusion that the world is created afresh at every instant in some mysterious way. Consequently, Hume presupposed what he set out to prove, namely, that there is no connection between past and future. In other words, his DISP proof of productive causation is circular. The empiricist reduction of causation to regularity is grounded in the original sin of empiricism, namely, the identification of truth with its criterion, the reduction of the meaning of a proposition to the mode of its verification. The road is short. It is first stated that the sole test of causation is the observation of constant conjunction. 27. Then, on V. Wittgenstein's verifiability doctrine of meaning, it is concluded that the meaning of causation is exhausted by regular association. Now, it is indisputable that, in order to test hypotheses concerning any kind of facts, the examination of a large number of similar instances is very convenient. That is, whenever possible, it is desirable to study large collections or series of, almost, repetitive phenomena, that is, repetitive in some respect. But, apart from the fact that this is not always possible in practice, such a sound methodological prescription does not entail that, in causation equals regularity. Such a reduction involves a confusion of epistemology, and, more particularly, of scientific methodology, with the theory of the most general traits of reality, namely, ontology. Likewise, the recognition of the fact that every criterion of material existence involves sensing, acting, and judging subjects does not imply that every existent is dependent upon some sensing, acting, or judging being. In summary, the reduction of causation to regular association, as propounded by Humeans, amounts to mistaking causation for one of its tests, and such a reduction of an ontological category to a methodological criterion is the consequence of epistemological tenets of empiricism, rather than a result of an unprejudiced analysis of the laws of nature. 2.5. Causation as necessary, constant and unique. Production \v hat we need is a statement expressing the idea common to both the ordinary and the scientific usage of the word that causation, far more than a relation, is a category of genetic connection, of change, that is, a way of producing things, new if only in number, out of other things. This efficacy or productivity of the efficient cause. 28. This dynamic character of the causal connection left aside in the Humean formula, is what we shall try to express in a third approximation. Let us try the following proposition: if C happens, then, and only then, E is always produced by it. 5. Translated into the categorical mode, this statement may be worded as follows: every event of a certain class C produces an event of a certain class E. These sentences are refinements of the vulgar maxim the same cause always produces the same effect, or of the even shorter C always brings forth E. Unlike, 4, the last statements go beyond asserting a mere constant and unique, that is, a necessary, conjunction. They say that the effect is not merely accompanied by the cause, but is engendered by it in conformity with both the ordinary and the scientific usage. Contrary to C. What Hume 29 and his followers have maintained, I am here rejecting the identity of production and causation, for, as science shows us and as is abundantly argued at other places of this study, some things are produced or originated in a non-causal way. Causation is a particular case of production, the latter need not be restricted to causal production or to any other special form of generation. 3. According to 5, something, e, is brought forth by something else, c, in a necessary, constant and unique, manner. The following concepts, usually regarded as essential components of the causation category, are included in the proposition. 5. Conditionalness, uniqueness, one-sided dependence of the effect upon the cause, invariability of the connection, and productivity or genetic nature of the link. Other formulations of the causal principle have been proposed, and there may be better ones than 5. But presumably most of the alternative formulations of the principle of causation either are reducible to 5, or are not rigorous enough, or contain some extra causal concept, as will be made plausible in what follows. Therefore I propose to employ the statement if C happens, then, and only then, E is always produced by it as an adequate formulation of the causal principle until new notice. Let us now investigate whether further specifications are likely to lead to better formulations. 2.6. Supposed further refinements of the necessary production formula of causation among the statements that are at first sight more precise than 5. The following is noteworthy: if C happens under the same conditions, then, and only then, E is always produced by it. 6. Or, in the categorical form, the same cause, under the same conditions, always produces the same effect. Or, again, other things being equal, the same cause always produces the same effect. Is 6 really better than 5? In order to answer this question we must distinguish two cases: the conditions and the cause are interdependent, or they are independent from each other. If the conditions or circumstances are connected with C, if together with C they constitute a single causal complex C, then not much has been gained with the qualification except that it is now explicitly stated that the cause is not simple but complex. Thus in the almost classical example, if a match is struck, it lights, at least the following conditions must be assumed for the link to hold: that the match be dry, and that there be enough oxygen. But these two conditions, subsidiary or background causes, can be regarded as accompanying the formulations of the causal principle. 49. Primary cause, which is the striking of the match. In fact, the above statement can be remodeled to read: if a dry match is struck in an oxygen-containing atmosphere, it lights. In short, if the conditions are linked to the cause, then C may be taken as the chief or primary cause, necessary but not sufficient, the conditions being the subsidiary causes. It is then the whole complex of determiners which constitutes the necessary and sufficient cause. If, on the other hand, the conditions required for a causal link to obtain are contingent upon the cause, then it may be wondered whether 6 is a strictly causal proposition. Think, for example, of auxin, the vegetal hormone which is growth stimulating when located in the tips of a plant but inhibits growth when placed in the roots. In this case no direct bond exists between the cause, hormone action, and the effect, growth. And whenever a third component is added, which may be as important as the cause while remaining external to it, a non-causal type of determination is at stake. The conditions referred to in 6 may include, not only the environment of the object on which the cause acts, but also the specific properties and the state of the object, as well as its intrinsic processes, and the latter are non-causal determinants, since efficient causes are by definition, see Sector 2.1, extrinsic. Self-movement and the corresponding self-determination are just the opposite of causal determination. Indeed, whatever is spontaneous in some respect and to some extent is not caused, though it is not therefore indeterminate. Hence if the accompanying conditions are contingent upon the cause, formula 6 expresses more than a simple, direct causal bond. The efficient cause involved in it acts in combination with the processes inherent in the object concerned, and the cause must then be regarded as the unchanged aider or triggerer of a process rather than as the necessary and sufficient producer of the effect. In conclusion, if the accompanying conditions are contingent upon the cause, the statement 6 cannot be reduced to 5, but, then, it definitely departs from causality, as it implies that C is necessary but not sufficient for the production of its effect. If, on the other hand, the accompanying conditions are functionally bound with the cause, then 6 reduces to 5. Consequently, 6 cannot be regarded as a better formulation of the causal principle. Undoubtedly, all events are immersed in complex situations. Every cause is embedded in a complex of determiners out of which it cannot be extricated except by abstraction, an abstraction that may or may not work as a first approximation. Moreover, no cause succeeds in effecting a result if it remains, so to speak, indifferent to the proper nature of the object concerned and consequently outside its self-movement, this being the reason why science works and magic does not. Hence formula 6 does fit the nature of things better than the former scheme, only, to the extent to which it actually says more than 5, it is not a faithful reconstruction of causation, since an element of spontaneity or self-determination is then introduced in it. Let us now consider a further supposed improvement over the statement of necessary production. Ever since Leibniz, in a Heraclitean mood, formulated his celebrated maxim that no two things in the material world are identical, that is, the principle of the identity of indiscernibles, both philosophers of change and thoughtful scientists have become more and more convinced that, as Maxwell put it, it is manifest that no event ever happens more than once, so that the causes and effects cannot be the same in all respects. 31 This is why the uniqueness condition is sometimes relinquished, and the causal principle is stated under the form like results under like circumstances, or, more explicitly, similar causes, under similar conditions, always produce similar effects. A translation of the last sentence into the conditional mood would read: if similar causes happen under similar conditions, then similar effects are always produced by them. 7. Does such a replacement of sameness by likeness constitute an improvement over 6? Not at all, as from the start we have pointed out, see Sector 2.2, that the causal connection, being law-like, does not refer to isolated facts, but to facts b. Formulations oj the causal principle longing to certain classes or kinds which takes care of the variations in the individual instances. Russell has explained this point clearly. The law of causation does not state merely that, if the same cause is repeated, the same effect will result. It states rather that there is a constant relation between causes of certain kinds and effects of certain kinds. For example, if a body falls freely, there is a constant relation between the height through which it falls and the time it takes in falling. It is not necessary to have a body fall through the same height which has been previously observed, in order to be able to foretell the length of time occupied in falling. In fact, what is found to be repeated is always the relation of cause and effect, not the cause itself. All that is necessary as regards the cause is that it should be of the same kind, in the relevant aspect, as earlier causes whose effects have been observed. 32 The same holds for all law statements, and their lack of reference to specific events is just what lends them a universal extension. In conclusion, if in all the previous formulations of the causal principle we have understood under C a class of events and under E another class, then the statement, 7, does not constitute any improvement on 5, as it just renders manifest what had been implicit in it. Finally, cautious scientists might object to the all operator in 5. It is not that the word always, or, conversely, never, should never be used in connection with events in the material world, as fortuitism claims. But the legitimate extension of these concepts is really very restricted, in factual, material or empirical, matters more frequently than not. Almost always, s replaces always, s. 33 Consequently the following statement may be preferred to the preceding ones: if similar causes happen under similar conditions, then similar effects are produced b. them in most cases. 8. A clarification of meaning. Who doubts that this principle fits facts more closely than the preceding ones? But what a far cry from the candid and superficial if then always relation. Actually, 8, belongs to the domain of statistical determinacy. In fact, the qualification in most cases designates maximum frequency of occurrence, that is, a value around which all values tend to pack. Thus, a closer approximation to facts has taken us further away from causality. Consequently, the category of causation cannot be regarded as exhausting determination, a conclusion we anticipated in Chapter I, and we would proceed wisely retaining the formula, 5, of necessary production as a faithful schematic reconstruction of causation. 2.7. Retrospect and conclusion. We started by recalling the Aristotelian teaching of causes, finding that, of all four, formal, material, final, and efficient, modern thought had retained only the efficient cause regarded as an agent acting extrinsically. Then we examined Galileo's clear but not altogether distinct definition of cause as the necessary and sufficient condition for the appearance of an event. We found that, far from specifying the causal connection, it was general enough to apply to all types of lawful determination. After that, a more precise and abstract statement was tried, namely, the if-then-always relation, that is, the constant conjunction formula of causation. This Humean enunciation turned out to cover various marks usually attributed to causal determination, save the uniqueness and the genetic nature of the causal link. This purposeful limitation of the Humean formula was criticized for blurring the distinction between correlation and production. Thereafter we tried to remedy the shortcomings of the constant conjunction formula of causation by introducing the concept of uniqueness, I correspondence between C and E, and, above all, that of production as distinct from that of causation. This took us to a refined version of the common maxim same causes same effects, to wit, if C happens, then, and only then, E is always produced by it. This proposition happened to mark a crucial stage in our search for an adequate statement of formulations of the causal principle. 53. The causal principle, as successive attempts to refine it either did not add anything new or took us away from causality into other types of determinacy, self-movement and statistical determination. This was regarded as adding strength to the claim that proposition 5, expressing necessary, constant unique, production, is the adequate formulation of principle of causation even though it falls short of reconstructing the full richness of determination. This does not mean, however, that the statement LJC happens, then, and only then, E is always produced by it, or any other single proposition, can be regarded as covering the whole richness of causation or all the implications of the doctrine, causalism, holding the coincidence of determinacy and causality, except in formal matters. Adequacy does not entail completeness. Thus far I have concentrated on a few verbalizations of the causal connection. In what follows I propose to examine the doctrine of causality, or causal determinism. In the course of this analysis further formulations of the causal principle will be met. Part 2. What causal determinism does not assert. 3. An examination of the empiricist. Critique of causality. Before attempting to discover the valid kernel of causalism we should endeavor to clear up several misunderstandings about it, if only because it is unfair to attribute to a doctrine sins that it has been unable to commit. Hence in this and in the following chapter we shall point out what causality is not, thus imitating Thomas Aquinas's method of remotion to acquire a knowledge of God. In the present chapter we shall analyze some theses on causation that are characteristic of empiricism. We shall do it partly because of their intrinsic philosophic importance, partly because they are shared by many contemporary scientists, which is in turn owing, at least in part, to the simplicity and precision with which such theses can be stated. In contrast to most empiricist analyses of causation, the following treatment will neither rely on a study of the psychological origin of the causation concept, nor restrict itself to a linguistic analysis of it or to a methodological examination of the empirical verifiability of causal hypotheses, a subject on which masterly studies are available. In what follows we shall of course touch on these subjects, but we shall concentrate on causation regarded as an ontological category. Furthermore, it will be taken for granted that countless hypotheses concerning causal connections have been empirically verified, to within experimental error, millions and millions of times. For an assumption of this work is that, to the extent to which the causal principle works, it reflects not only a feature of our cognitive relation with reality, but a trait of reality itself. This accounts for our focusing on T3. II contiguity, an essential component of causation. According to Humeans, the causal principle involves what may be called continuity of action between the cause and the effect, as every discontinuity or interruption in the causal thread would have to be assigned a further cause if non-causal events, such as gaps in a causal chain, are to be avoided. But such a continuity of action, which excludes non-causal events, should not be confused, as it so often is, with spatial contiguity, that is, with the continuous transmission of actions through space, action by contact. It was Hume who not only held that the idea of contiguity in space is one of the essential components of the idea of causation, but went so far as to assert that it was nearly the first of the component parts of the idea of causation. Appearing upon an analysis of the latter, I find in the first place, that whatever objects are considered as causes or effects, are contiguous, and that nothing can operate in a time or place, which is ever so little removed from those of its existence. Though distant objects may sometimes seem productive of each other, they are commonly found upon examination to be linked by a chain of causes, which are contiguous among themselves, and to the distant objects, and when in any particular instance we cannot discover this connection, we still presume it to exist. We may therefore consider the relation of contiguity as essential to that of causation. 2. It is strange that Hume should hold this opinion. For one thing, he was writing precisely in the midst of an era when the idea of action at a distance, doubtless contradictory to contiguity, was triumphant in his own country and beginning to Hume, 1739–174 degrees, Treatise, Book I, Part 3, Sector 2. An examination of the empiricist critique of causality. 59. Conquer the European continent. 3. Gradually overcoming the Cartesian and Leibnizian doctrines of nearby action effected by contact forces through a subtle medium, as well as the Democritean principle that the interaction of bodies can occur only through collision. For this is one of the pieces of evidence in favor of the suspicion that Hume's philosophy of science was behind his own times, being in fact pre-Newtonian. 3.1.2 Contiguity, a hypothesis inconsistent with empiricism. A second, and more important, reason why it is difficult to understand that an empiricist should cling to the belief that contiguity is not only an essential component of causation, but even an indispensable ingredient of a scientific worldview, is that contiguity is not a fact directly ascertainable by experience, but rather, as Hume himself recognized, 5, a hypothesis. Moreover, it is not a hypothesis the consequences of which can be tested with any degree of accuracy. The experimental test of contiguity would require an infinity of observations between any two events at different points in space. The hypothesis of contiguity entails, in short, an empirically unprovable interpolation which, of course, does not diminish its value. In other words, it is the principle of contiguity, rather than the hypothesis of actio ad distans, which Leibniz regarded as barbarous, that is a metaphysical assumption about physical reality. Let us dwell on this point, which has an important bearing on field physics, as the principle of nearby action is embodied in it. The validity of the very concept of field cannot be demonstrated empirically just by measuring field strengths, and this for the following reasons. First, what is measured is not the field strength itself but the force exerted by the field on a test body. For example, in the case of the electric field, the ponderomotive force F equals E is measured, from which the value of the field intensity E is referred on the basis of the knowledge of the electric charge E, obtained from an independent experiment. Second, field strengths E, X, T, are defined but not measured at a given point in space and at a given instant of time. What experiment affords is not a point function E, X, T, but a collection of averages over both a small but non-vanishing field region and a small but non-vanishing time interval, Moreover, owing to the atomic structure of matter, it does not seem possible at present to diminish that volume without limit. 6 In short, the field concept is not an operationally defined one. The validity and usefulness of the field concept are demonstrated, at least in the macroscopic domain, in an indirect way, as is usual with elaborate theoretical concepts, namely, by the far-reaching testable consequences to which field theories lead. And this is not peculiar to field physics, but is a pervasive feature of science. If scientific concepts had to be restricted to operationally defined observables having an immediate empirical content, only a few unintelligible empirical rules would remain in every branch of science, and Mach's ideal of an economical description of experimental facts would be attained. If the hypothesis of contiguity were abandoned in accordance with the requirements of consistent empiricism, all field theories, gravitation, electromagnetism, and mesodynamics, as well as the whole physics of continuous media, classical fluids and elastic solids, would have to be ruled out. Such a surgical policy was actually demanded by Opera 6 C. Heitler, 1954, The Quantum Theory of Radiation, pages 81 fr. An examination of the empiricist critique of causality 6 Itionalism several years ago 7 and is still being suggested by pragmatists who feel that Maxwell's theory of the electromagnetic field is over-descriptive because it overflows the operationist cup. 3I.3 Explicit definitions of causation do not involve contiguity, but our primary concern is not to show that the principle of action by contact is definitely incompatible with empiricism, as in fact it is. Our business is to weigh the claim that contiguity is essential to causation, a Humean idea that has modern followers. 8 If causation is defined as involving contiguity, then the causal principle will of course imply the principle of nearby action, as was the case with Hume's allegedly precise definition of cause and effect. 9 But such definitions, specifying a restricted type of causation, common as they were during the general formulations of the causal principle advanced in the last 2 centuries, see Chapter 2, shows that causation and nearby action are two logically independent categories, hence the subjects of separate principles. Causation is consistent with contiguity but does not entail it. Moreover, contiguity is consistent with the reversal of the causal nexus, in the sense that theories are conceivable in which everything proceeds to proche and proche, as demanded by the principle of contiguity, but in which effects appear before their causes. Finally, and this is usually overlooked by Humeans, any reference to spatial contiguity in the formulation of the causal principle would render it almost inapplicable outside physics. To sum up, causation is consistent with contiguity but does not entail it. 3.2 Does causality involve antecedents? 3.2 Causality is consistent with instantaneous links. The principle of retarded action, or of antecedents, states that there is always a time delay between the cause and the effect, the former being prior in time to the latter, so that, relatively to a given physical system, such as a reference system, C and E cannot be both distant in space and simultaneous. Hume L. L. Schopenhauer 12 and many other students of the causal problem have stated that the time priority of the cause over the effect is essential to causality. Russell asserted that if there are causes and effects, they must be separated by an examination. O.J. The empiricist critique O.J. Causality 63 A finite time interval, 13 and N. Hartman held that causality means only that, in the course of happenings, the later are determined by the earlier. 14 Finally, the philosophic notion of causality that has come to be accepted among scientists in the last 100 years actually entails the idea of a time lag of the effect relative to the cause. However, the principle of antecedents and the causal principle are independent of each other. To verify this assertion, it suffices to recall any of the formulations of the causal principle that were examined in the preceding chapter, particularly the empiricist definition of causation as constant conjunction, Sector 2.3, and the definition of causation as necessary production, Sector 2.5. None of them contains the idea of temporal priority. What they all do state is what we called existential priority of the cause over the effect, Sector 2.3, that is, they all require that the cause be there if the effect is to occur, but they do not entail succession in time. Causality is consequently compatible with instantaneous links, whether at a given point in space, as in the case of the dynamical law force causes acceleration, or among systems placed at different regions in space. The latter case is important, as actions at a distance involving no time delay have actually been imagined by physicists not only before field theories were born but also in some present theories, independently of considerations about causation. Although scientists who affect to ignore philosophy altogether tend to mix up questions of antecedents with the causal problem. The principle of retarded action, or antecedents, was not generally adopted until about the middle of the 19th century. Before that time the hypothesis of instantaneous physical actions, both at a distance and through a medium, prevailed in gravitation theory and in electromagnetic theory. Even the Cartesians, who remained faithful to the principle of contiguity, stuck to the belief that the propagation of light was instantaneous. It was not until the deformations of continuous media were studied by Cauchy, and the concept of electromagnetic field was introduced by Faraday, that the principle of retarded action began to be regarded as a necessary restriction upon the principle of causation in the domain of physics. 16. The recognition of the principle of antecedents was essentially linked with the successes of field theories and entailed a restriction upon the causal principle in the domain of physics, not, however, in domains where no velocities of propagation enter. Special relativity, 1905, finally banished instantaneous links from mechanics in connection with events taking place at different points in space. 17. Paths of light rays. / 6. Position Fig. 3. Event B is to the right of event A, and the two are simultaneous relative to this particular frame of reference. They are causally unrelated, because not even the fastest known signal, a light ray, could bind them. Light rays emerging from points A and B, both to the left and to the right, propagate in space-time along the oblique straight lines shown in the figure. These lines constitute the forward light cones of events A and B. Event A can only act on the events lying inside its own forward light cone, and so for B. 3.2.2. The principle of retarded action. In special relativity we have asserted that the principle of retarded action, rather than being involved by the causal principle, imposes a restriction upon physical causation whenever the former is accepted. This means that the principle of antecedents entails the assertion that there are systems that cannot interact with one another and that, a fortiori, cannot be causally tied to one another. In other words, the joint assertion of the principles of causation and of antecedents restricts the number of possibilities of physical connectedness. In relativity physics, this statement takes on the following special form: as a consequence of the principle according to which all known physical actions are propagated with finite velocities, any 2 points in space-time that cannot be tied to each other by means of the fastest known chain of events, light, are causally unrelated. See Fig. 3. Contrary to what has been claimed 18, this does not mean a violation of determinism, it just excludes as physically impossible certain conceivable causal lines, but it retains all causal chains within light cones. A further radical change in classical ideas about succession in time was introduced by relativity. It was shown that time series are relative, that is, they depend upon the reference system, though not necessarily upon the observer, which is one among an infinity of possible reference systems. Relativity has moreover shown that the time order of certain events can be reversed. Thus two light signals arriving at a certain reference frame, rigid material system, in the order R2, may arrive in the reverse order, 2R, at a different system, in motion relative to the former, see Fig. 4. On the other hand, relativity does not hold that light, or any other physical object, can arrive at a given point before it has been produced. It asserts that the order of production of the successive light flashes coming from a given distant source is unique, only their time differences, An examination of the empiricist critique of causality. 67 time intervals, are relative, that is, differ numerically from one reference system to another. Time reversal is possible only for those pairs of events that, being separated by a distance, do not stand in a causal relation to each other. In other words, relativity admits the reversal of time series of physically disconnected events but excludes the reversal if causal connections, that is, it denies that effects can arise before they have been produced, and consequently does not assert that the past can be changed. If preferred, according to relativity, the time order of causes is relative to the reference system, while causal connections are invariant. That is, duration is relative, and the time order of any two genetically disconnected events E and E can be reversed. As a particular case, E and E may both stem from a single cause, C, as in the example of Fig. 4, but in no case will C happen after either E or E. Moreover, the cause cannot even occur, in relativity physics, at the same time as E and E, for such a simultaneity would entail that a light signal could travel in no time, thereby contradicting the principle of retarded action embodied in relativity. In short, events whose order of succession is reversible cannot be causally connected with one another, at most they may have a common origin. That is, the concepts earlier and later have an absolute meaning for causally connected events and for them alone. Hence, sequences of the Humean type do not involve a unique arrow of time, but genetic chains, whether causal or not, are on the other hand no less than the very substratum often. 19. To conclude, a condition for causality to hold is that C be previous to or at most simultaneous with E, relative to a given reference system. Antecedence is relative in connection with pairs of causally unconnected events, and absolute with regard to events that are causally connected and, in general, genetically linked to one another. The principle of retarded action is independent of the causal principle, and, whenever it is 68. Postulated, it entails a restriction on the possible genetic connectivity of the physical level of reality. Moreover, the mere statement of retarded action, far from being essentially committed to causality, is consistent with non-causal categories of determination. 20. 3.3. Is causation identical with invariable succession in time? 3.3i. The interpretation of causal process as succession of states. Most positivists have held that the concept of causation should be replaced by or actually reduced to invariable, uniform, succession in time. Thus Comte asserted that in the positive, scientific, stage the human mind does not seek to know the intimate causes of phenomena, but only their effective laws, that is, their invariable relations of succession and similitude. 21 Mill stated that the law of causation, the recognition of which is the main pillar of inductive science, is but the familiar truth that invariability of succession is found by observation to obtain between every fact in nature and some other fact which has preceded it. 22 The ground for this claim has been well known since Hume. Only invariable succession and conjunction are shown in experience, a curious sort of experience that ignores active production and reproduction, acknowledging only passive observation. Hence, if philosophy is to be empirical, no other meaning than that of uniform succession can be attached to the causal principle. What experience makes known, is the fact of an invariable sequence between any event and some special combination of antecedent conditions, in such sort that wherever and whenever that union of antecedents exists, the event does not fail to. An examination of the empiricist critique of causality 69 occur. 23 A similar reduction of causation to invariable succession was defended by Pearson 24 and by more recent representatives of positivism. 25 The identification of cause with constant antecedent, of causation with invariable, uniform, succession, has been criticized many times by philosophers. It has been pointed out, for instance, that the reduction of determination to precedence would prevent us from distinguishing the few relevant antecedents in the mass of precedents. However, scientists, concerned as they are in the most interesting part of their work with laws of change, have too often ignored such criticisms. Many scientists still believe, in fact, that every statement of regular and unique succession of events, or every continuous series of states of a system, constitutes a causal law. Thus the following sentence is frequently regarded as a rigorous formulation of the causal principle: the states of a closed system unfold themselves in time in a unique and continuous way. 9. Other times, this or some equivalent proposition is considered as the particular form that the causal principle takes in physics. 26. Since it is difficult to understand how a law of succession of states could be described as causal without further ado, sometimes the ad hoc definitions cause equals initial state, and effect equals final state are added. 27. Thereupon the vulgar maxim same cause, same effect is sometimes replaced by the following formula, which has become quite popular among physicists and philosophers of science: the same initial state is always followed by the same final state. A much exploited illustration of this sentence is Newton's law of motion, namely, force equals mass times acceleration. In this case the initial state consists of the set of values of the positions qo and momenta po of the intervening mass points at a prescribed time. By Newton's law of motion, subsequent states, q, p, follow in a regular, unique, and continuous way from the initial state. But, save in the extreme case of inertial motion, this evolution is not, as required by Io, exclusively dependent on the initial state, qo, po. Instead, usually both constraints and external forces contribute to determining the subsequent states, see Fig. S, and the constraints are not specified in the initial state. Since genuine causes are supposed to be necessary and sufficient for the production of their effects, it is not correct to call initial states causes whenever additional determiners, such as constraints and external forces, are present. The simple case of analytical mechanics shows, then, that causal lines are more than patterns of uniform succession. Likewise, the thermodynamic theory of isolated systems, concerned as it is with successive states that unfold themselves spontaneously, that is, in the absence of external determiners, shows that intrinsic patterns of uniform succession need not be causal. It is easy to see why states cannot have a productive virtue of. An examination of the empiricist critique of causality 7I. Their own. The state of a material system is a system of qualities, not an event or a string of events. Every state is the outcome of a set of determiners, usually causal and non-causal. If preferred, the values of the parameters that specify a state are the result of both inner processes and external connections. Consequently, there can be no action of one state upon another state of a given system. In particular, there can be no causal links among states, nor among any other systems of qualities. States are not causes, but simply antecedents of later states. To regard states as causes amounts consequently to committing the fallacy of the post hoc, ergo propter hoc. 3.3.2. The interpretation of causation as predictive ability. Sometimes a more sophisticated sentence is regarded as the correct formulation of the causal principle, namely, the knowledge of the initial state of a closed system is sufficient for the prediction of its state at any other later time. This is how many contemporary physicists understand causality. 28. However, is first of all incomplete, as the law of motion, and eventually the force function, as well as the constraints and the specification of the surroundings, boundary conditions, are needed besides the initial state in order to perform some prediction. But even if these qualifications are added, the uniqueness that characterizes the causal bond is lost in, since empirical information is never quantitatively exact. Instead of an unambiguous set of values specifying the initial state of the system concerned, observation and measurement usually yield statistical distributions of the relevant variables. This uncertainty in the initial information, which always shows a spread around average values, spoils the Onetto 1 correspondence among neatly defined states. As in classical physics, the theoretical values are supposed to be sharply defined. This is one of the reasons for regarding II as an inadequate formulation of the causal principle. 29. Moreover, all laws, whether causal or not, when framed in observational terms acquire statistical features, but this has nothing to do with the laws at the ontic level, which are not couched in operational terms. The transition from the level of theory to the level of experiment, from the conceptual to the empirical level, takes place when it is a question of verifying a theory, not when its formulation is at stake, see 12.1.2. Besides, I is not an ontological statement, not a proposition concerning the world, but a sentence concerning our knowledge and prognosis of events. If it were correct, but we have seen that it is incomplete, since it refers to initial information and to prediction, it might be regarded as an epistemological partner of an ontological principle, the one about the unique and continuous unfolding of states of an isolated system. Certainly, the knowledge of a certain type of law of nature, alongside a set of items of information, such as initial conditions, makes an almost unique prediction of future states often possible, at least as long as no qualitative changes occur, nor unexpected external perturbations arise, provided we know how to solve the mathematical problems eventually involved in the prognosis. Our prediction may be adequate for limited periods of time. But the causal problem, far from having solely an epistemological side, is chiefly an ontological question. Hence, considerations about knowledge and foreknowledge are out of place in connection with statements of the causal principle. They belong, on the other hand, in statements concerning the verification or the application of law statements, whether causal or not. The empiricist identification of the meaning of an empirical statement with either its predictive usage or the technique by means of which it is put to the test, hence confirmed or infirmed, leads to confusing criteria of determination with kinds of determination, and particularly criteria of causal connection with kinds of causal bond. Thus Rappaport distinguishes three kinds of causality: I, observational causality, the meaning of which would be, watch for the occurrence of A, and you will observe the occurrence of B. 2. Manipulative causality, which is taken to mean, fake A occur, and you will observe B or. An examination TIF. The empiricist critique TIF causality 73 prevent A from occurring, and B will not occur. Finally, 3. Postulational causality, which is said to obtain if B appears to us surprising when we are ignorant of the occurrence of A, and ceases to be surprising when we learn of the occurrence of it. 30. Of course, if the verifiability theory of meaning which underlies the preceding classification is not accepted, then the foregoing kinds of causality are seen not as different types of causal connection but as criteria of causal connection or as techniques for verifying causal hypotheses. To summarize, causation is not identical with any of the tests for it. 3.3.3 Descriptions of change as sequence of states need not be causal. Descriptions of change as time sequences of states need not be causal, that is, need not point to a process whereby certain effects are produced by certain causes according to a given pattern. Moreover, predominantly phenomenological accounts of change need not be intelligible and verifiable descriptions, that is, need not be scientific. They may be mythical or magical, as is the case with the archaic and ancient myths about the successive metamorphoses of fabulous beings. 31. The phenomenalist program of accounting for invariable succession in a purely descriptive way, without inquiring into the mechanism of change, is in fact characteristic of a poorly developed culture rather than peculiar to the positive stage of mankind. Of course, science contains assertions of invariable succession in time. But, first, it does not seem legitimate to call them causal laws whenever they lack the essential component of a productive, genetic, connection, if they just describe uniform sequences without pointing out the causes of the process. Second, science seldom remains satisfied with mere statements of regular succession in time. These are usually the first, not the last, word unless the change concerned actually happens to be purely quantitative. Further laws, underlying the bare fluxus formae and explaining it, are always sought and sometimes even found. Thus the hypothesis of the electromagnetic nature of light explains geometric optics, and the hypothesis of the class struggle is intended to explain certain historical events. Finally, if causation were nothing but uniform succession, relativity could not hold. Indeed, relativity establishes a deep difference between the succession of genetically unconnected events, the time order of which is relative, and causal succession, whose time order is irreversible. Sector 3.2.2. The relativity of the time order of causally unconnected events, as contrasted to the absolute character of the existential, and eventually also temporal, character of the precedence of the cause over the effect, shows that the empiricist reduction of causation to regular succession in time is at least outdated. In short, causation is not exhausted by regular association in time, although causal chains may of course develop in time, or, rather, they engender time, in accordance with fixed patterns. 3.4. Is causation mirrored by differential equations? 1. 3.4 differential equations as mirror images of uniform sequences, a confusion of dimensions of language. If causation were exhausted by uniform, unique, and continuous succession, then differential equations with time as the independent b variable could be regarded as the mirror images of causal laws, just as partial differential equations with space coordinates as independent variables are the adequate mathematical forms for expressing the contiguity characteristic of fields and continuous media. Such is, in fact, a very wide spread belief. 32 Russell once went so far as to state that science, an examination of the empiricist critique of causality 75 scientific laws can only be expressed in differential equations. 33 Quite a deal of boldness was required to utter this sweeping generalization at a time when integro-differential equations, finite difference equations, matrix equations, and other mathematical forms were being introduced everywhere in physics and technology, not to speak of older acquaintances, arithmetic laws such as Mendel's, algebraic laws like Ohm's, or integral principles like Fermat's and Hamilton's. If the empiricist reduction of becoming to uniform, unique, and continuous succession in time is accepted, then the reduction of the mathematics of empirical science to differential equations may follow, on the additional assumption that science should not be concerned with laws of structure. But the stubborn fact is that science uses other mathematical forms as well, which shows that research would have been seriously impaired had it followed the positivistic doctrine, or any other limitationistic policy, in this regard. Every a priori limitation on the possible mathematical forms of scientific laws is at best ineffective and at worst crippling. Experienced scientists know that the mathematical instrument that is chosen in each case to express a given objective pattern depends not only on the sort of phenomena themselves that are concerned but also on the scientist's own mathematical equipment and ability. It is furthermore a commonplace truth that the advances of science elicit the invention of fresh mathematical tools, and vice versa. The advances of mathematics afford in turn a richer and richer assortment of forms that sooner or later are filled with, that is, correlated to, the most varied contents, or at least take part in some scientific theory. To imagine that this two-way flow could someday cease is a mark of unwarranted pessimism. The dogmatic dicta of philosophers have sometimes a large stopping power in connection with the progress of science, but the latter ends always by finding its way. Not only are differential equations not the sole mathematical instruments of science, but they do not even reflect causation, one of the simplest forms of determination. In fact, differential equations, even if duly interpreted in material terms, do not state that changes are produced by anything, but only that they are either accompanied or followed by certain other changes. Just as functions may be used to express constant associations, so differential equations may be employed to express regularly associated, concomitant, changes. Consider the simplest of differential equations with time as the independent variable, dx dt equals jct, which can also be read dx equals f, t, dt. These formulas 34 do not state that the change dx is produced by dt, they merely assert that the variation dx undergone by the property designated by x, during the time interval dt, equals f, t, dt. They should not be read as asserting that the flow of time dt has caused or produced by itself the change dx, since time, far from having productive virtues and far from flowing per se apart from the succession of events, is just the rhythm of process, the order of successives, Leibniz. When a causal interpretation of a mathematical form, whether equation or inequality, differential or not, is reasonable, it has to be added to the mathematical entity. Such a semantic rule of correspondence, attached to the syntactic form concerned, is usually expressed by means of words. In other words, such an interpretation does not belong to the mathematical symbols themselves but to the semantic system of relations linking the signs with the physical, chemical, biological entities in question. Sometimes such an interpretation is not made explicitly but is taken for granted, but it is precisely a job of philosophers of science to unearth hidden assumptions and to distinguish the various dimensions of language. Ampere, who was both a scientist and a meta-scientist, knew this very well, when he argued that the law of the mutual and pairwise action of electric currents, which he had established, was consistent with two different explanatory hypotheses. He was convinced that, whatever the process by means of which electrodynamic phenomena were explained, his formula accounted for the facts. And de Broglie said once that equations remain while their interpretations pass away. This may be, by the way, the chief justification for most present meson field theories. Their equations may finally turn out to have empirical correlates in some section of reality. One and the same mathematical form, such as a differential equation, is then susceptible of different interpretations, contents or meanings. If it is not possible to attach to it an explanation in terms of material processes, it remains a simple matter of fact statement, although it may serve to explain further facts. Consider Fourier's equation of heat diffusion, OU_DO2UTT, OX2. This equation was highly praised by Comte 35 and Mach 36 precisely because, according to them, it does not tell what heat is or why it flows, but is instead limited to telling how it flows. Fourier, on the other hand, had clearly stated that his own work on heat conduction was consistent with different explanations of the mechanism of heat propagation and with different hypotheses regarding the nature of heat. 37 Moreover, as is now well known, the same equation can be used to describe other phenomena as well, such as the transport of materials by diffusion. The moral is simple enough, to wit, syntactic forms may be invariant under the most varied semantic transformations. 3.4.2 Non-causal laws formulated with the help of differential equations. If a more fashionable illustration is required, Schrödinger's wave equation, IH_H.1. 27 TTT, op. will do, as it probably is the most reinterpreted equation that has ever been written. According to the logical empiricist interpretation of quantum mechanics 38, the theory based on Schrödinger's equation is ontologically neutral, and in particular it supports neither determinism nor indeterminism, as it asserts nothing about the real world but everything about measurements on the atomic scale. The theory would, on the other hand, be decidedly indeterministic with regard to the results of such measurements, which are not deemed to be determined by anything. Now, such empirical information is summarized in the if function, often named wave of knowledge, that solves the Schrödinger equation and that, according to the interpretation espoused by most positivists, has only a probability meaning. In other words, the usual, positivistic, interpretation of the quantum theory entails an empirical indeterminacy, although probabilities evolve in a strictly prescribed and unique way according with Schrödinger's equation. An examination of the empiricist critique of causality. 79 Positivists should either drop the orthodox interpretation of the quantum theory or abandon their contention that differential equations of a certain type mirror causation, as the two are incompatible with each other, not to speak of their separate disputability. The identification of causal laws with differential equations that can be made to represent an unlimited variety of types of continuous evolution in time, if the adequate semantic rules are attached to them, has led to a widespread naive solution of the puzzle of quantum mechanics. According to this interpretation, the theory, while renouncing causality as regards things themselves, for example, atomic systems, retains it in connection with the evolution of what is usually regarded as our information, as probabilities themselves, or, rather, probability amplitudes, evolve in accordance with an allegedly causal law, namely, Schrödinger's equation. 39 Mathematical forms say by themselves nothing about material reality, and this is just why they may be used, in combination with semantic rules, to say so much about the external world. The eventual objective content that can be poured into mathematical forms lies entirely in the factual, physical, biological, meaning attached ad hoc to the symbols appearing in them, that is, in the semantic rules. Consequently, the objects referred to by a given theory cannot arise in either the formulations or the representations of a given scientific theory, but only in its interpretations. 40. Whoever accepts the doctrine of the voidness of mathematical structures, and logical positivists are among those who have contributed to clear this point up, cannot consistently maintain that differential equations are by themselves the mirror image of causation nor of any other form of determination. 4. That many features of the material world can be described with the help of mathematical tools is true, and is another matter. But, to restrict ourselves to differential equations, it must be realized that they may be of help in the formulation of both causal and non-causal laws. Thus differential equations of the type A P at equals F, Q, P, T, where Q and P may in turn be functions of T, appear not only in theories having a strong causal component such as classical fluid dynamics but also in statistical theories of non-stationary processes, such as transport phenomena or stochastic chains. In these theories, P usually denotes a probability density, so that the meaning of the foregoing equation, in the context of such statistical theories, is not precisely causal. The simplest and best known illustration of that type of equation is provided by the law of the average rate of radioactive decay, namely, dN dt equals n, which can be derived on the assumption of the mutual independence or randomness of the successive individual disintegrations. Integration of this equation yields n equals no at, which is plotted in Fig. 6. But the same mathematical form is employed to describe the absorption of light in homogeneous media, the decay of the intensity of excitation in neural circuits, the death rate of bacteria under the action of a disinfectant, Daniel Bernoulli's law of marginal utility, and a host of other processes, whether causal or not. \V hat matters in this respect is not so much the mathematical form as the meaning attached to the symbols appearing in it, that is, their interpretation. In the case of statistical theories, initial states are initial probability densities, or frequency distributions, or average numbers, out of which other distributions follow in time, in a unique way, as is the case of the so-called stochastically definite processes, or not, as in the general case. To call cause the initial value of a distribution function specifying, for example, the probability that a system shall be in one or other of a number of possible states, sounds paradoxical. It is, in fact, begging the question. \VE therefore refuse to identify causes with initial states and causation with regular, unique, and continuous succession of states. 3-4-3. Integral equations and teleology. Since the opinion we are examining is so widespread, a further argument may be found useful. Another fact showing the untenability of the contention that all that can be said about causation is stated by means of differential equations of a certain type is that these ideal objects are contained in still wider structures, namely, integral equations. In fact, differential equations can be derived from integral equations, although the converse is not always possible. Thus, for example, the Lagrange equation, dol de Ach equals 0. Probably the most frequently recurring differential equation of theoretical physics, can be deduced from Hamilton's integral principle. 3tl, q, t, dto. G. If one insists on assigning every mathematical form a specific ontological content, why not maintain, then, that integral instead of differential equations are the mirror image of causation? Actually, the opposite has been claimed, namely, that integral equations, and, more specifically, extremum principles, such as Fermat's or Hamilton's, are the mathematical translation of purpose. 42. Is this any better than attributing life to self-regulating material systems like gyroscopes or automatic furnaces, just because they respond to small perturbations in such a way that some property of them, angular momentum and temperature, respectively, is conserved. Moreover, since every differential equation can be rewritten in an integral way, and since from extremum principles certain differential equations are deducible, namely, the Euler-Lagrange equations, that strange opinion might lead to identifying efficient and final causation, or to asserting their interconvertibility, a thesis that has actually been defended 43 and which essentially boils down to confusing final state with goal. Those who, from Aristotle on, insist on attempting to introduce teleology in physics would do well to read Voltaire's Histoire du Docteur Akakia, where he made fun of Maupertuis' teleological interpretation of the least action principle. They might also recall that the multiplicity of means characterizing end-seeking behavior, see Sector 2.4.2, is just the opposite of the uniqueness of processes asserted by extremum principles, provided the integrand satisfies certain conditions that are usually required in physics just to ensure the uniqueness of the solution. This is precisely why extremum principles have sometimes been regarded as formulations of the postulate of the uniqueness of natural processes, see Fig. 7. To say that in behaving the way they do physical objects move with the purpose of minimizing or conserving the intensity of a given quality is not too different from asserting that things happen as they do in order that the laws of nature may be satisfied. Extremum principles are no more indicative of end-seeking behavior than any other physical laws, and the association of integrals with purpose or design belongs in the same class of confusion of dimensions of language as the association of differential equations with causation. 3.4 plus the empirical test OJ differential equations and the question OJ the true elementary laws of nature to conclude with our analysis of the claim that certain differential equations mirror causal processes. A last argument will be set forth, namely, that differential equations are not directly testable by experiment, even after having been interpreted in empirical terms. In fact, only finite difference equations and integral relations, such as the solutions of differential equations, can be correlated with empirical data. Think of the very elementary notion of instantaneous velocity, defined as dx/dt, only mean velocities ijx/ijt are afforded by measurement. Or think of the term curl E appearing, for instance, in one of Maxwell's equations, only its integral equivalent, namely, the line integral E ds, can be assigned an operational meaning, to wit, the electromotive force. It might be argued that an arbitrarily close approximation to the elementary, differential, expression can be obtained, so that after all the problem of the empirical verification of a scientific hypothesis couched in differential terms resembles the replacement of geometric lines by fine threads. This is actually so in many cases, notably in connection with formulas involving simple symbols like dx/dt. But in some cases not a mere quantitative difference is at stake but a qualitative difference between the theoretical law and the experimentally testable expression. More exactly, sometimes no unique correspondence can be established between the differential laws and experimental data, so that the choice among the various data-fitting hypotheses is arbitrary, unless one of them is backed by theoretical reasons, or by ontological tenets, such as simplicity. Such a lack of unique correspondence between experimental data and the theoretical model is particularly acute whenever closed lines of flow or of force appear, as in fluid dynamics, electromagnetic theory, and other classical field theories. In an examination OJ the empiricist critique OJ causality 85 such cases no less than an infinity of different elementary, differential, laws is consistent with a single integral law, the one accessible to experiment. 44 In other words, largely arbitrary modifications of the differential laws have no empirically testable consequences, hence, it is empirically meaningless to ask which of these infinite differential formulas is the true one. The failure to understand this point was the source, a century ago, of a long and rather sterile controversy among the partisans of Ampere and those of Grassmann about the true elementary laws of the mutual actions of electric currents. The argument was over two different elementary laws which, integrated along a circuit, gave the same result and were thus empirically equivalent. It is now understood, though not made explicit enough, that in such cases only the integral law statements can be true or false, while the choice among the various differential laws consistent with the integral law is largely a matter of convenience or even of taste, to the despair of the upholders of the reflection theory of knowledge. Moreover, the same set of experimental data and the same reasoning suggesting the choice of a given differential equation as the reflection of a certain group of phenomena suggests also a finite difference equation. Only further consequences of the two alternative hypotheses, equations, may eventually be tested. While no different consequences have been tested, such alternative hypotheses are of course empirically equivalent, and our preference for differential over finite difference equations is dictated chiefly by the greater simplicity of the former or by the acceptance of the hypothesis of continuity. All this has the important philosophical consequence that the theory according to which differential equations are the ideal or even the sole form of scientific laws is, a. consistent with the empiricist reduction of determination to uniform succession, and b. inconsistent with the radical empiricist requirement that scientific laws should contain solely parameters that are accessible to experiment, that is, having a direct operational significance. The empiricist choosing the second alternative should propose calling only integrated expressions and finite difference equations scientific laws, and should consequently abstain from calling Newton's law of motion or Maxwell's laws of the electromagnetic field physical laws, since they obviously are not laboratory equations having a direct operational meaning. 45. However, few scientists would be prepared to receive this idea, which lends itself too easily to subjectivism, for the solutions of a differential equation, unlike the equation itself, depend upon the choice of initial or boundary values, reference systems, and so on, and these are in turn dependent, to a large extent, upon the information, mathematical equipment, and needs of the scientist. Besides, those following the operational course of identifying physical laws with laboratory equations should part company with the propounders of the positivist teaching on causality, see Sector 3+I. To sum up, differential equations are not the mirror image of becoming in general, nor of causation in particular. On occasion they can be assigned a causal meaning by means of ad hoc semantic rules, but this can be done with other types of mathematical objects as well. In short, the causal problem is not a syntactic but a semantic one. It has to do with the interpretation rather than with the formulation and representation of theories. 3.5. Summary and conclusions. Causality involves neither contiguity nor antecedence, although it is consistent with both. Indeed, causality is compatible with action at a distance and instantaneous action at that, as gravitation was once supposed to be. Since Hume regarded both contiguity and antecedence as the essential components of causation, it follows that his criticism of causality was not valid, however psychologically effective it may have. An examination of the empiricist critique of causality 87 bin. The principle of action by contact is moreover inconsistent with empiricism, as it is not directly testable by experiment. Though reasonable and fruitful in the domain of physics, the hypothesis of nearby action may lose any significance in other fields of research, which is a further ground for not regarding contiguity as essential to causation. Contiguity and antecedence, on the other hand, each impose a restriction upon causation. States of physical objects are not agents but systems of qualities, consequently they have no causal efficacy. Initial states cannot therefore be causes but may be produced by previously acting causes. Hence causation is not reducible to invariable, unique, and continuous successions of states. Predictability by means of laws of succession is a criterion not of causal connection but of the validity of nomological hypotheses about time sequences. Causation is not mirrored by differential equations, which by themselves have no more factual content than any other mathematical form. Such equations do not state that changes are produced by anything, but can be read as stating that certain changes are accompanied by certain other changes. One and the same differential equation can be assigned a causal interpretation alongside other, non-causal, interpretations. Differential equations are as little the carriers of efficient causation as integral equations are the carriers of final causation. The opinion that differential equations are the paradigm of scientific law in 18th century belief is not confirmed by modern science and is moreover inconsistent with the, equally untenable, operationalistic requirement that scientific laws should contain solely parameters having a direct empirical significance. In conclusion, the empiricist theory that determination is nothing but regular, unique, and continuous succession not only is unwarranted by modern science but leads empiricism into contradictions that do not seem surmountable without a retreat from fundamental positions. One of the severest blows suffered by the empiricist reduction of causation to uniform succession came from relativity physics. In fact, relativity introduces a radical difference between time series of genetically unconnected events, which are reversible. 88. And causal series, which are irreversible. Moreover, it suggests that it is the flow of time, relative to every reference system, that can be regarded as rooted to genetic sequences or, if preferred, as measuring their tempo. Change is thereby regarded as primordial and time as derivative. The time theory of causation, defended by Hume and his followers, is thereby reversed and a causal theory of time is established. As soon as this important step is taken, a traditional cornerstone of empiricism is left aside, and when such step is taken by eminent empiricists 46 it may be a sign of the deep crisis in contemporary empiricism, though not much deeper, it is true, than the crisis in any other living philosophic school. All in all, the empiricist critique of causality has been as erroneous as famous and rigor-provoking. 4. An examination of the Aralnantic critique of causality. The starting point of the empiricist critique of causality was the obvious remark that experience, by itself, said nothing about any causal bonds, whence it was concluded that, experience being the sole source of legitimate knowledge, a clearly trans-empirical statement, the category of causation in the sense of genetic link was a dispensable figment of abstract thought. The net result of the empiricist critique of causality was consequently a restriction of determination to regular association or invariable succession. The Romantics, from Schelling to James and Bergson including Peirce, the Romantic empiricists have on the other hand criticized causality on an ontological plane, and not just because they deemed the claims of causalism to be exaggerated moderation not being precisely a Romantic characteristic, but because they regarded causality as too poor a theory of change. Their colorful vitalistic Weltanschauung was embroidered on a canvas of multiple subtle organic interconnections. Compared with the richness of this universal interdependence or, Zusammenhang, the one-sided causal nexus, decried by empiricists for its alleged anthropomorphic associations, decried, in short, for containing more than experience could warrant causation, looked rough, miserable, dry, lifeless, and impersonal. The target of the Romantic critique of causality was, to sum up, the enlargement instead of the restriction of causality, which empiricism had preached. It is likely that the Romantic critique 89.90 Schism would have remained unnoticed had it not been for the fact that empiricists had already done a great deal in the way of discrediting causalism, and that 19th-century science, in all of its newest branches, was rapidly disclosing richer, non-causal, kinds of connection, mainly mutual actions and organic connections. Above all, science was realizing that the picture of change in terms of separate events, into which the causation category can fit, had to be replaced by a picture in terms of processes. In its turn, the increasing awareness of the complexity of the categorical outfit actually used by science, combined with the Romantic criticism of causality, exerted a beneficial influence on the positivistic approach to the causal problem, although at first sight no two approaches could seem as polarly opposed as the neopositivistic and that of the Naturphilosophie. In point of fact, the traditional empiricist efforts to reduce causation to regular association, to the external juxtaposition of concomitant events, were replaced, by some of the followers of Hume, by the attempt to substitute functional interdependence for causal dependence. This was especially the case with Mach, who, unlike most of his forerunners and followers, had a keen and somewhat romantic feeling for the diversity of nature and for the intimate interconnections existing among its different members and aspects. Like the Romantics, whom he probably despised and certainly ignored, Mach decried causation as an abstraction and as an insufficient concept which becomes superfluous as soon as interconnections are taken into account. We shall see below, however, that Mach failed to grasp, or at least to acknowledge, the notion of genetic interconnection, so that the affinity of the two approaches, which I am suggesting, should not be exaggerated. In the present chapter we shall analyze some of the criticisms raised against causality by Romanticism. Actually, we shall here be concerned solely with the main critiques that I consider justified, namely, the identification of causality with mechanical determinism, the attempt to replace causation by functional interdependence, and the claim that causality makes no room for freedom. The kernel of the positive contribution of the Romantic critique of causality 9I, the Romantic philosophers to the problem of determinism, will be mentioned in later chapters. 4.1. Should causation be replaced by interdependence? 4II. The functional view of causation, as was pointed out above, both Romantics and neopositivists have demanded the replacement of causation by interdependence. But modern positivists have usually lacked the Romantic sensitivity to process and newness, and, contrary to the Nader Philosophien, they accepted mathematics enthusiastically, though just as a shorthand enabling us to perform an economical description of experience. Further, while the Romantics decried mathematics on account of its alleged dryness and tautologous character, and opposed universal organic interconnectedness to the one-sided and unidirectional causal bond, Mach proposed on the other hand that the mathematical concept of function be used as the precise scientific tool for reflecting interdependence. Mach showed thereby that by interdependence he did not mean genetic interrelation but rather mutual dependence among existents, a static net of reciprocal dependences like that among the parts of a steel frame. Let us examine the Romantic claim that causation is but an abstraction from interdependence, in the restricted and precise form set forth by Mach 1. The founder of neopositivism was among the first to hold the functionalist view of causality. He demanded the replacement of every sort of connection, particularly causal connections, by functional relations expressing a symmetrical interdependence. Thus the relation xl equals f, x2, x3, dot, can be read to mean the property designated by xl is related to the properties designated by x2, x3. In the precise way specified by the function f as a particular case, laws of conservation, of momentum, energy, and so on, will be expressed in the form f, x2, x3, equals const. Or CFL6 XL0. Kirchhoff followed Mach shortly afterward along this path. The doctrine was adopted by most positivists, and some have even claimed that science has already achieved the complete replacement of the outmoded causal link by functional dependence. At least, this was announced in 1929 by the Wiener Kreis in its famous manifesto. 2. We have dealt with the program of reducing causation, and, in general, determination, to functional dependence. Indeed, functions establish correspondences between sets of numbers, so that they are a mathematical expression of regular conjunction, or constant association. In other words, the claim that causation is exhausted by functional dependence is more precise than, but not essentially different from, the constant conjunction view on causation, held by traditional empiricism, cc's 2.3 and 2-4. However, for the sake of clarity we shall deal separately with the functional view of causation. 4I.2. Criticism of the functional view of causation. The following objections can be raised against functionality. A. Functions express constant relations, fixed correspondences among two or more sets of numbers that are supposed to represent the numerical values of metrical properties. They may be used to state that something is invariably associated with or accompanied by something else which may consist of another, coexistent, property of the same object in question. But functions are insufficient to state anything concerning the cause that produces the state or the phenomenon in question. Although functions make it possible to symbolize and to give precise quantitative descriptions and predictions of connections enormously more complex and rich than the causal bond, they fail to state the one-sided genetic connection that characterizes The Romantic Critique of Causality 93. Causation, such a one-sided dependence of the effect upon the cause must be stated in an extra set of semantic propositions. B. Functional relations are reversible whenever the functions in question are single-valued, thus, from y equals x we may infer that x equals /a, provided ai equals 0. Hence, functions serve to symbolize interdependence, whether of different features of a given object, or of properties of different events. In this special but important case of functional dependence, the variables denoting the cause and the effect are interchangeable, whereas GNU and causal connections are essentially asymmetrical, see Sector 2.3. In other words, if a equals f, x, is a single-valued function, it can be inverted unambiguously to yield x equals fi, y, so that the relative places of the cause, first represented by x, and of the effect, which in y equals f, x, is symbolized by y, can be exchanged. The failure to account for genetic connections is a shortcoming of the functional relation. But not all connections in the world are genetic. In many, perhaps in most, cases we are confronted with interdependence rather than with a one-way relation of dependence, as is shown by the pervasiveness of the function concept in the sciences. A trivial illustration of non-causal interdependence of different features of a single phenomenon is afforded by the relation y equals a sin wt between the phase wt and the displacement y of an harmonic oscillation. It would be meaningless to point to either variable as the cause of the other, since no genetic connection is involved in that relation. Only a change in one of the variables could be read as the cause of the change in the related variable. Still, this causal interpretation would not do justice to the asymmetry or unidirectionality of causation. C. A typical trait of causation is uniqueness, see Sector 2.4.1. On the other hand, in general functions do not establish one-to-one, that is, bionic, correspondences. Consider the function y2 equals x. This is a two-valued function, as two values of y are associated with every value of x. If interpreted in causal terms, it would say that two different effects y equals x and e equals x correspond to a single cause x and two exactly opposite effects at that, see Fig 8. 94. X. Fig 8. The two-valued function y2 equals x. The same cause has two effects, a positive and a negative one. D. In many cases, a variation in the independent variable x is accompanied by no change in the dependent variable y equals f, x. In other words, the cause is ineffective, hence it is not a cause at all. Within these ranges of values, variations in the cause have no effect. If preferred, the effect does not depend on the precise intensity of the cause, which may vary arbitrarily within the given range. Such zones of insensitivity, sometimes called plateaus, are characteristic of saturation phenomena, see Fig 9. At least in the saturation zone the independent variable x and the dependent variable e cannot be regarded as representing the cause and the effect, respectively. In other words, plateaus correspond to the non-causal range of the law in question. An even more drastic illustration of this point is afforded by the function y equals sin n7t, which is always 0 for integral values of n, and may jump from integer to integer without having any effect on y, whence it cannot be regarded as the cause of e. Functional relations may be employed to describe processes that may or may not be causal, but by itself functional. Dependence does not constitute a category of determination. Functions, together with the semantic rules stating the meaning of the variables tied by them, are often useful to tell what happens and why it happens. If a causal meaning can be attached to some of the symbols intervening in a function, rarely, if ever, to all of them, such an interpreted function will reflect a causal connection, see Sector 3+I. In other words, functions, which are syntactic forms, cannot replace causal propositions. At most, they may take part in the description of causal connections. I may be allowed to recall briefly the formal nature of mathematical entities, see Sector 3+I. Functions are mathematical forms that may be filled with an infinity of contents not excluding unscientific, untestable, statements. Functions, alongside other mathematical entities, help us to express some of the features of laws of whatever type, whether causal or not. Thus, distribution functions help us in reflecting random processes. Moreover, functions are by themselves neutral with regard to material, factual, truth. They may be used to state truths of fact as well as errors of fact. Scientists who are aware of this semantic neutrality of mathematics are not prepared to receive the naive idea that, in view of the alleged scientificizing virtue of mathematical formulation, all that is needed to obtain a perfectly scientific definition of 9.6. Causation is to identify it with some mathematical form, function, differential equation, etc. 3. 4i.3. Strange features QF. The functional view QF causation. The functional view of causation has suggested naive solutions to time-honored problems. One of them is the problem of teleology. The founder of the Vienna Circle stated that the replacement of causality by functional dependence leads to the breakdown of the distinction between teleology and causality, for the meaning of determination is possibility of calculation or prediction, and if we can calculate E from C by means of a certain formula, we can also infer C from E, whence it makes no difference whether we say the past determines the future or the future determines the past. For we shall not linger upon this curious result of functionalism, which depends on the idealistic identification of determination with possibility of calculation, see Sector 1.2.2, as well as on the confusion between future, or final, state and goal for whose attainment present processes are assumed to serve too obvious a confusion to deserve further attention. A second problem that can be solved in naive terms on the ground of the functional approach is the mind-body problem. If it is stated that determination is exhausted by functional interdependence, then psychophysical parallelism ensues. In fact, the statement that the series of psychical states 11, 12, parallels that of the physiological states P2, of the nervous system amounts to asserting the existence of a symbolic, not necessarily metrical, functional relation 1 equals J, CP, with the eventual, but unwarranted, proviso that the function J, CP, must be single-valued, to ensure unambiguous coordination. This functional view of the mind-body problem is consistent with dualism, neutral monism, and Leibniz's pre-established harmony, but is it consistent with the elementary remark that we can cease thinking without having to annihilate our brain, whereas the removal of the latter renders thinking impossible? A third problem that has been given a naive and uncompromising solution by functionalism is that of the relation between the material conditions of existence and spiritual culture. As against both the idealistic doctrine of spiritual life as the ultimate source of every cultural, social, event and the materialistic theory of the ultimate predominance of material over spiritual factors, historical functionalism states that it is not a question of genesis and predominance, whether short run or long run, but only of an inextricable interdependence among factors standing on the same footing. The undeniable fact of the reciprocal action among features actually standing on different levels is thereby emphasized, but at the price of giving up the hope of understanding the real genetic mechanism, since the factors involved in the functional dependence are regarded as given and, moreover, as standing on a single level, as if society were not a multilevel structure. Functionalism is also consistent with organismic cosmologies, and is true to the extent to which organicism is true, its element of truth being that real connections are not one-sided but many-sided, and variable instead of static. The main shortcoming of functionalism is its lack of recognition of the productive, genetic character of determination. Moreover, if applied consistently, functionalism leads to the view that the whole universe is an unanalyzable muddle consisting of an infinity of factors, all of them standing on the same footing. The isolation of factors from one another is certainly an abstraction in many cases, but such an isolation or singling out of the various features is required by a scientific treatment. What is wrong is not the tearing of partial and one-sided connections out of the general interconnection, but the remaining at such a preliminary stage of research. The truer an account of facts, the more it attains an integration of the various partial views, but such a synthesis, if scientific, will not be presupposed, it will be a result of analysis, and will include 98. Evaluation of the various factors, that is, statements about what are the relevant and decisive components or aspects, which are the ultimate determinants in a given respect. To sum up, causality is not reducible to functionality, because functional dependence is in a sense more general than causation, since with the help of functions interdependence instead of one-sided causal connection may be adequately expressed. But on the other hand, functional dependence is poorer than causation, since it does not include the concept of genetic connection through a process, but expresses instead a mutual dependence among things or qualities that may coexist without being genetically related to one another. 4.2. Causality and universal interconnection, the block universe and chance determinism, whether in its causal variety or not, asserts, at least as defined in Sector 1.5.3, the genetic principle and the principle of legality. The former implies that there are no isolated facts in concrete reality, things being actually interconnected and in precise and regular ways at that, adds the principle of legality. But this does not mean that determinism, and in particular causal determinism, asserts that everything in the world is connected with everything else in all respects, nor does causal determinism assert that everything is causally connected with everything else, a doctrine occasionally, and erroneously, ascribed to monism, which in one of its varieties asserts nomological unity, but not necessarily of the causal kind. The doctrine of universal and necessary interdependence, stating that everything is en rapport with everything else, that tout est essent, as romantics and occultists maintain, need not be causal although it is consistent with causality. The doctrine of causality is also compatible with the idea that coexistents may not be causally related to one another, parallelism. This was clearly realized by the most consistent among the early partisans of the universal, unrestricted operation of the causal bond, namely, the Stoics. In order to substantiate their claim that the world is an organic unit, a common life animating all of its. The Romantic critique of causality 99 parts, as Plato had suggested in his Timaeus, the Stoics postulated the existence of a universal sympathy among the different linear chains of successive causes and effects. 5. That is, the Stoa added a special, horizontal, connection through space, but not necessarily of a physical nature, to the vertical causal connection, and this universal sympathy holding the various parallel causal chains together in a single bundle, this horizontal connection, was not necessarily of a causal nature. The philosophers of the Enlightenment, plainly under the spell of the Newtonian theory of universal gravitation, often stated the principle of the reciprocal action among all concrete coexistents, as a special axiom to be added to the law of the causal succession in time. 6. The Romantics who came shortly afterward joined the two ideas in the single principle of the universal and dynamic Zusammenhang or interdependence that was supposed to hold all things together through both space and time. Now, if the causal principle and the theory consisting of its unlimited extrapolation allow for independent or parallel causal lines, then they are consistent with the admission of that type of chance consisting in the crossing or encounter of mutually independent causal lines independent, that is, till the instant of their meeting. Hence, although the causal principle excludes chance in connection with every single sequence, it does not exclude contingency as synonymous with independence, or mutual irrelevance, of different causal series. This sort of chance, dealt with in antiquity by Chrysippus and in modern times by Cournot 7, is not a mere name for human ignorance save as regards the prediction of exact place and date of the chance encounter. Even an exact foreknowledge of such a coincidence would not prevent its being a chance encounter, since up to the moment of their crossing the two lines were disconnected, they are objectively contingent relatively to each other to the extent to which independence, or irrelevance in definite respects, has an ontological status. Consequently, those who, wrongly, regard chance as a wholly epistemological category, and even as nothing but a name for our ignorance, cannot reasonably claim that this doctrine on the nature of chance is based on the causal principle, or even on causalism, which at least implicitly makes room for chance from the moment it does not assert universal causal interdependence in all respects. Not only does causalism make room for chance, but, if consistently developed, it leads to a self-defeating recognition of contingency, as will be shown in seconds AI. But, quite aside from the question whether causality implies rigid universal interdependence or not, a word should be said on the claims to validity of the block universe doctrine. The perfect test of it would be the utter failure of science, for, if things were so closely tied together as the propounders of unlimited interdependence assume, if everything were relevant to everything else, then it would not be possible to know any part of the universe without knowing the totality, which obviously is not the case, for we do not even know what the whole is and whether it has a finite spatial extension or not. Conversely, no knowledge of the whole would be possible unless a complete acquaintance with every one of its parts were available. This tragic circle was perceived by Pascal, who, in spite of this, held the doctrine of unlimited universal interdependence, a conflict that may have influenced his conversion to religious meditation. On such a view, which organismic ontologies should propose if they were consistent, the progress of knowledge would be impossible, the very task of science would be like that of solving a logical circle. Since we are not caught up in such a circle, since the progress of knowledge is undisputed, we may infer that the hypothesis of unlimited universal interconnection, whether causal or not, is false. A further test of the falsity of the doctrine of the block universe is the existence of chance, that is, statistically determined phenomena. Most of them arise from the comparative independence of different entities, that is, out of their comparative reciprocal contingency or irrelevancy. The existence of mutually independent lines of evolution is in turn ensured by the attenuation of physical interactions with distance, and by the romantic critique of causality 101, their finite speed of propagation, the most effective looseners of the tightness of the block universe. 4.3. Is causality fatalistic? 4.3i. The otherworldliness of fatalism. When Emerson wrote that the book of nature is the book of fate, he merely repeated another common error. It is, indeed, a widespread misconception that natural science discloses the work of fate, and since science is currently assumed to be entirely or at least essentially causal, another wrong belief, it is concluded that causality is fatalistic. This misconception is not only disseminated among essayists, like Emerson, but even among philosophers and scientists. Phenomenalists like Renouvier, accidentalists like Jordan Lowe, and above all the Romantics have too often asserted that causality and determinism are identical with fatalism, that is, the belief in a transcendent necessity producing inevitable results and moreover operating ab aeterno, in such a way that events are all predetermined, or written, as it were, in some book, even before writing was invented. Actually, fatalistic determinism is in a sense the very opposite of scientific determinism, and is in particular incompatible with causal determinism. In point of fact, fatalism is a theological or at least a supernaturalistic doctrine asserting the existence of an unknowable and inescapable destiny. On the other hand, causal determinism claims to be a rational theory offering the means for knowing, predicting, and consequently changing the course of events. The word fatalism designates the class of doctrines subordinated to some non-naturalistic belief, and asserting that a transcendent, otherworldly, uncontrollable, unpredictable, immaterial power produces all events, or most of them. 1. There is no fatalism without a fatum or fate, and this is anything but the so-called blind rule of law, conceived as the immanent pattern of being and becoming. 4.3.2. The lawlessness of fatalism. It is important to realize the difference between fatalism and determinism, whether causal or not, because virtually all of the objections that are ever raised against determinism turn out on examination to be objections against fatalism, which disappear as soon as fatalism is thus distinguished from non-fatalistic determinism. 12. Causality, as such, need not assume any supernatural agency. Besides, according to causality, events are chained to one another, whereas for fatalism every bond is indirect, since it is assumed to go across a power external to the events concerned. As conceived by fatalism, necessity is not inherent in things, it is not rooted to the nature of things, but is definitely contingent upon what things are and how they change. According to fatalism, there is a primary cause, which is transcendental, and there are secondary effects, which are worldly but occur no matter what the worldly state of affairs may be or may have been. The necessity asserted by fatalism is lawless, and this is why its patterns, if any, are deemed to be inscrutable. To fatalists, events occur regardless of circumstances, since what is preordained must occur, nothing will prevent its happening, nothing will be able to interfere with an unbreakable external necessity, the fatum that produces or directs the course of events. In other words, according to fatalism, just as according to accidentalism, events are unconditional, and the future is as unchangeable as the past. As Sophocles put it, strange are the ways of fate, her power, nor wealth, nor arms withstand, nor tower, nor brass-propped ships, that breast the sea from fate can flee. 13. Fatalism and accidentalism are the two extreme forms of lawlessness. Lawfulness, and causal lawfulness as a particular case, lie midway between the unconditional necessity asserted by fatalism and the unconditional arbitrariness assumed by Tachism. While fatalism holds an unconditional necessity and conceives it as transcendent, an essential mark of causality and, indeed, of every other type of lawful determinacy, is conditionality, see Sector 2.2. Statements of causal laws and, in general, scientific laws, do not assert that something will inevitably happen under all circumstances, regardless of past or present conditions. Quite on the contrary, statements of causal laws assert that if, and only if, certain conditions are met, certain results will follow. A change in the conditions will therefore ensure a change in the results. The rule of fate is then seen to be illusory, events not being predetermined once and for all, but improvised, so to say, along the way. 4.3.3 The interference of causes defeats fate. An implication of causal conditionalness is that causes may interfere with one another, so that the result may turn out to differ from what would follow from any of the separate causes. Since any given cause may be counteracted, or at least influenced, by another cause, causality does not entail inevitability. On the contrary, it leaves room for processes and deeds capable of changing the course of events, thereby affording a real though certainly limited ground for both chance and freedom. Whereas fatalism rules possibility out of the world, relegating it to the epistemological sphere, causality, if rightly understood, is one of the very grounds of possibility. It renders possibility possible. Indeed, according to the doctrine of causality, there are no uncaused events, but not every cause need succeed in producing the expected effect. A given set of causes may be hindered, for the production of their otherwise normal effects, by the interposition of other causes. 14. Leibniz had an idea of this when he said that it is necessary that everything have a cause, but it is contingent that every cause should produce its effects, whence past events have been necessary while future ones are contingent. In order that a cause may produce its normal effect, other causes, background causes, or conditions, must concur. The interference of new circumstances, a change in the background, may prevent a causal connection from taking place, and this is a source of possibility. A fortiori, general determinism does not recognize anything unconditional and, as a consequence, it does not entail any inevitability other than what results from the lawful concurrence and interplay of processes among which the human conscious conduct may eventually intervene. Only, general determinism shows us that the set of laws enabling us to counteract or at least modify in some way any given course of events, thereby building a different future, is much richer than that imagined by causalism. The ethical and sociological import of this question is obvious. Neither fatalism nor accidentalism allows for freedom. The former relegates freedom, if any, to the arbitrary deeds of an uninfluenceable fatum. And accidentalism does not make room for freedom, because it does not afford the means of achieving freedom, whether individual or social. For, if things just happen in an arbitrary fashion, If the universe is a chaotic heap of unrelated events, what can we then rely on? Which traits of the world, which laws can we use for attaining freedom from outward compulsion and constraint, or, rather, liberty to subject external conditions, within limits, to our will? What is there to warrant that a tendency to resist, counteract, or simply modify such a compulsion in some way may develop? Moreover, what assures us that such a compulsion exists, and consequently that there is an ethical problem at all? This extreme consequence has actually been drawn by the propounder of the so-called principle of complementarity. In fact, time and again Bauer has maintained that the strife between the upholders of free will and those of ethical determinism, or, rather, predeterminism, is a Inhaltlosigkeit, a vacuous question, like the antinomies determinism, indeterminism, and the romantic critique of Causality J105 mechanism vitalism. The gist of Bauer's argument is the following: in order to analyze experimentally the subject's behavior, one would have to disturb him basically, thereby rendering his free will illusory. In fact, such an experimental analysis of the subject's moral conduct would require a thorough mechanical, chemical, biochemical, and physiological dissection of his body. This argument sounds like maintaining that one cannot both be a physiologist and know something about human physiology because one cannot remain alive while being taken to pieces, or like saying that it is not possible for a psychologist to know something about human behavior and consciousness because he cannot study his own behavior while watching the flux of his consciousness, or because he cannot exert his free will while being subject to a test. Such obvious difficulties do not prove that freedom is a metaphysical fiction. Rather, they support the hypothesis that moral behavior cannot be analyzed experimentally in the manner of physical phenomena. Free will is certainly rooted to the lower levels, but it has not been shown that it can be reduced to them. This is why nobody solves ethical problems by means of physico-chemical techniques. Tikism, no less than fatalism, and for the same reason, namely, lawlessness, involves the servo arbitrio of astrology and of Mohammedan and Calvinist theologies. On the other hand, the conscious and planned handling of laws, of those asserting self-determination as well as of those expressing the way in which certain agencies may be counteracted by other agencies in a regular way, is the very condition for attaining a genuine libero arbitrio, replacing the servitude to which ignorance of such laws condemns us. L5. 4.3 Plus Are historical events inevitable? The same is true, mutatis mutandis, of social events. Historical happenings are not inevitable, in the sense of occurring no matter what the conditions are. What is true is, that many historical facts occur without our conscious will and sometimes even despite the will of the social group concerned, but this has nothing to do with inevitability, and much to do with our ignorance of social laws or with our inability or unwillingness to apply the scanty available knowledge of them. Nothing can refute the assumption that effective and lasting influence on the course of historical events is attainable on the basis of a scientific approach to social events, an approach including the search for the laws of socio-historical development affording the means for performing predictions of a statistical character, see SECS. IO.4 and 12.3. The inevitability of social events is noticeable even in the case of radical changes. With regard to political upheavals, a South American should be believed upon his word. As to social revolutions, let us hear the testimony of a historian. A social revolution, says Child, may be necessary in the sense of essential to further progress, but it is not inevitable. In Mesopotamia, Egypt, and China, theocratic despotism, relations of production appropriate to the productive forces of the Bronze Age, persisted into the Iron Age. They effectively fettered the exploitation of the new forces represented by iron, with the result that technology also stagnated. The whole life of those societies stagnated too. The first two eventually perished altogether. From a Marxian analysis, all that one can deduce is the dilemma: revolution or paralysis. History does not disclose an unfaltering march to a predetermined goal. 16 revolutions, however needed at critical stages for further advance, are possible only provided certain objective conditions are fulfilled, and they have a chance to succeed only if, besides such objective conditions, which ultimately, but not entirely, depend on the socio-economic basis. There are influential groups enlightened as to ends and means, whose acts are not utopian but are rooted in the objective conditions, and who are ready to exert their will to the extreme. Inevitability, if any, is the product of carefully planned action. To summarize, no form of scientific determinism entails fatalism. On the contrary, the assertion that things occur in a lawful way, that is, that they follow definite patterns provided 11 Child, 1947, History, p. 73. Italics mine. The romantic critique of causality certain conditions are met, is the very prerequisite for avoiding the inevitability of fatalism, both in connection with the mastering of natural forces and in the remodeling of society. Freedom, far from being the negation of determination, is a form of it. It is the victory of lawful self-determination over the external compulsions and constraints fitting, in turn, other laws. 4.4. Is causality mechanistic and is mechanics altogether causal? 4+I mechanics restricts causes to forces. Further broadcast misconceptions regarding the causal problem are that causality is necessarily mechanistic and that, conversely, mechanism necessarily entails causality. The former opinion is explainable in view oft undeserved oblivion into which scholastic philosophies, which are causal but not mechanistic, have fallen. The latter can be explained in view of the current disregard for Epicurean mechanism, which included an uncaused sort of motion, the atomic swerve, or Klein Amen. The two mistakes have been indulged in by Cournot, 17 Peirce 18 Bergson 19 Ray, 20 and many others 21 who have been concerned with the nature and history of mechanistic philosophy. Causality, in one form or other, can be found in most traditional ontologies, not excluding those which like Plato's, Aristotle's, or Aquinas's were furthest from mechanism and emphasized final causation, regarding efficient causation as ultimately dependent upon purpose. Practically all of the scholastics looked upon the causal principle as a principium per se notum, a self-evident axiom. This point will be discussed later on. What must now be stated is the peculiarity of mechanics and of mechanistic philosophy with regard to the causal problem, namely, the reduction of cause to horse. To Galileo, the true causes of physical phenomena were forces, and these should be explained, in the last analysis, by the motions of the atoms, whence the name of mechanical causes, to distinguish them from those invented by the schoolmen. To Descartes, too, force was essentially connected with change of place. It was Newton who enlarged the notion of force, the mechanical representative of cause, to include in it not only the forces arising from changes of place, but every agency producing a change in the state of motion in a body. 22 In short, what was peculiar to both mechanics and mechanistic philosophy, from Galileo to the Newtonians, was not causality but with a tautology, mechanical causality, as contrasted to the richer but chimerical forms of causation imagined by Aristotle and by his uncountable commentators. 4.4.2 Self-movement in mechanics, inertia. Moreover, mechanics is not a purely causal discipline, nor is consequently mechanistic philosophy, at least neither of these has been entirely causal since the 17th century. Both mechanics and mechanism constitute, in fact, a limitation on causality, since they restrict causes to whatever produces a change in the velocity of bodies. In another sense, modern mechanics and mechanism transcend causalism, by the fact that they employ a category of determination that makes room for change of place, even in the absence of causes, forces. Indeed, modern classical mechanics, and the few consistent mechanistic philosophies built thereon, assert, in contradistinction to causal determinism, the principle of inertia, which is a restricted version of the principle of self-movement. Since this point is capital for the understanding of both causality and mechanism, we shall consider it in some detail. Contrary to what most immaterialist, and especially romantic, philosophers believe, modern mechanics, whether classical, relativistic, or quantal, does not regard matter as inherently passive, inert stuff. It asserts, instead, that the motion of material systems, relative to a given reference system, need not be caused, that is, mechanical motion need not be elicited by agents external to the system itself and summarized in the force concept. The mechanical motion, change of place, of a system endowed with mass is, moreover, never the sole result of the external forces acting upon it, only the alterations in the state of motion or of rest of the system are the effects of such forces, and this, in accordance with Newton's second law, or some of its generalizations. Indeed, according to the first axiom or law of motion of Newton's Principia 23, if a body is left to itself it will not therefore cease moving, as Aristotle had taught and Aquinas had repeated, but it will continue moving until some force, originating, for instance, in collision with an obstacle, causes it to deviate or even to stop. If a new system is considered, such that it includes the sources of the forces previously regarded as external, then it will evolve of itself. From this we infer that, if the future states of this wider isolated system are not entirely determined by its present state, then it is not as isolated as we had thought, but is subject to some external perturbation. That is, mechanics rejects the scholastic maxim quod movetur ab alio movetur, everything that moves is moved by something else. It acknowledges, instead, an element of spontaneity, hence of non-causality. Another basic peripatetic maxim is thereby rejected, namely, causas es ante cessat effectus, the effect ceases with the cessation of the cause. In short, the principle of the mechanical self-movement of matter, that is, the principle of inertia enunciated by Galileo, Descartes, and Newton, is openly non-causal, for it states that a certain type of change, the simplest of all, requires no efficient, extrinsic and motive, cause, that is, no force or external compulsion to proceed. 24. Let us give an illustration of the foregoing discussion, a point misunderstood even by physicists with too generous notions about the scope of causality, as well as by philosophers who retain scholastic ideas about matter and motion. Consider the motion of a billiard ball, or, rather, of its center of mass, during a time interval short enough to permit us to neglect the effects of friction. At an arbitrary initial time the ball moves with velocity v0 and is struck with a billiard cue, thereby acquiring a new momentum mv, m being the mass of the ball. The total change in momentum will then be mv, vo equals f pound lt, where f denotes the intensity of the cause, that is, the force, that produces the change in velocity v, vo, and pound lt designates the time interval during which the cause has acted. 25. In other words, the cause f, acting during the small time interval pound lt, has produced a change of momentum pound l, mv, equals mv, vo. After the cause f has ceased acting, the ball continues changing its position, relative to the billiard table, in accordance with the law t, mv, /dt equals 0, which holds to the extent to which friction forces can be neglected. From this law we deduce, by integration, that the change in position proceeds in accordance with the formula x equals vt plus xo, xo being the initial position and v the velocity acquired by the ball as a consequence of the collision. Thus, the force has produced only the first change, the succeeding positions, after the time LLT has elapsed, were not acquired by the ball as a consequence of new blows with the cue, nor as a consequence of air vortices behind the ball, as an Aristotelian would think. They were the result of previous states in the absence of causes. Moreover, the sole causes acting after the blow with the cue were retarding and not accelerating forces, namely, those of friction. Still, it might be argued that mass, which summarizes mechanical inertia, resistance to change in the state of motion, is the cause of inertial motion, so that after all the latter does not violate the causal principle. In fact, the statement is often found in textbooks that inertia causes matter to move along a straight line. A similar argument was employed by Carneades against the Epicurean explanation of free will as the outcome of the irregular and uncaused motion of the atoms, a mechanistic explanation that has recently been revived in connection with the uncertainty principle. In fact, according to Cicero, Carneades held that the Epicureans might have defended freedom of the will without renouncing causality, by asserting that the will acts freely, without a previous external cause, not however uncaused, because the voluntary motion of the soul is by its very nature in our power and is dependent upon us, and not without a cause, for its cause is its very nature. Point 26. This reasoning amounts to regarding qualities as causes. It is, moreover, circular, for it does not explain events but merely states that it is in the nature of things that such events should happen. 27. It is nothing but a verbal attempt to save causality. And Einstein-Newton's second law of motion embodies the principle of inertia, hence it is far more than a strictly causal law. Besides defining the cause-effect bond in the realm of mechanics, it asserts the mechanical form of the principle of self-movement. The causal component of Newton's second law is of course very important since, although the law states that changes of place may be causeless, it also states that every change of velocity, that is, every acceleration, is the effect of a force. Note, by the way, that the law force causes acceleration involves neither contiguity nor precedence of the cause over the effect. This double meaning of Newton's second law is made possible by its mathematical form, which is a second-order differential equation, d2xf equals m dash, dt2 having non-trivial solutions, x equals 1 equals constant, that is, motion, even if the cause vanishes, f0. On the other hand, Aristotle's law of motion can be framed, in modern terms, as a Geerst-order differential equation, namely, f equals r dx dt, that is, the force is proportional to the velocity, r denoting the resistance to motion. In the absence of causes, f equals 0, this equation has only a trivial solution, x equals constant, that is, rest. Aristotle's law of motion is then an entirely causal law, whereas Newton's law has only a causal range. This is why Newton, in contradistinction to Aristotle, and even Kepler, did not look for the cause pushing the planets around the Sun, but looked instead for the cause that bends their trajectories, see Figs 10 and II. Newton performed, in this regard, an analysis of planetary motion paralleling Galileo's celebrated decomposition of the motion of a projectile into the spontaneous, inertial, motion that it would have in the absence of gravity, and the free fall that would take place owing to gravity in the absence of an initial velocity. The situation is rendered even worse for causality in the relativistic theory of gravitation. In fact, according to this theory, what produces the bending of the trajectory of a planet is not a classical force but the space-time curvature, that is, departure from Euclidean geometry, around the Sun. Here again, planets move off themselves, but, unlike Newtonian mechanics, in which cause equals force, in general relativity no force is assumed to take part in the motion of planets. As Whale has said, since Galileo we conceive of the motion of material bodies as a strife between inertia and force. From the equality of I-14. Gravitational and inertial mass, Einstein concluded that, in the duality of inertia and force, gravitation belongs to the side of inertia. 28 Space-time curvature acts in fact as a condition or constraint rather than as a force, it guides the otherwise spontaneous motion of the planets around the Sun, in a way similar to that in which an inclined plane guides the rolling down it of a cylinder without causing its motion. General relativity therefore enlarges the territory of self-movement at the expense of the range of causation without, however, eliminating causation, since forces different from gravity are retained in it as causes. 4 plus 4. Action-reaction, and inner stress. A second non-causal component of mechanics is the principle of the equality of the action and the reaction, Newton's third axiom, according to which no mechanical action is exerted, so to speak, with impunity. 29 This principle may be regarded as the mechanical version of the general principle of interaction, asserting that there are no unidirectional actions, as the causal ones are supposed to be, save to a first approximation. By stating that principle, mechanics implicitly rejects the scholastic notion, correlative of strict causality, of the passivity of material systems, that is, the notion that there are pure patients which do not react on the agents. 30 Finally, a third non-causal component of mechanics is the concept of inner stress. The mechanical theory of continuous media, fluids and elastic solids, focuses on the inner stresses that develop as a consequence of the combined action of the external forces and of the inner, intermolecular, forces keeping the molecules together. The kernel of the dynamics of continuous media is an equation relating the variations of the components of the stress tensor. This may be regarded as the mechanical version of the basic principle of dialectics, regarding the contradictory nature of all concrete existence, which may be interpreted as asserting that every material object, however homogeneous it may look at first sight, is actually inhomogeneous in some respect and to some extent, and is moreover composed of mutually opposed or conflicting, that is, mutually disturbing, parts or features, thus being subject to an inner stress that may develop eventually and are said by external forces, to the point of producing a radical, qualitative, change in the zero bject concerned. Needless to say, ontic strife or, simply, inner opposition does not involve logical contradiction. Neither the assumed polar structure of concrete existence nor change is inconsistent with the principle of contradiction. 31. In brief, causality need not be mechanistic, and classical mechanics is not a purely causal discipline, although it contains an important causal ingredient, namely, the force concept. 32. By asserting the importance of self-movement, reciprocal action, and inner stress, or strife, to employ the Heraclitean and Hegelian metaphor, classical mechanics transcends causality and asserts, if only in a restricted way, the germs of the dialectical theory of change, just the germs, since qualitative change, the basic notion of dialectics, is absent from mechanics. 4.5. Summary and conclusions. Causation cannot be replaced by functional dependence, as romantics and neopositivists have demanded, because the category of interdependence lacks the essential component of genetic, productive connection. If a mathematical function is assigned a causal meaning, this interpretation must be stated in extra statements, semantic rules. Functionalism may do justice to all of the factors or facets concerned, but it fails to account for decisive determinants, that is, factors which in the short or the long run determine the essential characteristics of a process. An exaggeration of functionalism leads to the organismic view of the block universe, in which there is place neither for chance nor for freedom. But causality does not imply universal causal interconnection. While the latter excludes chance, causality leaves enough holes in the universe to let chance work as an ontological category, coincidence of independent causal lines, or mutually irrelevant processes. Two further reproaches of Romantic philosophers against causality are found to be unjustified, namely, that it is fatalistic and that it is mechanistic. Fatalism is a supernaturalistic doctrine asserting the unconditional, hence lawless, operation of transcendent determiners, whereas causalism is not committed to unscientific teachings, and respects the principle of legality. Moreover, causality affords means for achieving the freedom denied by both fatalism and accidentalism. If nothing is unconditional, then in principle nothing is inevitable, but every cause can be counteracted or at least controlled by another cause. That causality need not be mechanistic is shown by the mere existence of the Platonic and Aristotelian systems. And an examination of a few basic concepts and ideas of classical mechanics shows that this discipline, while containing an important causal ingredient, summarized in the force concept, goes beyond causality. If the Romantics had been better acquainted with Newtonian mechanics, they would not have felt justified in decrying it, but might have found in that science the germs of three categories of determination of which the Nader Philosophine had been very fond, namely, self-movement, reciprocal action, and inner strife of opposites. 33. Part.T3. What causal determinism does assert? The linearity of causation. After having tried to defend the doctrine of causality against reproaches coming from the most distant quarters, like empiricism and romanticism, we shall now launch an open attack. The shortcomings of causalism will be critically examined in this, the third part of the book. Our first concern will be to emphasize, and then criticize, the linear character of becoming stated by the doctrine of causality. 5.1. Is multiple causation strictly causal? 5. Simple and multiple causation. The less vague formulations of the causal principle involve either a single cause C and a single effect E, or a finite set of causes CLLC2, Cn and a single effect E, or vice versa. In the former case we speak of simple causation, in the latter of multiple causation, including in it both plurality of causes and diversity of effects, see Fig. 12. Thus there are many ways of wasting a fortune: plurality of causes, the possession of which may have various alternative consequences; plurality of effects. To the extent to which functionality parallels causality, a limited extent indeed, as was shown in Sector 4. The functional correlate of simple causation is E equals J, C. Or if, as is usual, the intensity of the cause is denoted by the independent variable, x, and the intensity of the effect by y, then the functional relation corresponding to simple causation is y equals j, x. The functional correlate of the plurality of causes will on the other hand be y equals j, xl x2, xn, and the functional correlate of the diversity of effects will be the set of functions of a single variable y equals fx, I1, 2, n. If there is both a finite set of causes C, and a finite set of effects Ej, the relation among the two sets will be causal provided the correspondence among them is one-to-one reciprocal, Cj Ej, or, if preferred, Wien equals h, x. But this case falls under the heading of simple causation, since the connection is split into the set of relations y1 equals fl, xl, y2 equals f2, xz, 11 equals f, xn, representing a bundle of independent, non-interfering, causal lines. If, on the other hand, no such one-to-one reciprocal correspondence exists, if there is a relation between the set of causes and the set of effects, then we may be in the presence of multiple statistical correlation, in which the characteristic linearity of causation is lost, as different variables become intermingled. The last case to be considered is that of an infinity of factors or variables. But infinite sets of either causes or effects, NCI, in the foregoing formulas, will not do, they are not empirically verifiable. In fact, the best tests for the authenticity of a causal factor, or, rather, for the adequacy of a hypothesis stating the probable relevancy of a causal factor, are its removal and its deliberate reproduction, and a necessary condition for either test is that there be a finite and moreover a reduced number of relevant determiners alone. It could always be objected that the infinity of connections remaining beyond the reach of experimental control are not really causal, but constitute instead a non-causal remainder. Therefore, in order that the linearity of causation I2I connection be entitled to be called causal, it must involve finite sets of both causes and effects. We conclude that multiple causation is restricted to connections among a single cause and a finite set of effects, or a finite set of causes and a single effect. 5.1.2. Conjunctive plurality of causes, reducible to simple causation. Needless to say, when speaking of single causes or effects in connection with either simple or multiple causation, simple events are not necessarily meant. The events may be infinitely complex situations, but always such that they behave as units or wholes in the respect that is being investigated. In other words, if a single effect is at stake, it may be produced, and so it is in actual cases, by the joint action of various causes, but whenever the causal connection itself is simple, that just means that the complex of conditions constitutes a single determinative unit, that is, a collection of jointly acting determiners. It may prove convenient in this case to speak of conjunctive multiple causation, symbolizing accordingly the total cause in the form C equals CIC2C, and the connection of conjunctive multiple causation may then be symbolized CRC2CN-. A most interesting variety of multiple conjunctive causality is that in which the causal complex can be analyzed into a hierarchical gradation. This procedure was commended by Galileo, who refused to regard all of the factors involved in an authentic causal complex as standing on the same footing, The true and primary cause of the effects of the same kind must be a single one. When such a gradation of causes is possible, we may speak of the primary cause, the first-order perturbation, the second-order perturbation, and so on. The application of the calculus of perturbations in astronomy and physics rests on the possibility of such a gradation of causal factors. In an ideal case, the numerical values Ck and Chi of the intensities of two successive terms in such a sequence would stand in a ratio like IC plus RLC, I 1/10, a neat separation among the various factors being thus possible. In particular, the vera e primaria causa can then be assigned unambiguously. However, things are not always so easy. Whether the cause can be analyzed into a neat gradation of factors or not, conjunctive plurality of causes reduces to simple causation, as the various causes CLC2, Cn must be there jointly if the effect is to be p-arguldeust. In other words, conjunctive plurality of causes does not belong to authentic multiple causation but is at most a varioj simple causation. 5.1.3 Disjunctive plurality causes, genuine multiple causation. Genuine multiple causation does not occur with the joint but with the alternative application of causes, that is, when the effect is produced by each cause alone, the joint occurrence of two or more causes not altering the effect. Let us call this the disjunctive plurality causes, to distinguish it from the connection involving the conjunction of causes. An obvious illustration of disjunctive plurality of causes is the variety of processes by which heat can be produced, each of them alone, whether friction, combustion, or the explosion of a nuclear bomb, produces the same effect, not, of course, with the same intensity. Again, a knife, a bullet, or a poison may each alone suffice to cause the death of a man, and their joint application does not alter the effect death. The functional relation E equals F, XL x2, Xn, does not represent faithfully the connection between an effect and its multiple alternative causes. In fact, changes in the dependent variable y may be affected either by the joint variation of the causes XL x2, Xn, or by the variation of each cause alone. That is, the function y equals F, xb x2, Xn, is not only powerless to convey the productivity and unidirectionality of causation, but is moreover formally inadequate as a representative of multiple causation, since it can be correlated to both conjunctive and disjunctive plurality of causes. A convenient symbolization of disjunctive multiple causation is in tens of the compound and/or connective, thus, C1v C2v v Cne. It is just the ambiguity of V which renders it an adequate logical correlate of genuine multiple causation. Strict partisans of causality, like Thomas Aquinas, as well as critics of it, like Hume, have rejected the plurality of causes. Newton's second rule of reasoning in philosophy reads, to the same natural effects we must, as far as possible, assign the same natural causes too, which was a polite manner of dispensing with providence in scientific matters. One of Hume's enunciations of the causal principle contained an explicit reference to the one-to-one reciprocal correspondence characterizing causation. The same cause always produces the same effect, and the same effect never arises but from the same cause. 3 A follower of Hume has held that the plurality of causes results only from conceiving the effect vaguely and the cause precisely and widely. Cohen and Nagel have repeated Russell's contention, holding that when a plurality of causes is asserted for an effect, the effect is not analyzed very carefully. Instances which have significant differences are taken to illustrate the same effect. These differences escape the untrained eye, although they are noticed by the expert. 5 Granted, this is so in many cases, analysis often succeeds in decomposing a plurality of causes, or a diversity of effects, into bundles of causal threads. But what warrants us that this will always occur? It may be argued that to train the eye in order to detect the presumed differences may take centuries, so that the assumption of multiple causation is in many cases at least a provisional working hypothesis, but so is simple causation as well. Multiple causation has been defended, and even taken for granted, by the most diverse thinkers. It hardly needs an elaborate defense unless it is dogmatically postulated that Only one-to-one connections are possible. Rather, simple causation is suspected of artificiality on account of its very simplicity. Granted, the assignment of a single cause, or effect, to a set of effects, or causes, may be a superficial, non-illuminating hypothesis. But so is usually the hypothesis of simple causation. Why should we remain satisfied with statements of causation, instead of attempting to go beyond the first simple relation that is found? The existence of multiple causation is one of the traits of the world that render both phenomenalism and fictionism possible. Think, in fact, of human psychology. One and the same set of circumstances may have different consequences in different persons. Conversely, one and the same pattern of human behavior is usually consistent with several different intentions. Consider the following instance of diversity of effects: a fire breaks out, C. Mr. A behaves in it as a hero, L, while Mr. B runs cowardly away, E2. The puzzle is not solved by analyzing the causes and effects more closely with the hope of explaining away the plurality of effects, but by investigating further factors, such as the conditions and predispositions of the acting individuals, that is, by disclosing non-causal determiners. Thus, while the mere existence of multiple causation is compatible with phenomenalism, both the acknowledgement that it happens to be multiple causation, and the requirement of its further analysis, are incompatible with phenomenalism. We may accept disjunctive plurality of causes or effects, but, whenever possible, we should attempt to explain such multiple connections in terms of further, eventually non-causal, terms. 5I-4 Multiple causation is not strictly causal. Probably the only adequate objection that can be raised against multiple causation is its name, since it is not strictly causal. In the first place, disjunctive, multiple causation, being by definition a one-to-many connection, fits none of the more or less adequate formulations of the causal principle, all of which rightly assert a unique connection, see Chapter 2. As soon as the possibility of a plurality of causes, or of effects, is admitted, the picture of the causal chain ceases to be a possible model of becoming, or at least loses its meaning after a few branchings. In the second place, disjunctive, multiple causation is non-additive. The joint action of causes that might each alone produce the effect does not alter the result. Third, multiple causation goes over into statistical determination as soon as the set of possible causes attains a sufficient degree of complexity and, particularly, if the causes are all of the same kind and order of magnitude of intensity. Thus one and the same equilibrium distribution of a large assembly of molecules can be attained from an infinity of non-equilibrium situations, much in the same way as a stone can reach the floor from an infinity of positions. To summarize, genuine multiple causation, that is, disjunctive plurality of causes, or effects, is often a more adequate hypothesis than simple causation only. It is not strictly causal because it is not a unique and additive connection, and because it degenerates into statistical determination if the causes are very numerous and all about equally important. 5.2. Causality involves artificial isolation. 5.2.1. The universal chaining. The modern approach to historical problems began during the Renaissance, when the characteristic procedure of medieval historiography, the chronicling of events regarded as rather disconnected objects, was replaced by naive causal chains that were supposed to explain historical events in a scientific fashion, see Fig. 13. The new approach was illustrated in masterly fashion by Machiavelli in his writings on the history of Florence. The following is a beautiful sample of the new method. The city of Florence, having after the year 1494 lost a portion of her dominions, such as Pisa and other places, was obliged to make war upon him who held these places, and as he was powerful, they expended great sums of money without any advantage. These large expenditures necessitated heavy taxes, and these caused infinite complaints from the people, and as the war was conducted by a council composed of 10 citizens who were called the 10 of the war, the mass of the people began to hold them in aversion, as being the cause of the war and its expenses, and began to persuade themselves that, if this council were done with, the war could also be ended. Thus when the time came for reappointing the 10, they allowed their term to expire without renewing the council, and committed their functions to the Signoria. 7. Machiavelli's causal chain is simple enough: loss of territory, war, large expenditures, heavy taxes, popular dissatisfaction, fall of the war council. This type of description certainly meant an enormous advance over the dry medieval chronicling of separate events. It showed the links between them and was thereby both explanatory and more faithful. Still, it was an oversimplification, since actually every link in the chain is produced by several determiners, of which the chief one is singled out and mentioned. Besides, the specific nature of every link in the chain matters as much as the whole chain, and that specific nature, characterized as it is by a peculiar structure and by peculiar laws of self-development, remains outside the causal nexus, which is largely external. Finally, causal chains are not as self-explanatory as is usually believed. What is explanatory is not the sequence of links by itself, but rather the host of hypotheses or even theories hiding behind the words designating the various links. 8. The extreme oversimplification entailed by the linear series. The linearity of causation 12.7 of causes and effects was dimly realized even during a century that held simplicity as an ideal, though no longer as an indubitable fact, at least in natural and social matters. Voltaire, who was quite an enthusiast of the enchainment universe in the domain of metaphysics, had at the same time too deep an historical insight, and too extensive an historical information, not to perceive that the explanation of historical events in terms of such chains could lead to ridiculous extremes if applied to long stretches. He therefore made fun of the linear series of causes and effects 9 maintained by the Jansenists while denied by the Jesuits, who were partisans of the arbitrary intervention of Providence in worldly affairs, as well as of absolute free will, which they needed in order to render punishment moral and reward meaningful. However, Voltaire did not explain why it was ridiculous to assume too long causal chains, nor did Diderot, who in Jacques Le Fataliste et son Maître, c. 1774, made fun also of both predetermination and free will. Both philosophers were contented, in this regard, with showing that they had enough esprit. The main ground why causal chains can at best work as rough approximations for short periods of time is that they assume a fictitious isolation of the process in question from the remaining processes. Let us deal with this point in greater detail. 5.2.2 Isolation, fictitious. We saw in Sector 5.1 that, in order that a process may be regarded as causal, either one causal factor or one of the consequences must be singled out of a whole constellation of determiners. Now, such a singling out and consequently the neglect of the complement of what is singled out is valid and even indispensable as a methodological procedure, but it is ontologically objectionable. In fact, it is empirically ascertainable that every event is actually produced by a number of factors, or is at least accompanied by numerous other events that are somehow connected with it, so that the singling out involved in the picture of the causal chain is an extreme abstraction. Just as ideal objects cannot be isolated from their proper context, material existence exhibit multiple interconnections, therefore the universe is not a heap of things but a system of interacting systems. As a consequence, a particular effect E is not only the product of the vera e primaria causae, see Sector 5.1.2, but of many other factors linked with C as well. A whole constellation of determiners is always present in real situations. Conversely, C will produce not only E but many other consequences as well. This will be the more so if the so-called remote instead of the proximate causes of an event are taken into account. As Hegel wrote, in the multiplication of causes which have been entered between it the fundamental fact that is being considered and the ultimate effect, it connects itself with other things and circumstances, so that the complete effect is contained not in that first term which is pronounced to be the cause, but only in this plurality of causes together. 10 To put it in a different way, there are always connections among numerous sets of factors, never connections between single isolable events and qualities, as causality assumes. This being the case, the hypothesis that becoming is a causal chain appears as a one-sided selection out of a rich net of inter 10 Hegel, 1812, 1816, Science of Logic, Toi. 2, p. 195. The linearity OJ causation 12-9 connections, see Fig 14, and also, to some extent, as a hypostasis of logical inference, hence as a partially anthropomorphic, prescientific conception. Yet, the singling out effected by causal thought, while ontologically defective, is methodologically unavoidable. Here, as everywhere else, the mistake consists not in making errors but in ignoring or neglecting them. 5.2.3 Isolation, a methodological requirement. The isolation of a system from its surroundings, of a thing or process from its context, of a quality from the complex of interdependent qualities to which it belongs. Such abstractions, in short, are indispensable not only for the applicability of causal ideas but for any research, whether empirical or theoretical. Indeed, science has no use for brute facts, for they immediately given imagined by Comte, Bergson, and Husserl. It is the concern of science to analyze such mazes of interconnected elements, singling out a few entities and features, and focusing on them with the hope of attaining a better understanding of the whole after the singled out parts have finally been replaced in it. Holists complain that this procedure damages the totality concerned, and this is true, but analysis is the sole known method of attaining a rational understanding of the whole. First it is decomposed into artificially isolated elements, then an attempt is made to synthesize the components. The best grasp of reality is not obtained by respecting fact and avoiding fiction but by vexing fact and controlling fiction. In many cases it is even possible to obtain experimentally such an isolation in an approximate manner and in certain respects, at least in a limited domain of space and for a short time interval. Think of the thermos bottle. The possibility of empirically obtaining fairly complete isolations, of varying one factor without provoking substantial alterations in the remaining variables, refutes the doctrine of the universal unrestricted interconnection, of all existence in all respects. To realize this is both ontologically and methodologically important, but it is also important to realize that perfect isolation is a theoretical fiction. It is by now almost common knowledge that, though what causal determinism does assert often a good approximation, isolation is never complete. Any doubt in this respect should be dispelled upon consultation with an expert in heat engines or in electricity. Perfect isolation in some respect is not so much a fact as a hypothesis that the scientist is forced to make if he wishes to turn the complex interacting systems of the material world into simple, schematic, in short, ideal and therefore tractable objects. Thus it is likely that the birth of modern dynamics, dependent as it was on astronomy, would have been considerably delayed were it not for the following highly favorable and highly exceptional features of the solar system. A. At the mechanical level the system is fairly isolated from the rest of the galaxy. B. The interactions among the planets are also negligible to a first approximation. The importance of these exceptional traits, which make mechanical isolation nearly complete, can be fully realized if it is recalled that no means of shielding gravitational fields have been found, nor are they to be found if the relativistic theory of gravitation is right in maintaining that the gravitational field in a sense constitutes space instead of filling an otherwise empty spatial ferrule. The hypothesis of oscillation, or, conversely, of a non-interfering background, is, then, a methodological requirement of the sciences dealing with the material world. Hence, the fiction of the isolated causal chain will work to the extent to which such an isolation takes place. And this is often the case in definite respects during limited intervals of time. But actually an infinity of neglected factors, Galileo's cause-accident-ary or causality secondary, are constantly impinging upon the mainstream, the chosen causal line, producing in it small modifications that may accumulate, thus eventually provoking the linearity of causation in the long run, an essential modification. 12. As Bernal puts it, such chance variations or side reactions are always taking place. These never completely cancel each other out, and there results an accumulation which sooner or later provides a trend in a different direction from that of the original system. Point 13. Elementary statistical theory usually treats only the simplest case, namely, that in which chance deviations cancel out, so that no significant change in the general trend of the process is produced, the process ending up in an equilibrium state. The mass of small cancelling influences coming from the rest of the universe is of this type. Thus, the gravitational disturbances impinging on the Earth are randomly distributed and do not produce lasting effects on the Earth's orbit, which is stable. Such collections of small influences have been regarded as an irrational remainder. 14 Actually they are not irrational but unknown in detail, although the individual elements are not controllable, the whole mass of the deviations is statistically tractable. 5.2 Plus paradoxes of isolation. Isolation, an assumption underlying every causal hypothesis, entails the assertion that there are entities that remain out of certain causal connections, and this is enough to defeat the doctrine of the universal causal interconnection. That is, theories of universal interdependence cannot be consistently causal, or, if preferred, the more causal they are, the less consistent they are. In Sector 4.2 we have shown that they need not be causal. This is the first paradox of isolation. A second paradox concerns the usual, and wrong, identification of isolation with causality. Partisans of strict causality have argued not only that nature is to be analyzed into mutually what causal determinism does assert independent, isolated, causal lines but also, conversely, that every isolable process is causal, so that causal anomalies can emerge solely as a result of external perturbations, that is, as a consequence of imperfect isolation. This has also been maintained by some propounders of the empirical indeterminacy entailed by the orthodox interpretation on the quantum theory. 15 However, inertial motion goes of itself in complete isolation and in the absence of causes. On the other hand, the disintegration of naturally radioactive nuclei is both a statistical and an isolable process. Granted, the individual disintegration times are not undetermined, since every individual nucleus is supposed to obey some laws of physics, but the fact that the average rate of decay is insensitive to all known external circumstances shows the high degree of self-determination of this process, and consequently its non-causal character. We conclude, then, that partial isolation is a necessary condition for causality to hold, yet not a sufficient one. 5.2.5 Causal chains. A first approximation. The picture of linear causal chains is ontologically defective because it singles out a more or less imaginary line of development in a whole concrete stream, see Fig. 15. Such an isolation of a causal series from the whole complex process, in which the singled out part is regarded as a thread external and parallel to the remaining threads, is but a useful fiction that can be applied only for limited intervals of time, much in the same way as a small arc of a curve can be approximated by the corresponding chord. Soon the initial causal line will either be found to branch, as is the case with the divergent development characteristic of biological evolution, or some of the 1 T A B C, D, E. Fig. 15. Main schemes of processes. Isolated lines of development, causal or not, A. Unilinear, B. Multilinear, parallel. Combined lines of evolution, E. Divergent, branching with emergence of new levels, D. Convergent, interpenetration with emergence of new levels, E. Real, combination of simpler types of development. 133. Branches will be seen to merge with other, initially independent lines, until the whole ends up to continue with picture language in a continuous stream, the convergent development characteristic of cultural evolution. In summary, strict causal lines or chains simply do not exist, but in particular respects, in limited domains, and for short time intervals, they often afford both a satisfactory approximate picture and an adequate explanation of the essential mechanism of becoming. 16. At least two dangers lie in ambush for those who ignore or forget the largely fictitious character of causal chains. The first is, obviously, Leibnizian monadism, the second is the imitation of a contemporary American historian who, in his enthusiasm for causal chains, undertook to prove that all events that happened in the Roman Empire were nothing but the last links of a long one-way chain originating in the internecine wars of the Mongolian tribes. What is often a methodologically sound hypothesis may, if exaggerated, lead to ridiculous extremes. Empiricism has rightly pointed out that rigid causal chains exist only in our imagination. A Humean philosopher has written that the chain manufacturer who made chains having the properties of causal chains would soon be a millionaire. 17 But it is, I think, an exaggeration of Humeans to hold that causal chains are nothing but hypostases of logical inference. The logical figure known as sorites may be taken as a model of a causal chain, for it is a chain of syllogisms in which the conclusion of each is the premise of the next. There is no ground to deny that, if causal chains are valid in limited contexts, it is because they constitute a rough reflection of reality, that is, because there is in the real world something vaguely resembling the causal chain. At any rate, the Stoic conception of the linear chains of successive causes and effects is both nearer truth and more fruitful than the conception of the world as a heap of separate, isolated events that are self-contained or at most initiate circumscribed processes detached from the rest of the universe. The former picture has a limited domain of validity, whereas the latter renders scientific research pointless. In short, causal chains are rough reconstructions of becoming. What is to be emphasized in this statement, rough or reconstruction, depends on the specific nature of the case. 5.3. Causality requires either a first cause or infinite regress. 5.3.I. The two alternatives. Causalism assumes that whatever can be explained at all is to be explained as the result of a cause or as a link in a causal chain. Now, chains may have a beginning or not. If causal chains are assumed to have an absolute beginning, then a first cause is eo ipso asserted to have been operative, that is, an ultimate source of change is postulated, a first mover is imagined, which is itself uncaused and eventually, not necessarily, unmoved by its own action, like Aristotle's unmoved mover, or the one of Neoplatonists. 18. The assumption of a causa prima is, of course, a theological requirement. 19. It has been moreover contended that this hypothesis is not only supernaturalistic but also self-contradictory. 20. Actually, the assumption of a prime mover entails only a limitation on the range of validity of the causal principle, not its negation. It is not self-contradictory, but it is certainly inconsistent with the principle of sufficient reason, which is not a law of change but a principle of knowledge. See Sector 9.3. In fact, this principle demands, in connection with our problem, that a reason be afforded for the existence of a first cause. In order to refute causality in the name of the hypothesis of the causa prima, the so-called secondary, that is, natural, causes have to be deprived of every efficiency. This is actually what Malebranche did. According to his doctrine of occasional causes, God alone has causal efficiency, while natural, secondary, causes are not really causes, producing agents, but rather occasions for the intervention of the first cause. However, neither science nor religions are very interested in this doctrine, which renders science useless and punishment immoral. If, on the other hand, no first beginning is admitted, then causality demands the postulate of the infinite regress of causes and effects. In this way the unrestricted validity of the causal principle is saved, and the extra-scientific assumption of an uncaused first mover is avoided. Unfortunately, the regressus ad infinitum is ontologically fictitious and gnoseologically inoperative. That the infinite regress is ontologically fictitious follows from the fact that the linear series of causes and effects is an oversimplification, valid as a first approximation, but quite useless after a few branchings and crossings. See Sector 5.2. And the infinite regress is gnoseologically sterile, for, instead of explaining the unknown in terms of the known, it does just the opposite. The device is, in fact, supposed to explain the present in terms of a mostly unknown past. 21. But the main shortcoming of the infinite regress is that it does not enable us to begin at any definite stage in the development, requiring instead a continuous unending recession. It does not make room for definite stages in processes, for fresh starts associated with the emergence of qualitatively new modes of being, hence of qualitatively new modes of becoming. It is precisely the existence of levels characterized by laws of their own, and emerging discontinuously in the course of time, that enables us to dispense with the causal regresses ad infinitum, though not with every finite regress. SS 5.3.2. Evaluation of infinite causal regress. It should, however, be realized what a tremendous conquest of thought the concept of regressive chain was, what an enormous progress it meant to acquire the habit of receding back from consequence to antecedents, viewing the latter in turn as results of an unending process. This way of thinking had been practiced by a few Greeks and was thereafter practically lost. During the Christian Middle Ages, infinity was regarded as the monopoly of God. Schoolmen usually dealt with problems separately, each thesis being discussed as a self-contained unit, by means of syllogisms that were eventually connected with one another but not necessarily chainwise as in Sorites, and which always ended up in axioms that were regarded as self-evident, hence as indisputable. The syllogism, rather than the whole logical discourse, was the focus of medieval logic. What the Middle Ages knew was not so much the chainwise process as the static Neoplatonic chain of being, arranged once and for all in agreement with divine law and according to the ethical dignity and power of the links concerned. It is during the Renaissance that the tendency emerges to treat every fact in its actual cosmic context. Theoretical interest shifts from isolated facts to series of facts standing in a genetic relation with one another. In correspondence with this transformation in the scientific and ontological approach, the center of the Renaissance logic becomes what Descartes calls the tongues gens de raisons, though often under the disguise of attacks on formal logic. As was recalled above, Sector 5.2.1, Machiavelli inaugurated the explanation of historical facts, which in the West had been merely chronicled, and explained them as links in long causal chains. The restriction to the Christian Middle Ages is meant to make room for the astonishing scientific approach of Ibn Khaldun. The seeming chaos of historical events is then transformed into an orderly whole, perhaps into an oversimplified contrivance in which no room is left for either chance or design. The Stoic picture of the cosmos, in which everything is tightly connected to everything else, is rediscovered. The regressus ad infinitum became a valuable ontological instrument for such a conversion of the chaotic maze of appearances into a lawful, hence intelligible and controllable, cosmos. The chain of reasons was its logical instrument. To sum up, like so many other concepts, the infinite causal regress played a progressive role, until the very wealth of data that it contributed to accumulating showed its inadequacy. There is infinite regress, but not of the causal type. The first member of this compound sentence is a philosophical hypothesis, whereas the assumption of a first cause is a theological one. The qualification follows from Cs. 5. I and 5.2 and, indeed, from the whole present book. Essay. Causality involves continuity of action 5 plus I. Ground and consequences oj continuary oj action. The causal principle involves continuity of action between the cause and the effect, that is, the absence of gaps in causal lines. 22. This requirement is almost obvious, as every continuity in the causal chain would have to be assigned to the action of an extra cause. Continuity of action does not, however, involve spatial contiguity or action by contact. This was shown in Sector 3.1. Another feature of the continuity characteristic of causality is expressed by the maxim small causes have small effects, meaning that a gradual change in the cause has a gradually changed effect. The contrary proposition, namely, small causes have great effects, is, on the other hand, often regarded as describing chance phenomena, but it also applies to instability. In the beginnings of modern science, this condition was found not only ontologically plausible but even methodologically necessary for the application of the differential calculus to the description of natural phenomena, which is so characteristic of modern science. In fact, the simplest differential equation employed to reflect natural processes is dyj dx equals j, x. If the function j, x, is not continuous enough, it will not be possible to ensure that the equation has a single continuous solution. In other words, if J, X, has not some property of continuity, for instance, piecewise continuity, the process that the solution Y, X, of the equation is supposed to reflect may not go uniquely from one state to another, whence it will not satisfy an essential requirement of causality, namely, uniqueness. Continuity and uniqueness are, in short, closely related. A consequence of the hypothesis of the gradual character of all change, a hypothesis clearly formulated by Leibniz 23, is that the products of change, 2, form a continuous series of intermediate beings. This consequence, of the existence of a plenum hormerum, was of course noticed by Leibniz, who adopted the linearity of causation 139, the old idea of the continuity of living forms, a hypothesis certainly not warranted by facts. 5.4.2 An argument against the continuity of causation. Let us consider the following argument against the compatibility of causation and continuity. A causal bond will be inferred solely provided in a sequence of events there appears in some part of it a neat cut, such that a part of the sequence can be called the cause, and the remainder the effect. This is, no doubt, a condition for acquiring a feeling of causation, or for inferring that we are concerned with a causal process, not with a mere sequence of associated or concomitant events. The argument looks powerful if causation is regarded as only a category of experience. In this case it may be viewed as destructive either of the causal principle, which, as we saw, requires continuity, or of the empiricist reduction of causation to constant association or to uniform succession. It has in fact been employed in the latter sense, and in the following way: the dynamical ground of causality, whether subjective or objective, is perturbation, interruption. As long as a sequence of changes is regular or harmonious, the feeling of causation does not appear. But if an accustomed sequence is interrupted, the feeling of causation awakens instantaneously. Hence, there is an associative thinking, a thought of mere sequence, and a causal thinking, which appears when the sequence is interrupted. 24. This argument is valid if causation is assigned no place at all outside experience, that is, if it is regarded as but a connection among sensations, thoughts, and so on. On the other hand, if the causal bond is regarded as obtaining whether we experience it or not, and if experience at a given moment is seen as illuminating solely a section of objective reality, then the foregoing argument does not show that causality as such involves discontinuity. Indeed, it might be assumed, as Leibniz did with his theory of imperceptible sensations, that the empirical 14.0 what causal determinism does assert cause-effect bond, that is, the link of which we may be aware, is resolvable into a factually continuous causal line. It is, however, true that causalism tends to focus on separate, though connected, events rather than on processes. Moreover, it tends to focus on instantaneous events which are, of course, only a convenient fiction that can be used as a first, rough, approximation to real events. This contradiction between the requirement of continuity, on the one hand, and the habit of causal thinking, of concentrating on separate events, on the other hand, must be faced as a characteristic antinomy of the doctrine of causality, as an unavoidable shortcoming of it. 5.4.3 Criticism of hypothesis of universal validity of law of continuity. I will not argue against the law of continuity, but against the belief in its universal validity, that is, against the doctrine which Peirce 25 called synechism. Various objections can be raised, among them, the following: a. Instability. The simplest, most tractable, facts of the real world are those that take place in conditions of static or dynamic equilibrium or stability. This simplicity is the main reason why such a large part of our sciences of nature and of society are concerned with them, in spite of the fact that stability has always a limited range, and that the most interesting events are departures from stability or transitions from unstable to stable states. Now, in the case of stable states, it is true that, whenever causes are really at stake, small causes have small effects. This rule may even be used to define stability, see Fig 16, a. But in the case of unstable states, Exactly the opposite is true. A small perturbation may lead the system to a very different state, more exactly, to a whole range of states. Moreover, the states following a state of unstable equilibrium are not entirely determined by the cause of the departure from the first state. The cause only triggers a process that it does not entirely control. A typical phenomenon of this kind is the one represented in Fig 16b. A more complex illustration of instability is the discontinuous change, known as jump. Peirce, 1892, Philosophical Writings, chaps. 25 and 26. The linearity of causation 141. A. B. Fig 16. A. Stability. After small departures from the equilibrium position, bottom, the marble returns to it. Small causes have small effects. B. Instability. Small departures originate large effects, small causes have large effects. Effect. In the amplitude of the oscillations of a nonlinear oscillator when the frequency of the driving force attains a certain value, Fig 17. Instability is, in short, a source of causal discontinuity in classical physics. As to quantum theory, according to the usual interpretation, one kind of discontinuity at the atomic level arises just from the existence of stationary states. The transitions between stationary, stable, states are discontinuous. Another kind of discontinuity is the sudden reduction of wave packets, an event which, according to the orthodox interpretation, takes place when the observer takes cognizance of a result of measurement. Nothing warrants, however, that these discontinuities may not be reduced, in the future, to swift continuous processes. 26. B. Quantitative discontinuities. In some cases, if the intensity of the cause is not large enough, its effect, far from being proportionally small, is exactly null. This is characteristic of situations in which energy thresholds or minima are involved. If E, C, and T denote the intensities of the effect, the cause and the threshold, respectively, the cause-effect relation in such cases can be represented in the form E equals F, C, T, with the proviso that E equals 0 for CT. An illustration of this type of law is the all or none law of the firing of neurons. In this case, E is the intensity of the response, and C, T the excess of stimulus E over threshold T. Similar situations are met with in everyday life. Think of the minimum force that is required to start the motion of a car, or to open a door. Such a quantization is even more conspicuous at the atomic level. It suffices to recall the photoelectric threshold, below which photocells do not respond, see Fig 18. Again, visual perception, which at first sight looks like a continuous process, has not only a definite threshold but is moreover composed of a discrete string of events. Every visual impression lasts for a non-vanishing time interval, so that facts occurring in between cannot be recorded by the eye, still busy as it is with the former impression which accounts for stroboscopic phenomena. A simpler instance of quantitative discontinuity appears in processes describable by functions of the type 10x, which at certain critical points change sign abruptly on passing through an infinite value, see Fig 19. The effect not being in this case a continuous function of the cause over the whole range of the variable, the principle of continuity would require us to refrain from using the infinite class of functions of this kind in the factual cases, relegatal. Owe them to the realm of intermediate mathematical. The linearity OJ causation. OT frequency Fig 18. The discontinuity in the photoelectric effect, below the threshold frequency T, the incident light, however intense, is ineffective. 143. Steps. I wonder whether all continuists would be prepared to accept such a mutilation. C. Qualitative discontinuities. There are qualitative gaps among classes of coexistents, and qualitative jumps occur at critical points in processes, this being why they are called critical. An elementary illustration of the latter is afforded by light absorption. A light quantum, in colliding with an atom, may be absorbed by it, hence annihilated as such. First qualitative change, and, if its energy is larger than the atom's ionization potential, an electron will be emitted by the atom. Second qualitative change. If there are qualitative discontinuities, qualitative jumps in processes, there can be, strictly speaking, no continuity of forms, no plenum homorum. This is confirmed by the bare fact that classifications of material existence are possible. If there were no abrupt qualitative differences, at least in some respects, most classification would be impossible, since classifications are based on qualitative differences. A principle of discontinuity is inherent in all of our classifications, whether of mathematical, physical, or biological objects. 27. There are types, though not necessarily fixed, in all domains, and such types, by their very 2 Darcy Thompson, 1942, On Growth and Form, 2nd ed., p. 1094. I-44. What causal determinism does assert. O-__m plus --. Fig 19. The function 10x. A small change in the cause near any of the critical points would have catastrophic effects. Existence. Refute the hypothesis of the strict continuity of forms, which does not invalidate the Darwinian hypothesis that species arise out of varieties. The existence of ambiguous or borderline cases has nothing to do with it. Such exceptions do not show that classification is impossible, as is often argued, but rather that it must be improved. The theory of the endless small continuous variations has then a limited range of validity. And it cannot be argued that the gaps in the series of forms might well be the holes produced by selection in a primeval continuum. This would require an actual infinity of beings in all realms for which the least of necessary conditions, namely, room, would be wanting. Paradoxical as it may seem, real evolution is inconsistent with strict continuity in all respects. The linearity of causation, just as it is inconsistent with the discontinuous emergence of newness out of nothing. 5-4 plus continuity, a hypothesis with a wide but limited range of validity. The hypothesis of continuity has, in short, a very wide but, like every other known law, limited domain of validity. In both nature and society there are processes involving definite quantitative and qualitative changes that violate the continuity required by causality. There is, besides, and as a result of such jumps, the discontinuity of existence. However, it does not follow from this that discontinuities are in all respects ultimate or irreducible. Jumps are to be regarded as real but not necessarily as absolute, that is, independent of contexts and levels. Thus, for instance, we now know that quantum jumps need no longer be viewed as instantaneous transitions, but can be regarded instead, at least according to some interpretations of quantum mechanics, as continuous motions in space and time. Again, the process of evaporation of a liquid is actually discontinuous from a molecular point of view, as molecules and even whole droplets evaporate one at a time, but this atomicity is entirely lost at the molar level, at which the process is continuous. Similarly, the emergence of new qualities or of whole bundles of new qualities, as in the appearance of new stages of development, certainly constitute leaps in some regards, but not necessarily in all. Continuity in some respects is consistent with discontinuity in others, just as change in some respects is consistent with permanence in others. Continuous variables do not replace but supplement integers. Besides, new qualities do not arise out of nothing but always as a result of a process, often one of sheer quantitative variation, and moreover against a continuous background. That which constitutes a leap at a given level may turn out to be the result of a continuous process at some other level, and vice versa. Both continuity and discontinuity are conspicuous traits of the world, and they are not external to each other but arise one from the other. In short, the law of continuity, while it does not enjoy an what causal determinism does assert unlimited validity, is a most valuable tool in the analysis of becoming, not excluding the explanation of discontinuities at other levels. Faith in continuity helped Faraday in founding the field theory of electromagnetism, but it also prevented him from inferring the atomic nature of electric charge, which was almost displayed in his laws of electrolysis. Continuity and discontinuity are complementary categories. The problem is not to reduce one to the other, but to investigate whether continuous processes at one level are made up of jumps at another level and, vice versa, whether jumps are resolved into continuous processes at a different level. The consequence of all this for causality is obvious. The mere fact that the hypothesis of continuity is not universally valid entails a limitation upon the range of validity of the causal principle. 5.5. Summary and conclusions. Only simple causation, to which multiple conjunctive causation can be reduced, complies with the usual formulations of the causal principle, all of which entail the uniqueness of the causal bond. Multiple disjunctive causation is often a more adequate picture of change, but owing to its ambiguity it is not strictly causal. Moreover, when the complex of determinants is complex enough, and when they are all about equally important, multiple causation goes over into statistical determination. Simple causation involves an artificial isolation or singling out of both factors and trends of evolution. It may reflect the central streamline but not the whole process. Isolation is a simplifying hypothesis rather than a fact. It is indispensable and even approximately valid in many cases. Nevertheless, it is never rigorously true. A consequence of causalism is the need of making a choice among an uncaused first cause or infinite regress. The former is a theological, the latter a philosophical, fiction. Infinite causal regress has no cognitive value, since the knowledge of the present is thereby made to hang from the whole infinite ignored past. There is regression, but it is neither linear nor, in particular, causal. The emergence of new levels, that ls, of definite qualitative discontinuities, dispenses us from tracing back the entire past history in every single case. Causal chains are valid along limited stretches. Their validity is sooner or later ruined by branching, convergence, or discontinuity. Continuity is essential to causality, but no more essential to the world than discontinuity, with which it is intimately connected. In summary, the linearity of causal lines or chains is one of the characteristics of causality that restricts its validity, while on the other hand it tempts us with the paradise of simplicity. Yet, such a linear character of causation is not altogether fictitious. It does work in definite respects and in limited domains. Causal chains are, in short, a rough model of real becoming. 6. We have seen, in Sector 4I, that the Romantics criticized the unidirectionality of the causal bond, as contrasted with the allegedly universal mutual dependence. This was a positive contribution of the Romantic critique of causality. Unfortunately, the critique was spoiled by its exaggeration and by the unscientific, foggy, and metaphorical way in which it was stated and argued. We shall try to pick out the intelligible and testable kernel of the Romantic criticism of the unidirectionality or asymmetry of the causal link. But we shall also show the limitations of the interaction category, which can by no means be regarded as a substitute of the causation category in every instance. That is, we shall point out the limitations of causality with regard to reciprocal action, but we shall likewise show that functionalism, or interactionism, has in turn severe limitations. 6.1. Causality neglects the response. 6r.1. A.Remetrio j actio and passio, essential for causality. The causal principle asserts not only a linear but also a uncided dependence of the effect upon the cause, that is, it reflects only the cause plus effect way. It accounts for activity but neglects reactivity. This is clearly shown in the following precise definition of physical causation. From a physical point of view, causality is introduced in the following way: let S be a system capable of acting upon a second system, SF, and let us consider a given modification of the system S, supposing that J48. 149. A certain modification of the system S corresponds to it. If the modification of S is entirely defined, in intensity as well as in direction, by the modification of S, then the latter is called the cause of the modification of S.1. The conception of causes alone as active and productive, and of effects as their passive consequences, has its correlate in the peripatetic dichotomy of substances into agents and patients. Its logical correlate is the belief that the work of reason is nothing but an extraction of consequences out of premises, as if a critical examination of the theorems were unable to suggest the need for a renewal of the very starting points, axioms. The unidirectionality attributed to the causal nexus is perfectly consistent with the doctrine that identifies causation with unique and uniform succession of states, since obviously a state cannot react back upon a previous, already non-existent, state. But we have already seen, CSECS 3.3 and 3.4, that uniquely determined and regular time series may but need not be causal. We pointed out that causes cannot be defined as states, both because the claim of causalism is just that every state is produced by a cause, and because there are processes in which the successive states are not brought about by any causes. As commonly conceived, and particularly as conceived by the doctrine of efficient causation, natural causes are always changes, events or processes, originating other changes. Now, for this type of object, the unidirectionality of causation is often, yet not always, inadequate. Let us begin by giving a few illustrations of this inadequacy. 6.1.2 Reciprocal action in physics. The category of reciprocal action, now universally accepted in science, was quite a novelty toward the end of the 18th century. Some philosophers of the next and even of our own century went so far as to regard mutual action as ridiculous. This was, for instance, the case with Schopenhauer. Yet the simplest of the fundamental physical theories, namely 15.0 what causal determinism does assert dynamics, has at its basis a principle asserting not only the existence of a reaction accompanying every action, but even the quantitative equality of the two. See Sector 4+4. In this, as in other cases, science preceded philosophy. The Newtonian law of gravity is usually regarded as an illustration of causality and even as the paradigm of causality. However, the connection between two gravitating masses is typically non-causal, for it consists in an interaction, not in a one-sided action. In other words, Newton's law of universal attraction, F equals cmm2, r2, is not a causal law, for it is in general meaningless to assert either that the mass m is the cause of the acceleration of m2, or vice versa. Every change produced by ml on m2 reacts back on Mr. the consecutive action of which will consequently differ from what it was previously. Gravitational attraction is a mutual change, not a unidirectional process. Only if one of the masses is much smaller than the other, for example, a stone as compared with the whole Earth, can the greater mass be regarded as the cause of the acceleration of the smaller one, and the reaction of the latter's motion on the motion of the larger mass be quantitatively neglected. Thus, we explain the fall of human-sized bodies to the floor as due to the attraction of our planet, that is, as a one-sided action, although the falling body in turn modifies the Earth's gravitational field. Even though in such cases the quantitative differences, in the accelerations involved, are negligible, as a matter of principle the situation is not altered. In the classical theory of gravitation we are not confronted with causation but with reciprocal action. And, in general, forces denote one side of interactions rather than actually unidirectional actions. See Sector 6.1.3. A similar illustration is provided by the coupling of any charged body with an external electric field. The charge is surrounded by its own field, so that it reacts through its proper field upon any externally applied field and modifies it. If the body happens to be an electron moving in an external macro, the unidirectionality OJ causation plus O F Fig 20. Causal approximation. An electron is accelerated by the electric field between the plates of a condenser. The reaction of the electron's field upon the cause, external field, is quantitatively negligible. Scopic field, such as the one between the plates of a charged condenser, then the reaction of the electron's field on the external field is quantitatively negligible, and we can describe the latter as the cause that modifies the state of motion of the electron. Fig 20. We apply, in short, what can be termed the causal approximation. Generally, in classical as well as in quantum physics, we are in principle able to solve the equations of motion of a particle in an external field of force, in a field that is supposed to be known and that is not appreciably modified by the particle's motion. In other words, we are able to solve problems of interaction in the causal approximation. In some cases this involves no error at all, thus, the dynamical problem of two interacting bodies can, by a suitable choice of the reference system, change from laboratory system to center of mass system, be transformed into the fictitious causal problem of a single, fictitious, body moving under the action of an external force. A physical interaction problem is thereby transformed into an ideal causal problem. Moreover, the causal approximation can be applied, provided the interaction is pairwise, that is, if the sum total of the interactions among the various parts of the system concerned can be described with the help of an array of functions Hj of the relevant characteristics of every pair of components, such as the mutual distance Rij between the ith and the jth molecules of a body. On the other hand, if the system consists, for instance, of polarizable charged particles, the principle of pairwise decomposition of the interaction will not apply. In such cases, one-sided cause-effect bonds will be inadequate idealizations of the actual net of mutual actions. The general problem of finding the motion of two or more particles interacting through their fields with non-central forces cannot be solved exactly. Irreducible reciprocal action is a harder bone than causation. Thus, in the case of two neighboring electrons, each of which moves in the field of the other, see Fig 21, there is no external field, no field common to both particles whose variations are independent of the electron's vicissitudes. The mechanical and the electromagnetic equations are so intimately coupled, in correspondence with the symmetrical character of 153. The interaction, that the causal approximation is not valid in this case. 6.1.3. Force as one of the poles of interaction. This is perhaps the place to point out that particle dynamics, not, however, the whole of mechanics, treats forces as if they were external to the bodies on which they act. More exactly, particle dynamics deals only with external causes of departure from inertial motion. This has not, however, the ontological meaning that is usually imagined. It does not mean that mechanics denies self-movement, see sector 4.4.2. It has merely a methodological value, for, as soon as we enlarge the system in question so as to include in it the bodies producing the forces in question, thereby obtaining a free system, we realize that, it is a question of reciprocal actions among different portions of matter rather than of forces acting ab extrinseco on a given portion. This point was brilliantly elucidated by Maxwell. The mutual action between two portions of matter receives different names according to the aspect under which it is studied, and this aspect depends on the extent of the material system which forms the subject of our attention. If we take into account the whole phenomenon of the action between the two portions of matter, we call it stress. But if we confine our attention to one of the portions of matter, we see, as it were, only one side of the transaction, namely, that which affects the portion of matter under our consideration, and we call this aspect of the phenomenon, with reference to its effect, an external force acting on that portion of matter. The other aspect of the stress is called the reaction on the other portion of matter. Two physical action and reaction are, then, two aspects of a single phenomenon of reciprocal action. But, in order to treat phenomena with the available conceptual apparatus, it is often convenient to focus on one aspect at a time. Then, causation is artificially enhanced at the expense of reciprocal causation, as has so often been remarked by dialecticians. 3. The fact that most tractable cases are precisely those in which the causal approximation is valid makes us forget that such cases are quite exceptional, reality being on the whole feebly causal, or at least a lot less unidirectional and linear than most philosophers of causation have imagined. If preferred, reality is a richer causal structure than the one assumed by the theory of causality. 6.1 Plus causality and feedback. The inadequacy of asymmetrical causation, as opposed to reciprocal causation, is being acutely felt in contemporary technology, where the concept of feedback, or rather its conscious use, has become indispensable, at least in the domain of control. As is well known, in devices endowed with negative feedback, such as automatic heating systems, a part of the output, effect, of the system is sent to a control instrument and is then fed back, as a correction signal, to the motive force or energy source, cause, as a consequence of which the output itself is changed. See Fig 22. One of the oldest devices for automatic control is the governor, see Fig 23, invented by Watt, 1788. When the engine runs too fast, the balls B move outward, and by so doing they tend to close the throttle, thus slowing down the speed of the machine. And when the engine runs too slowly, the balls tend to open the throttle. An engine with a governor, or with an equivalent automatic control device, is a self-regulating system, in which a small part of the input energy is used to compensate for undesirable changes in its functioning, for example, those produced by random variations in the environment. The process that goes on in automatic machines has been called a causal cycle, in contradistinction to linear and one-sided causal series. For this designation is correct, for in mechanisms. What causal determinism does assert endowed with self-correction devices, the cause, input, and the effect, output, are connected through reciprocal, not through unidirectional, causation. The determinants of the system constitute a loop of interdependent factors, and this is what makes it a self-regulating system. Of course, feedback can be analyzed into a set of asymmetrical causal stages, but the process as a whole is dominated by the interaction category. The causal net is not causal itself. Here, as elsewhere, possibility of analysis does not entail reduction, and explanation of the mechanism of emergence does not explain emergence away. 6.5. Interaction in the social field. That causation is often a one-sided approximation to interaction is rather obvious in biology, and more in social matters. Take socio-political ideologies. They grow in a given social and cultural matrix. They are effective solely to the extent to which they adapt themselves either to the prevailing social structure or to social movements engaged in attempting its modification, but, besides being the children of objective social situations, ideologies may react back on the system of social relations in the midst of which they grow, helping either in the conservation or in the modification of the very conditions that had elicited their emergence. Orthodox cybernetic Ians would attempt to frame all this in technological terms, saying perhaps that conservative ideologies are nothing but instances of positive feedback, since they tend to enhance the cause, whereas revolutionary ideologies illustrate negative feedback, as here the effect tends to oppose the cause. 5. Despite the almost obvious fact that the various aspects of social life act upon one another, most sociological theories and meta-histories assert a one-way action of one of the factors over the remaining ones. Suffice it to recall, in this connection, the following doctrines: geographic determinism, racial determinism, historical idealism, and economic determinism. However, most contemporary social scientists would be prepared to admit that interaction rather than causation is the prevailing category of determination in social matters. Yet nobody, except functionalists, regards society as a muddle of reciprocal actions standing all on the same footing. The various social functions are usually acknowledged to rest ultimately upon work, upon material production, upon economics, just as the highest functions of the organism are ultimately dependent on the intake of food, oxygen, and heat, however much this feeding may in turn be affected, in particular, controlled, by the higher functions. In either case, the dependence upon the material basis is ultimately one-sided in the majority of important cases, but at crucial points the arrow may be reversed, and the dependence is rarely direct unless the levels are contiguous, as happens, for instance, with the economic and the social levels. Moreover, the dependence is not a strictly causal one, since a host of categories of determination intervene in it. It takes a causal aspect if the inner mechanism is overlooked. Once again, Pure causation is a feature of superficial analysis rather than the typical pattern of change. 6.1.6 Interaction in the theory of knowledge. Typically, causal theories are the naturalistic and the sociologistic views of knowledge, according to which all human knowledge is merely a reflection of the human natural or social environment in the human mind, so that no department of organized knowledge can evolve, at least partly, according to its peculiar, inner logic. According to these theories, nature or society are the cause of knowledge, and knowledge is a passive effect. In particular, many sociologists of knowledge, whether they call themselves Marxists or not, tend to regard all sorts of products of spiritual activity, not excluding formal logic, as if they were mere reflections of the relations of material production, and as if the work with feelings and ideas had not laws of its own. To the materialist trend of empiricism, the inner world of sensations merely reflects the external world, without adding anything of its own, save the eventual distortion of the image. To subjectivistic empiricism, on the other hand, things are experiences, so that there is no division between the inner and the outer world, or, if preferred, everything is in the inner world and consequently no problem concerning the adaptation of the one to the other arises. At most, the question of the internal coherence between the perceptual and the conceptual strata can arise in this theory. Thus, Mach wrote about the progressive adaptation of thought to fact, and even of the Copy-Nachbildung of fact in thought, but his facts were just sensations and, in general, experiences, so that the adaptation was an affair of internal coherence between two layers of knowledge, the sensible and the conceptual. 6. The variety of empiricism that grants the autonomous existence of the external world usually holds that man is solely able to reflect, in a passive manner, a reality that is given to him and that he apprehends as when we pick up a coin lying on the floor. The human mind can only combine ready-made elements supplied to it by the senses, but is incapable of creating new, ideal, say mathematical or philosophical, objects lacking an empirical counterpart. Ideas are, then, either products or recollections of previous impressions, including those furnished by that vague internal sense which Locke and Hume employed as an emergency entrance whenever the empirical counterpart of an idea was not apparent. All ideas stem, in short, from the senses, and only their combinations or, rather, juxtapositions can produce anything different from what is experienced. The subject-object relation is thus reduced by this branch of empiricism to an instance of the Aristotelian dichotomy of patient and agent. This example of a causal theory of knowledge shows, I think, how intimately connected epistemology and ontology are, and how general ontological hypotheses, like the law of causation, may favor or hinder the clarification of epistemological issues. The doctrine of causation has, in fact, contributed to framing both objective idealism and the reflection theory of knowledge. Conversely, the realization that in the vast majority of cases, the unidirectional oj causation 159 there are no one-way roads, owing chiefly to the larger or smaller extent of autonomous activity in every material existent, suggests that there are no one-way roads to knowledge or from knowledge. In recent times, the question of the relation of ideas to the specific structure of the society in which they arise and spread, or succumb, has been discussed from many angles. This question has at least two sides, a psychological and a sociological one. The psychological, or rather psychosociological, problem concerns the way in which certain ideas are suggested by the prevailing social organization and by the characteristics of material production. The other facet of the problem, sometimes referred to as pragmatics, is the responsiveness or the indifference of a given social organization to a certain idea. This is perhaps the central concern of the sociology of knowledge. Although the systematic approach to the former problem is quite recent, one result of it is certain, namely, that some general ideas on the constitution of the world and on the nature of divinities are suggested by the prevailing social organization. For example, the early Mesopotamian and Mexican divinities were organized in the image of the primitive democracy peculiar to the first city-states. But it is not possible to expect a precise reflection or an exact adequacy of ideas to social facts. Granted, ideas are the product of an active process that gathers much raw material from the external world, but ideation has laws of its own, which at the logical level are neither physical nor physiological nor psychological nor social and, moreover, ideas, when grasped by people, are apt to react back on the soil that nourishes them. Of all the ideas that are produced during a given period by a given social group, the group adopts only a few or even none. This should suffice to show that the alleged reflection is at least very distorted. In the domain of knowledge, it is not a question of unidirectional influence of the environment on the cognitive subject, but rather of a process of interaction and integration. Knowledge of act, as contrasted with formal knowledge, which is not directly concerned with material objects except in a psychological sense, is true to the extent to which it is coordinated with the external world. 7. But adequacy, or, better, faithful reproduction, which is metaphorically called reflection, is anything but an engraving on a tabula rasa. It is, on the other hand, an outcome of a peculiar activity of the knower, of a process of creation in which the subject places himself in mutual action with his natural and artificial surroundings. 6.1.7 The relation of the category of causation to that of interaction. Essentially, three views have been propounded with regard to the relation of reciprocal action to causation. One is the placing of the two categories side by side, the second is the subsumption of interaction under causation, the third is the converse subsumption of causation under reciprocal action. The first view was held by Kant, the second by Russell 194s, the third by Hegel. We shall not deal at this stage with the view according to which interaction is just entanglement of causal lines whence causation is the primary category, because this claim of causalism has been examined earlier in this chapter. Having before him the successful all-explaining theory of universal gravitation, which furnished at last a scientific basis for the old doctrine of universal interdependence, Kant realized that causation does not exhaust determination. He therefore included reciprocal action, under the names of Gemeinschaft, community, and Wechselwirkung, reciprocal action, in his table of categories 9, though he retained the scholastic notions of agent and patient. Reciprocal action was also one of the Kantian analogies from experience, side by side with causation and restricted to the instantaneous mutual action among existents, much in the same spirit as the Stoa had postulated the universal sympathy side by side with the causal chains. Moreover, reciprocal action was to Kant the fundamental law of coexistence, providing a connected picture of the world at a given instant, just as causality provided, to indulge in an anachronism, a motion picture of the universe. As is well known, instantaneous interconnections are now rather outmoded, though not entirely excluded as a possibility. What matters for our present concern is not, however, the unavoidable aging of Kant's ontology, but the fact that he placed the principle of causation and the principle of reciprocal action side by side as mutually independent axioms, which, incidentally, illustrates Kant's characteristic petrification of differences. Hegel, on the other hand, maintained that causation, far from being external to interaction, is nothing but a particular case of it. He described mutual action as gegenseitige Causality, reciprocal causation. Moreover, interaction was regarded by Hegel as a stage in a process. 1. According to Hegel, then, cause and effect are but the two poles of the interaction category, which realizes the causal relation in its complete development. 12 Besides, in Hegel's system of objective idealism, the category of interaction enjoyed an ontological status, whereas Kant had treated it, alongside the remaining categories, as a purely epistemological element, and even as prior to experience. The materialist disciples of Hegel retained and developed his teaching on the interaction category, holding that the cause-effect connection should not be conceived as an irreconcilable antithesis but rather as a stage, or moment. In the Hegelian jargon, in a many-sided and changing connection, cause and effect become confounded when we contemplate that universal action and reaction in which causes and effects are eternally changing places, so that what is effect here and now will be what causal determinism does assert cause there and then, and vice versa. 13 Although Marx and Engels regarded causation as a hollow abstraction, holding instead that interaction is the dominant category. They did not reject the notion of causal nexus altogether but recognized its working at exceptional points. During crises. 14 Among dialecticians there is a definite tendency to subsume causation under reciprocal action, however. Neither Hegel nor his materialist disciples indulged in functionalism in the working out of special theories. In practice, if not always in philosophic theory, they did not replace causation by reciprocal action but recognized and even emphasized the existence of decisive factors or primary agents, such as mind in Hegel's system and matter in the theories of his materialist followers, from Feuerbach to dialectical materialists. Let us take a closer look at functionalism, a preliminary criticism of which was advanced in Sector 4. J. 6I.8. Exaggerations of interactionism. Let us agree to call interactionism, or functionalism, the view according to which causes and effects must be treated on the same footing, in a symmetrical way excluding both predominant aspects and definitely genetic, hence irreversible, connections. While this view is legitimate in many cases, notably in dynamics, it has no general validity, and its universalization may be regarded as a hasty extrapolation of the mechanical principle of the equality of the action and the reaction. Interactionism certainly supplies a faithful account of facts in simple cases like static gravitational interaction, where the one-sided picture of causation utterly fails, see Sector 6.1.2. But interactionism fails as a universal theory, if only for the simple reason that material objects are in a state of flux, so that generally the action has over the reaction the definite advantage, to use an anthropomorphic expression, of priority in time. The systematic replacement of genetic connections by functional interdependence, in which the interacting factors are regarded as equivalent aspects of one and the same thing, may lead to a muddle, as illustrated by most meson theories of nuclear forces. These theories aim, among other things, at accounting for the transformation of some particles into particles of a different kind, such as the conversion of pions 17 into muons with the emission of neutrinos V according to the scheme 7T foot plus V. In this case, the parent particle, 17, is unstable, it decays spontaneously, that is, without any known extrinsic cause, though presumably as a result of an inner process, with a lifetime of about 0.02 of a microsecond. This is an irreversible, typically genetic process, the thing furthest from an interaction, despite which meson theories usually treat this process as if it were a mutual action among coexistents. More exactly, the parent-child connection existing between the pion and its descendants is described as an interaction eliciting that very transition despite the fact that the products are not yet born. If functionalism is pushed far enough, it can even lead to a teleological view of physical reality. Indeed, if, as usual, only ordinary, retarded, forces are employed in electrodynamics, then the mechanical law of action and reaction is violated in a certain sense. In fact, the action of charge I on charge 2 is followed by the reaction of charge 2 on a charge 1 that has already passed into a different state, since charge I will have changed during the time interval between the action and the reaction, hence, the reaction will not equal the action. But the chain of action and reaction can be completed so as to satisfy functionalism, if advanced forces are introduced alongside retarded ones. I6 Such advanced forces behave in a premonitory way, moreover, they represent the action of a still unborn future on the present. To avoid relapsing into medieval teleological science, a return that, needless to say, no experiment forces upon us, we have to relinquish the functional view of the complete exchangeability of cause and effect. We must reject, in short, the typically romantic notion that the distinction between them is superfluous 17 or pointless 18, unless we are willing to fall into the state of the man who, upon remembering his burial, hoped to be born. But where interactionism can be and has been more misleading is in the field of the social sciences, and particularly in the sociology of culture. Here again we find the soothing functionalist theory according to which it is pointless to seek for ultimate or long-run determiners, since everything is resolved into a net of interactions. It suffices to recall, in this connection, the fluctuations of the French materialists of the 18th century, who could not decide whether ideas mean nothing as compared with the milieu that gives them life, or whether the social environment is produced by opinion. 6.1.g. Does dialectics require the subsumption of causation under interaction? The comfortable and uncompromising doctrine of interactionism, often hailed as dialectical, can be no less confusing and sterile than the view that regards every determination as the result of the one-sided action of an agent on a patient. It is certainly important to discover the mutual actions among the components of a system, to account for the reactivity as well as for the activity, but the disclosure of interactions need not always exhaust the problem of determination, unless an extreme symmetry is at stake. It is also important to realize that, not every interaction is dialectical, unless it is agreed to attach the label dialectical to every sort of change, whether qualitative or not, which would render the word dialectics inoperative. Not every interaction produces a qualitative change, only the interpenetration type of interaction, characterized by the mutually determined qualitative modifications in heterogeneous interacting systems, should properly be described as dialectica P9, whence dialectics cannot be regarded as an exhaustive theory of change. 2. The interplay of a large number of entities, whether similar or not, may result in a system having qualities of its own, which do not characterize the individual components. This may happen whether there is a direct interaction among the individual components or not. The growth of heavenly bodies through accretion of small particles, determined by gravitational interaction, illustrates the first type of emergence of wholes, an example of the formation of totalities in the absence of significant interaction among the parts is afforded by the statistical aggregate of a large number of free, or nearly free, molecules constituting a mass of gas, in this case interplay within a common environment, rather than reciprocal action, is what determines the new, molar level of qualities that emerge out of the microscopic level. 3. Decisive changes are produced not only as a result of the interpenetration of heterogeneous entities and as a consequence of the interaction or the interplay of numerous homogeneous entities. Qualitative changes may also be brought forth by the definite predominance of one of the concerned determiners, even if such a predominance is not constant but obtains in the long run, despite relatively infrequent reversals of the dependence bond. In short, interaction is not a universal substitute for causation, nor is causation to take the place of reciprocal action. The relation between them should be investigated in every particular case, instead of deciding once and for all that one of these levels of determination is the fundamental one. Of the summative character of causes and effects. The hypothesis of the summation or superposition of causes holds that the factors that make up an effect act independently of one another, that is, even if they act jointly they behave as an aggregate and not as a combination, synthesis, or whole having qualities of its own that had been absent from the separate addends. According to causalism, whether mechanistic or not, causes may certainly add or subtract, as when two oppositely directed forces are applied to a body, they may interfere constructively or destructively, as in the case of waves. But the association of causes will not constitute a novelty in itself. In general, such a conjunction will produce a quantitative change only, that is, an increase or decrease of certain effects, not however the emergence of new traits. This is the hypothesis of the summative character of causes. The additive character of causation is involved in the very notion of the causal analysis of a given situation. In fact, such an analysis consists in the decomposition of a complex determinant into a sum of causes, or in the separation of a given result into the separate contributions of the individual components or aspects of a system or process. The 17th century called this the analysis of the given idea into simple ideas. 20. Causal analysis is analogous to mechanical analysis but not identical with it. The former decomposes determiners into causes, the latter decomposes things into mechanical units such as simple machines. That the hypothesis of the independence or superposition of causes and effects is vital for causality can be seen not only from the fact that it follows logically from the isolability of causal lines, see sector 5.2, and from the neglect of reciprocal action sector 6. but also from the fact that the non-additive joint action of different causes, that is, the production of causal syntheses or wholes, might well end up in non-causal entities. The synthesis or integration of causal factors is increasingly being recognized. A fashionable illustration is the perception or Recognition of perceptual universals, such as squareness or sweetness. The external configuration or gestalt of perceptible entities seems to be perceived as an integrated whole rather than as an aggregate or sum of elementary perceptions. However, the non-additive composition of causes is not an exclusive property of the higher levels, although it seems more conspicuous in them, or at least more clearly discernible than in the inorganic levels. As we shall see in the following, the so-called organic type of connection occurs in physics, and the non-integrative and yet non-causal formation of wholes out of large numbers of nearly independent entities is typical of statistical determinacy. In either case, the result, or effect, is qualitatively different from the components. Organic, or mutually integrative, connections can be found in all sectors of material reality. This fact has been used in support of organismic ontologies and intuitionistic epistemologies. It is, however, the common property of all ontologies that do not restrict themselves to causal determinism, mechanistic reductionism, or both. In physics, nonlinearity illustrates non-additive connectivity. Nonlinear systems do not obey the principle, theorem, of superposition, offworks, displacements, and so forth, a law that plays a chimeral role in most physical theories, such as mechanics, optics, electromagnetic theory, and quantum mechanics. 21. The principle of superposition may be regarded as the specific form taken in physics by the hypothesis of the independence of causes. If applied to forces, mechanical causes, it states that the joint effect of a number of forces applied together equals the vector sum of their effects regarded as acting separately from one another. In connection 168, what causal determinism does assert with vibrating systems, the hypothesis states that any given oscillation can be decomposed into a sum, or an integral, of separate elementary oscillations. Whenever the principle of superposition is abandoned, the components concerned, oscillations, forces, and so on, are no longer regarded as acting independently of one another. They are instead allowed to interact, producing phenomena that differ widely from those happening in linear systems, such as instability of certain states, discontinuity of certain changes, occupation of certain modes of vibration, and so forth. Therefore, only nonlinear field theories account for the reciprocal actions of particles when the latter are regarded as condensations or singularities of fields. This is why the relativistic theory of gravitation, a nonlinear field theory, does not need to postulate any extra equation of motion for the gravitating masses besides the field equations, which contain the description of the motion of the particles. The fact that nonlinear theories are rare is not so much a peculiarity of nature as a sign of the infancy of our science. Nonlinearity involves large mathematical difficulties. Besides being mathematically clumsy, it affects the very symbolic representation of physical entities. Thus forces that add nonlinearly, as gravitational forces do, cannot be exactly represented by vectors, since the addition of the latter conforms to the superposition principle. From the moment it was discovered that the laws of ferromagnetism are nonlinear, it has been more and more clearly suspected that all physical phenomena may turn out to be at least weakly nonlinear, linearity being only an approximation which is excellent in some cases but only rough in others. Since nonlinearity entails non-causality, we see once again that causality is a first approximation, that it is, so to speak, a linear approximation to determinism. 22. 6.2.3 Randomness as further illustration. OJ non-additivity. OJ causal factors. Equilibrium states, such as are studied by statics, are the result of the cancelling out of opposite forces. Likewise, dynamical equilibrium, as studied by dynamics, is a state of motion resulting from the harmonious, non-destructive, interconnection of opposite trends, in which none of them prevails overwhelmingly over the others. In either case, nothing radically new arises from the joint action of several homogeneous entities, Mechanical behavior results here from equally mechanical conditions. Statistical equilibrium, on the other hand, is characterized by radically new qualities, although it may emerge from the joint action of independent homogeneous factors. This is why, from a molar point of view, it is uninteresting to trace the macroscopic states of a mass of gas to the individual trajectories of the molecules. Not only would it be practically impossible to do so, at least with the available means, owing to the enormous complexity of the microscopic situations and to the experimental impossibility of distinguishing the separate molecules without in addition introducing significant disturbances in their states of motion, it would, moreover, be quite useless to perform such a causal analysis, since the thermodynamic properties of such a molar body, its temperature, specific heat, entropy, and so forth, arise out of its atomic properties but stand on a different level of their own, being meaningless in connection with the individual components of the large system. An even more striking result of the non-additive interplay of nearly independent processes is the distribution of the results of observation or measurement of a given property. A series of independent measurements of the intensity of a given quality constitutes a whole rather than a mere heap of altogether disconnected elements. Indeed, some of the properties of every one of them are determined, at least partly, by its membership in the statistical ensemble. Thus, the probability of every individual error of measurement in a given series will depend on statistical, collective properties, such as the mean value, the scatter around it, and so on. The overall and long run. 17.0 What causal determinism does assert behavior of large collections of whatever kind is studied by statistics. In this science, which is a real propedeutic to the so-called empirical sciences, the large number of intervening entities is not an obstacle to successful analysis but is, on the contrary, a condition of success, since averages, scatters, correlation coefficients, and other collective properties are the more stable the larger the number of constituents, and because the usual concept of probability can be applied provided a certain stability, of the frequency ratios, exists, a stability requiring, among other things, a large number of entities, so that a cancelling out of small individual deviations can occur. The case of statistics shows, I believe, that, contrary to what organismic philosophers claim, totalities or wholes can arise in the absence of systematic integration of the individual components, that is, wholes can be formed not only on the basis of a strong coupling among the parts of a system, but also by the mere existence of an environment common to mechanical or non-mechanical elements behaving almost independently of one another, that is, in such a way that there are no constant relations between any two elements in the collection. In other words, a definite regular collective behavior may arise from an aggregate of individual random, that is, mutually irrelevant, motions. 6.3. Summary and conclusions. A severe shortcoming of the strict doctrine of causality is that it disregards the fact that all known actions are accompanied or followed by reactions, that is, that the effect always reacts back on the input unless the latter has ceased to exist. However, an examination of real processes suggests that there are often predominantly, though not exclusively, unidirectional C_E actions. Causality may be a good approximation in cases of extreme asymmetry of the cause and the effect, that is, when there is a strong dependence of the effect upon the cause, with a negligible reaction of the output upon the input and, of course, whenever the cause has ceased existing. In other words, the polarization of interaction into cause and effect, and the correlative polarization of interacting objects. The unidirectionality of causation 17.1 into agents and patients, is ontologically inadequate, but it is often a hypothesis leading to adequate approximations and, more often than not, it is the sole practical course that can be taken in many cases, owing to paucity of information and theoretical instruments, hence, it is methodologically justified in many cases. But such a success is not justified in itself. If it is successful, it must be because it is rooted in the nature of things, because in reality most reciprocal actions are not symmetrical. The frequent asymmetry of interactions, as well as the fact that processes in which the antecedent disappears altogether cannot be described as interactions, although they involve reactions upon different objects, renders interactionism inadequate as a universal doctrine. Causation cannot be regarded as a particular case of interaction, because the latter lacks the essential component of irreversible productivity. Real determination is probably neither wholly causal nor strictly functional. However, in some cases determination can be approximately described as causation, and in other cases as interaction, which suggests that sometimes we are in the presence of predominantly, but not exclusively, causal processes, whereas at other times we are confronted with predominantly, but not exclusively, functional dependencies. It is likely that in most events both causation and interaction take part, in combination with other determination categories. In general, the interaction among individual entities, and sometimes even the mere interplay in the presence of a common environment, may produce supra-individual entities having qualities of their own and behaving, at least in some respects, as self-contained units. Hence the independence of causal factors, assumed by causality, does not entail the independence of the effects. More often than not, independence is a hypothesis necessitated by the paucity of knowledge or by technical difficulties encountered in the application of available methods. In the long run, the hypothesis of the superposition of causes is found insufficient in this or that field of research, as initially independent lines of development may fuse together, producing a trend with important non-causal aspects. This is illustrated by nonlinear systems and by statistical populations, in both cases. What causal determinism does assert what may be termed causal syntheses in contradistinction to causal aggregates are at stake. Yet, the tremendous historical and methodological importance of the hypothesis of the approximate independence and hence superposability of causes should be realized. An entirely organismic approach to reality, as the one preached by contemporary holistic philosophies, would be powerless to perform that dissectio naturae demanded by Bacon, which gave us and is still giving us modern science and its applications. The more or less explicit recognition of the principle of superposition of determiners, on the other hand, makes an analysis of real situations possible. Most of our science involves it. The exteriority of causes, like the remaining defects of the doctrine of causality, should then be criticized from a progressive standpoint, that is, from a point of view which, instead of proclaiming the utter impotence of the analytic method, acknowledges instead that causal analysis is not the sole kind of analysis needed in the scientific treatment of problems of determination. A constructive critical attitude toward the problem of the superposition of causes should rely on the recognition that the neat separation and isolation of determiners, while not the last stage of research, is a very important preliminary stage, whereas the tenet of the unanalyzability of wholes blocks ab initio every advancement of knowledge. The hypothesis of superposition is, then, neither an absolute truth nor utter nonsense. Like so many simplifying hypotheses of science and philosophy, it is true to a first approximation. Once more, we conclude that causation does not exhaust determination, but the latter necessarily entails the former as one of its varieties. 7. The externality of causation. Efficient causes are, by definition, extrinsic determinants. An important contribution of the criticism of causality performed by the Renaissance philosophy of nature and by the Romantic nature philosophy was to point out the insufficiency of the externality of causation. The emphasis on the inner springs of change, suggested to both Renaissance and Romantic philosophers by the processes of life and mind, as well as by the Hermetic tradition, was, however, both exaggerated and largely speculative. These philosophers overestimated the relative weight of intrinsic determiners at the expense of environmental conditions, and they were not eager to offer some sort of test of their statements. As in the criticism of the unidirectionality of causation, I shall here attempt to show the profile of the rational kernel of the Renaissance and the Romantic criticisms of the externality of causation. As elsewhere in this book, most illustrations will be drawn from contemporary science, which affects the long-sought synthesis of external and internal determiners, thereby retaining and limiting the rival doctrines of the omnipotence of external factors and of the sufficiency of self-determination. Active 1, it is, moreover, an agent acting on things ab extrinsico and one that cannot act on itself. The efficient cause is, in short, an external compulsion, hence, an essential mark of efficient causation is externality, see Sector 2.1. On the other hand, although the term internal cause has occasionally been employed, inward principles, conditions, drives, and so forth are in modern times usually described as non-causal. Thus Bruno too distinguished clearly two contributions to the constitution of things, the principal or inner component, and the cause or external component, the former being that which intrinsically concurs to the constitution of the thing and remains in the effect, while the cause is that which extrinsically concurs to the production of things. Intrinsic determinants such as inner stresses might of course be counted among causes, but such a linguistic convention would run counter to the traditional nomenclature and would suggest an extrapolation of causality to cover the whole range of types of determination. However, it should be warned that, although causal explanations are framed in terms of environmental agents, not every account of being or becoming in terms of the action of the environment need be causal. In order to be causal, an explanation must assign the whole power of origination or production to what is outside the object concerned. The recognition that extension, duration, and mass are not intrinsic but relational properties has therefore nothing to do with causality as long as the very existence of the properties is not attributed to the action of the environment. On the other hand, Mach's attempt to regard the mass of every body as the result of the sum total of its dynamical connections with the rest of the universe matches with causalism. Indeed, despite Mach's abhorrence of causality, his account of mass is causal, because he assigns the very origin of that property to the environment and, moreover, in a way reminiscent of Aristotelian dynamics, since the whole weight is put on the environment. 3. 7.1.2 The peripatetic principle quod movetur ab alio movetur. The slogan of causal determinism in connection with the problem of change is the peripatetic dictum, quod movetur ab alio movetur. Whatever moves is moved by something else. For to causalism nothing can move by itself, nothing can change on its own account, but every change evidences the presence of an efficient cause, of an agent acting extrinsically upon the patient. A contemporary Thomist Schoolman has put it clearly enough: the subject of change is never changing, it is being changed. The thing which is undergoing change is a patient, a possible, and it needs an agent distinct from itself to effect the change. 5. This axiom, vital for theology, is also a capital principle of classically oriented systems of metaphysics, such as N. Hartmann's, as well as of the ontology of common sense. Before atoms, fields, and radioactivity became pieces of common knowledge, even scientists could be found to share the belief that brute matter is a homogeneous, unorganized, and quiescent stuff entirely lacking spontaneity. 6. The matter, in short, dreamt by immaterialist philosophers. From the fact that every experiment is an encroachment on matter, they jump to the Aristotelian conclusion that matter is nothing but the barren receptacle of forms, a belief still held in esteem by those quantum theorists who hold that it is the experimenter who produces all atomic, scale phenomena. The inner processes of the changing object do not count and may not even exist for the doctrine of efficient causality. Every change is conceived by this theory as the inevitable result of a cause external to the changing thing. Nothing but God can be self-caused or causa sui, everything else is the effect of a causa transiens, never the result of a causa immanens or of the joint action of external and internal determiners. The whole of nature is therefore a principium passivum, not a causa esse movens. Nature were self-moving, God would be supernumerary. The consistent elaboration of this doctrine leads to the denial of every sort of natural determination, since, applied to the sum total of existence, the thesis of the externality of determination means that only a power external to the whole universe may elicit changes in it. This step was actually taken by Malebranche, who, from the assumed passivity of bodies, Platonic prejudice, and souls, empiricist tenet, conjoined with the Cartesian assumption of their radical heterogeneity, concluded that there is no causal relation whatever between a body and a spirit. What am I saying? There is none between a spirit and a body. Moreover, there is none between one body and another, none between one spirit and another. No creature, in short, can act upon any other creature with an efficiency of its own. 7. I.3. Causal determinism opposes self-movement. Let us begin by agreeing to call spontaneous whatever develops from within a given object, and not that which is lawless, since according to an initial assumption of ours, see Sector 1.5.1, everything is determined in accordance with law. Now, causal determinism neglects and even denies the inner, spontaneous activity of things, which the German Romantics had termed Selbsttätigkeit, self-activity. Modern causal determinism is, in a way, more restrictive but at the same time more realistic than the Aristotelian doctrine of causes, which, besides the external causes, efficient and final, recognize two intrinsic causes in every existent and in every change, namely, the material and the formal causes, see Sector 2.1. It is, of course, possible to employ the term internal cause in explaining how internal conditions combine with external ones in a given process. 8. But such a discourse will transcend the scope of the modern doctrine of efficient causation, which is usually meant to deal with efficient, motive causes alone, at least since the breakdown of scholasticism. 9. Chance phenomena might also be described as the result of fortuitous or accidental causes, as was common in antiquity, but, again, such a way of speaking is misleading, since it overflows the doctrine of causality, which does not admit fortuitous causes although it may grant the existence of accidental effects, brought forth by the conjunction of initially independent causes. When self-movement and the consequent self-determination are taken into account, when events are regarded not solely as results of external circumstances and forces stamping their seal on passive stuff but also as the outcome of inner conditions, then it is not usual and, moreover, it is misleading to speak of causation tout court. In such cases the scholastic terms causa immanens and causa sui are sometimes employed in contrast to what the schoolmen call causa transiens, transitive cause. The corresponding determination will be called self-determination, the word Selbstbestimmung having actually been used by Hegel. The schoolmen held that nihil est causa sui, nothing is the cause of itself with the sole exception of God, who exists per se. What causal determinism does assert? The Renaissance rediscovered the Greek materialistic ideas on the self-movement of matter and the self-sufficiency of nature, which had just vegetated during the Middle Ages. Bruno stressed the ceaseless lifelike inner activity of all material objects. Descartes, more cautious, held that, to exist, substance needs only God's concurrence, being otherwise self-subsistent. Spinoza restated the Brunian thesis with vigor and contributed powerfully to spreading it. To him, substance is not only self-subsistent but also self-existent, self-moving, and self-caused. Substantia est causa sui. Besides extrinsic efficient causation, Spinoza introduced an efficient intrinsic causation 10, which was to become Leibniz's indwelling force or activity inherent in every monad. Though seldom explicitly recognized by post-Romantic philosophers with the exception of dialectical materialists, Whitehead and Collingwood, self-movement is by now a solid philosophical acquisition of the sciences. In no department of science are scholastic patients recognized any longer. On the contrary, material objects at all levels of organization are more and more being regarded as entities having an activity of their own, conditioned but not entirely determined by their surroundings. The ancient dialectical thesis is being increasingly, though unwittingly, recognized, that nothing changes exclusively under the pressure of external coaction, but every concrete object participates with its own inner flux in the ceaseless changing of the material universe, or, to put it otherwise, the sole static objects are ideal ones. Our central concern is not, however, the theory of the inner sources of change. Here we have to deal with the limitations that this theory imposes on causal determinism. The main consequence that the theory of self-movement has for causality is that extrinsic causes are efficient solely to the extent to which they take a grip on the prop.er nature and inner processes of things. Let us consider a few cases in support of this hypothesis. 7.1.5 External causes combine with inner conditions. The process of fire extinction is an almost trivial illustration of our thesis. In order to slow down the combustion rate, we must act with the right means. These may consist either in shielding the available combustible, or in adding some substance that decreases the rate of the chain reaction. To employ semi-Aristotelian language, the new forms we wish to inhere in the given body, the burning thing, cannot be contingent upon it, but must match with it, otherwise our effort will be fruitless, that is, the causal agent will not have the desired effect. As an illustration taken from the level of life, consider the invasion of an organism by noxious germs. According to the classical germ theory of disease, every sickness is but the modification of the organism, produced by invading germs, without any active participation of the patient. On this, typically causal, theory there does not arise in the organism a conflict of opposing entities, the one coming from the outside and the other developing within. Nothing new, save a quantitatively abnormal behavior, rise of temperature, loss of weight, and so on, appears as a result of the invasion. This causal theory, which of course meant an enormous advance over the maleficent spirits theory of disease, which was also causal, but supernaturalistic, whereas the germ theory was materialistic, the germ theory of disease, I say, had to be corrected when it was discovered that, when the germ invasion first occurs, something new emerges in the organism to defend it, something that had been neither in the agent nor in the patient before the action of the former, namely, antibodies. Thus, according to modern pathology, sick organisms are not patients but active fighters. Moreover, whether sick or healthy, organisms tend to maintain a constant inner condition. Bernard's Fixite du milieu intérieur, the homeostasis of recent physiology and cybernetics despite the variations of the environment. Organocels are, to a large extent, self-contained units that, so far as they survive, succeed in escaping, counteracting, or transmuting extrinsic, causal determiners. As Hegel said, whatever has life does not allow the cause to reach its effect, that is, cancels it as cause. 12. What Hegel could not suspect in his time is that the same transmutation of external causes by inner conditions, the same specificity of the response, is to be found everywhere in reality, not only in the domains of life and spirit. Mutatis mutandis, much of what is true of infections is also true of affections, whether at the level of sensation or at the level of feeling. With regard to sensations, it is a well-known fact that the responses of the sense organs are specific even if the stimuli are not, that is, there may be a common stimulus, but the effect will depend on the organ that responds. Thus mere mechanical pressure on the eye produces the sensation of light, and an electric current in the tongue produces the sensation of taste. In these cases of disjunctive multiple causation, see Sector 5.1.3, the type of cause is rather immaterial as compared with the specific nature of the reacting organ. And as regards feelings, love, for instance, is in most cases unexplainable in terms of external determiners alone. The standard, and envious, question, what could she find in him, can only exceptionally be credibly answered in terms of the male's charm or appeal. From this, the conclusion is usually drawn that love is not only an irrational but also an unexplainable affair, a conclusion apparently grounded on the mistaken Aristotelian identification of explanation with causal explanation. If love does not stand causal analysis, it may on the other hand be explained, at least in principle, in terms of her own predisposition to fall in love with whosoever meets a certain set of requirements, usually a meager one, but at any rate determined by her own state. In this, like many other human affairs, particular circumstances and individuals are essentially vehicles or occasions for the fulfillment of inner processes. The environment does not act on a person, but rather through a person. 12 and 7.1.6 Freedom, is it restricted to the ethical domain? The problem of self-determination, spontaneity, or freedom has traditionally been regarded as an exclusively ethical one. In a few, but important, cases, however, self-determination has been recognized as a property of all sorts of existence, not only as a quality of conscious, and preferably wealthy, humans. Thus Chrysippus 13 held that he who pushes a cylinder or a cone imparts to them an initial impulsion but does not confer upon them their own way of rolling, which is not the same for cylinders as it is for cones. Chrysippus went so far as to maintain that the initial impulsion was solely required to start the motion of bodies, which moved henceforth in virtue of their proper nature. Unfortunately, it seems that this outstanding Stoic did not develop his valuable remark into a physical theory, but employed it solely as an illustration of his doctrine on the operations of the soul. These operations he regarded, so to speak, as triggered but not as produced by external stimuli. He believed, in fact, like Plato before him, that the main source of change in the soul was not an external cause but the soul's own inner spontaneity. Paradoxical as it may seem at first sight, determinism cannot be regarded as complete unless what may be called the freedom or spontaneity of every concrete, material or cultural, object is taken into account. The refusal to acknowledge it may be traced to the Platonic tenet that only the soul is self-moving, whereas bodies are entirely passive. This belief is vital for idealism, but is inconsistent with modern science, which shows that the activity and spontaneity of the soul, that is, of the psychic functions, far from being its privilege, are rooted in the fact that every bit of matter is buzzing with activity. Self-determination, spontaneity, or freedom is what makes things what they essentially are, but is of course never, equals complete. No. 120 CFH Cantrell, A. Ames, Jr., A. H. Hastorf, and W. H. Leeson, Psychology and Scientific Research, Science, 110, 1949, 517. 3 C. Cicero, Digeto, 42-43. What causal determinism does assert concrete object can be entirely free, 14 but can only have a certain amount of spontaneity, both because of its intrinsic limitations and because it is actually connected with an infinity of other existence. On the other hand, no ideal object can be free according to any scientific theory of knowledge, since ideal objects are not self-existent but are products of the human brain's functioning. Contrary to Hegel's teaching, not spirit but matter is self-contained existence, basic Selbstsein. Freedom, in the general sense in which it is here understood, need not be conscious, and it is not an undetermined remainder, an arbitrary, lawless residue, but consists in the lawful self-determination of existence on whatever level of reality. 15 Various levels of freedom should, however, be distinguished, as many as integrative levels. The highest, but by no means the sole, degrees of freedom are found in humans. Here we have, in the first place, freedom of choice among externally given alternatives. In the second place, as a higher kind of freedom we find the power of creating new conditions, that freedom described by Rinuccini, 1479, as potestas agendi, power to act, which Vico, 1725, referred to as libertà di fare, liberty to do. In the third place we have conscious freedom of creation, described by Engels, 1878, as the recognition of lawfulness and the consequent application of this knowledge of laws to the attainment of control over the environment and over ourselves. In this case, not a lack of dependence but an active and conscious self-assertion is at stake, the control of bondage rather than its impossible absence, the conscious mastering of determination rather than the unawareness of it or the illusory escape from laws. By negating the element of freedom in every existent, causal determinism remains defenseless in the face of those who grant the individual soul a certain amount of lawless spontaneity, the free will to sin. It further consecrates the various philosophies of society and of history based on the belief that external circumstances are almighty, a belief to which a special section will be devoted. 7.2. Does man make himself? 7.2.1 Anthropological environmentalism. A characteristic feature of the various applications of causal determinism is the exaggeration of the role of the environment. A celebrated surviving species of the environmentalist genus is the biological doctrine according to which organisms are capable of responding only to external stimuli, and lack the capacity of a spontaneous activity flowing to employ picture language from an inner source, that inner drive which vitalism has exaggerated to the point of charlatanry. A subspecies of environmentalistic biology is the wrongly called neo-Lamarckian theory of heredity, which regards the environment as the sole source of genetic change, a theory philosophically as suspect as the orthodox theory of the genetic self-sufficiency of organisms. Just as nativism leads to absolutism, environmentalism leads to biological, and cultural, relativism. In fact, environmentalism tends to regard adjustment as the highest biological, and cultural, value. Now, if successful molding by the environment, or exact adaptation to it, is the highest value, then obviously ants are as advanced as men, and modern society is not better than the primitive horde. Some of the causal anthropological theories, in a legitimate attempt to account for cultural differences, stress the importance of the physical milieu, physiographic determinism. Others emphasize both the geographic and the political circumstances, geopolitical determinism. A further group of theories overestimates the action of the neighbors of every social group while neglecting the peculiarities of the group itself, diffusionism. Probably all of them would subscribe to the famous necessity. However, at least in his Vorlesungen über die Philosophie der Geschichte, 837, Hegel retained the popular notion of freedom as lack of bondage. What causal determinism does assert maxim typical of the Enlightenment according to which man is the product of circumstances. This belief has had and still has an enormous importance in anthropology, psychology, education, history, and sociology. Let us mention one of the most influential applications of anthropological environmentalism to psychology and epistemology, namely, the tabula rasa doctrine. After the Renaissance emphasis on the inner sources of change in all existence, after Bruno had sung the excellencies of the individual and of the artegus interno, which forms matter and figure from within, 17 after that revival of the doctrine of self-movement, empiricism revived the discredited peripatetic doctrine of the passivity of the soul. Empiricists would not have had such a success had it not been for the dogmatic Cartesian insistence on the Platonic notion of innate ideas, with which Descartes meant to struggle against Aristotelian empiricism. As a consequence of the tabula rasa doctrine, which was adopted by nearly all 18th-century philosophies and which survives in classical behaviorism, the inequality of minds had to be attributed exclusively to differences in individual experience, hence partly to differences in nurture or education. Thus Helvetius, in his urgency to refute the inept tenet of the biopsychical origin of social inequality, went so far as to maintain that men are born equal in all respects, being entirely the product of their environment and, particularly, the children of education. Even geniuses were to him nothing but the product of the circumstances in which they had been placed, and the whole art of education was reduced to placing young people in a favorable concours de circonstances. 18 Along with other progressive thinkers of his age, Helvetius did not fail to draw the social moral from the belief that education makes us what we are, namely, that the happiness of mankind is essentially a question of improving education. Needless to say, historical events have not confirmed this optimistic doctrine. Based on the empiricist theory of knowledge, reforms in education came as results of social revolutions. It is quite a recent discovery that, to employ the beautiful title of one of Gordon Child's books, man makes himself. This discovery had of course precursors in antiquity. It was rediscovered during the Renaissance and was again clearly formulated by Guillaume Battista Vico, 1725, who added that this is why we can know the civil world, society, be as we make it. But this doctrine has definitely spread only with historical materialism and the various meta-histories and meta-sociologies influenced by it. According to these trends, there is a reciprocal action between man and his environment, a mutual modification and not merely a one-sided action of one over the other. Both providentialism, man is God's aereatur, and the causal varieties of anthropology, external circumstances are almighty, are thereby overcome in a synthesis of nature and nurture. 7.2.2 Externalism in socio-political history. The limitations of causal determinism are particularly manifest in connection with the interpretation of concrete historical events. Consider the much debated question of the downfall of the Old Kingdom of Egypt, which is usually explained as the effect of the penetration of some unknown Asiatics in the Nile Delta, or the explanation of the collapse of the Western Roman Empire, as brought about by barbarian invasions only, or, finally, the explanation of the collapse of Byzantium as affected by the sole military efficiency of the Turkish troops. Is it not more likely that extrinsic determiners were successful only at certain critical points, after having failed during centuries, and that they gained in efficiency as the inner breakdown became more and more intense? Is it not more reasonable to suppose that, in the absence of an inner breakdown, the attacks of foreign enemies would have been either ineffective or far less efficient? Historical explanations in terms of external causes alone look as inept as explanations in terms of subsidiary inner determiners, such as moral corruption, which, after all, is but an aspect of the overall inner breakdown of a human social group. External determiners succeed in producing deep changes in a community if they enhance existing inner stresses to the point of collapse, as Hernán Cortés must have known when he conquered the Aztec Empire with a handful of soldiers aided by an army of rebel warriors. Cheap politicians are fond of an easy sort of causal explanation of the social transformations that they are either unwilling to bring forth or unable to check. Thus the French Revolution of 1789 was attributed, by the propaganda of the émigrés, to Russian and American agents. The Russian October Revolution was occasionally attributed to agents of the German Kaiser and time, and again the distressing events of our time are attributed to the almightiness of this or that kind of currency, as if corruption were politically efficient in the absence of social maladjustment. In general, police-minded people are fond of the notion that social conflicts are caused by foreign agents. It is obviously easier to catch a few foreigners and to discredit the ideas assigned to them than to relieve deeply rooted social stresses. This sort of causal explanation is easier and has less dangerous consequences than the scientific description of inner conflicts, such as those between the economic interests of different social groups, which description, by the way, might be able to account for the eventual success of foreign agents when they happen to exist outside the imagination of the police. On causal philosophies of history, every independent, original attainment of new levels of cultural growth is unexplainable. That is why the achievements of apparently isolated cultures, such as those of Mycenae and Easter Island, are still regarded as miraculous. And this is also why the naive belief in a Greek miracle has been replaced by a clever explanation in terms of borrowings from Egypt and Mesopotamia, which indisputable borrowings do not explain, of course, why the Greeks and not other peoples made the most out of the ancient Near East heritage. Diffusion does not account for the original mechanism of the Hellenic processing of those imported cultural goods, just as food intake does not explain assimilation. Only the study of inner processes in their actual contexts explains satisfactorily the emergence of novelty. 7.2.3 The doctrine of borrowing in the history of ideas. The doctrine according to which external influences are the sole motive force of change is perhaps most inadequate in the case of intellectual history, which certainly is affected by factors belonging to other levels, biological, economical, social, but is obviously not directly produced by them. One such theory is the doctrine according to which knowledge is but the reflection of nature or society in the human mind. See Sector 6.1.5. A less obvious manifestation of the causalist exaggeration of external relations is the habit of seeking the origin of the ideas set forth by a given thinker in the ideas propounded by previous thinkers, without caring for either the inner motivations or the conditioning of the cultural atmosphere and zeitgeist in which the author in question lived. Among historians of ideas who neglect or entirely ignore the socio-cultural background and the eventual long-run social efficiency of the ideas they investigate, it is customary to trace intellectual influences directly from author to author. At first sight this procedure is able to tell the inner story, as it dispenses with external, non-theoretical, so-called anecdotic, circumstances, it is, however, none the less external, for it also dispenses with the inner world of the thinkers in question. In fact, it consists in manufacturing pretty causal chains of the type author N read author N, I, from whom he took the idea under consideration, but N, I had in turn derived that idea from writer N, 2, who read it in a book by N, 3, who borrowed it from a manuscript by N, 4, who copied N, 5. To this sort of intellectual diffusionism belong outstanding historians of ideas such as Duhem 19 and Lovejoy. 20. This historical mismethod, of tracing influences without caring to inquire into the personal contributions of the thinkers concerned and into the social circumstances and cultural atmosphere in which they lived, is, of course, able to explain. 188. What causal determinism does assert many things in a simple way. It explains everything except, a. how author know. I managed to get his ideas unless it be assumed that they were revealed to him, and, b. why writer number n was influenced just by author number n, I, refusing to let himself be influenced by the thinkers belonging to other chains. That is, the theory according to which scholars are what they have read is as inadequate as the doctrine according to which thinkers are what they eat, as it fails to explain originality as well as why, out of an enormous number of acting influences, only a smaller number are effective, while the largest mass of them do not succeed in starting the processes of intellectual creation. 7.2.4 Man, the self-domesticated animal. It is one of the ironies of history, one of the inconsistencies showing how far history is from logic, that the ideologists who prepared the French Revolution in the sphere of ideas held with the almost single exception of Diderot the belief in the preeminence of external conditions. This is funny, for such a belief is not only incapable of explaining social change in terms of human actions, but fits moreover admirably with social regimes in which human life is subjected to coaction, whereas spontaneity is the privilege of a chosen few, and even this in a restricted domain. No less amusing is the spectacle, which can still be witnessed in our days, of the thinker who displays an enormous scholarly activity with the aim of demonstrating that intellectual work is socially ineffective, on the ground that ideas are nothing but the passive reflection of society and cannot in turn affect anything another typically causal conception. Such is not, of course, the view of revolutionaries. To the extent to which they are consistent, social transformers cannot consistently accept those varieties of determinism which, like Buckles or Taines, lay the main emphasis on extrinsic determination and consequently deny that man is his own creature, that as contrasted to lower animals human beings are primarily the children of their own material and spiritual work. This does not, however, amount to underrating the value of education in the externality of causation. 18g The narrow, technical sense of the word. The doctrine that in the changing of his environment man changes high in self and thereby builds himself up implies that the best contrived educational method will be ineffective unless it matches the prevailing social conditions, which have to be changed first because they act as dominant determiners. It is further implied that adequate methods of education cannot be framed in detail before it is known what the changed social conditions and the changed men will be. The continual self-change of man as a result of his self-domestication does not preclude, however, the existence of certain human constants, of certain characteristics that have not changed appreciably in historical periods, a constancy without which no definition of humanness would be possible. One such constant is precisely the property common to all concrete existence, but qualitatively richer at the higher levels of reality, of possessing a varying amount of spontaneity or self-movement, and consequently self-determination. This essential, though not exclusive, trait of man is implied in most progressive trends in contemporary education. The teachers of old, saturated with empiricism, whether Aristotelian or Lockean, conceived of education as the engraving of a fixed, perfect curriculum on a passive tabula rasa. Progressive contemporary methods, on the other hand, stress activity. They emphasize, sometimes to the point of exaggeration, the active search after interesting information, and put aside the passive and resigned reception of uninteresting information, they regard a pupil as a being endowed with a certain amount of autonomy, whose free activity must be stimulated and channeled rather than suppressed. Following the Socratic model 21, the best of these modern trends conceive of upbringing as the task of helping to give birth to the pupil's own personality. To the extent to which it succeeds, the maieutic method refutes causalism. 7.3. Causality requires the persistent maintenance of the cause to secure the continuance of process. 7.3.1. The peripatetic maxim causalis ante cessat effectus: if every change, however small, is due to an efficient cause, then whatever is in process of change must have a cause sustaining that change, whence the peripatetic maxim causalis ante cessat e fectus - the effect ceases after the cause has ceased. 22. This rule is not an isolable piece of scholastic cosmology but a necessary constituent of the doctrine of efficient causation. It is, in fact, a corollary of the disregard for the inner activity of things, a neglect that is characteristic of causalism. See Sector 7.1. The negation of that maxim would amount to the acknowledgement that there may be uncaused events. The rule is moreover indispensable for theology, since it entails that some creator is necessary, even in the atomic age, in order to keep the world running. But, like so many rules enjoying a persistent popularity, this one has a ground in the common sense account of daily experience, which teaches us that, in human affairs, things do not get done by magic but by hard work. False as a universal rule, our peripatetic maxim has a wide field of practical applicability. Let us review a few examples of self-sustaining processes that falsify the foregoing rule. 7.3.2. Instances of self-sustained processes. The Greek atomists in antiquity, and Galileo and Descartes at the beginning of the modern era, found the first example of a non-causal process, of a movement that goes on by itself without any sustaining cause. It was mechanical motion, change of place, which, once started, proceeds of itself without needing any causal agent pushing or pulling the moving body along its path. The effect, motion, does not cease after the cause, force, has been removed. As Newton put it, the impressed force consists in the action only and remains no longer in the body. 22. Thomas Aquinas, Summa Theologia, I. 96, 3, ob. 3. The externality of causation when the action is over. For a body maintains every new state it acquires, by its inertia only. 23. Efficient causes produce alterations in this, the simplest sort of change, whose successive states are uncaused. An electrical analog of this sort of change is the current in a circuit. If the current be left to itself, it will continue to circulate till it is stopped by the resistance of the circuit. 24. Its energy being converted into heat or mechanical energy or both. A magnetic analog is the permanent magnetization induced in a piece of steel, as contrasted to the temporary magnetization induced in soft iron. And an optical analog of inertial motion is the propagation of a light ray in vacuum after it has been emitted, that is, once the cause of the light, usually accelerated electron motion, has ceased. The electromagnetic theory of light shows that the radiated field becomes independent of its cause or source, this decoupling being why the velocity of light does not depend on the state of motion of its source. Moreover, the propagation of light, which geometric optics takes for granted and does not regard as a process but as a stationary state, is explained by the theory of Maxwell and Hertz as the result of the inner opposition between the electric and the magnetic components of a light wave, which generate each other chainwise in accordance with Maxwell's field equations. The emission of a train of light waves is caused by a certain motion of electric charges, and every link in the electromagnetic chain can be regarded as the cause of T next, but, once started, the process as a whole is not causal but rather dialectical, since, to employ the metaphorical language of the Romantic period, it proceeds through a strife of opposite. Other well-known chainwise and self-supporting processes are chemical and nuclear chain reactions. The extrinsic cause does nothing but unchain an internal process that not only goes on thereafter of itself, but does it in an increasingly amplified way, so that the final effect is enormously larger than the triggering cause, thereby falsifying a further scholastic dictum, namely, causality quod effectum. An equally familiar after effect is phosphorescence, the cause producing the radiative instability of the material, namely, the light rays impinging upon the phosphor may disappear, despite which the body will continue emitting light for some time. There is, of course, a motive for the re-emission of radiant energy, but it lies in the structure of the phosphor itself, which is disturbed by the extrinsic cause. The efficient cause has not been sufficient to produce the effect, but has merely initiated a process leading to it. In general, modifications produced in complex physical systems by external agencies last for a time after such agencies have ceased to act. In ideal cases, inertial motion, light wave in perfect vacuum, isolated magnet, the effect may last forever. In actuality, that time is finite, and particularly in everyday life where sources of dissipation of energy, such as friction, are intense, the time of recovery is often very short. When this interval, the relaxation time, is negligible for all practical purposes, the maxim causas est ante cessat ejecta seems to apply. But rigorously speaking, it never applies, for it is based on our ignorance of the processes that render the cause effective and the recovery rapid. It is hardly necessary to show that self-supporting processes are conspicuous at higher integrative levels, characterized as they are by a richer variety of forms of self-activity and hence of self-determination. True, a great deal of physiology and psychology still employs the fiction of the direct, immediate, stimulus-response connection, and behaviorists still reject as meaningless the investigation of the inner mechanism connecting such extreme links. Yet, the poverty of both the causalist and the phenomenalist approach is increasingly being realized. Recent work on the physical basis of nerve signals has shown that the nerve pulse is not a mere propagation of an externally impressed excitation, but consists instead of a self-sustained chain reaction. An electric stimulus beneath a certain critical strength produces no nerve response at all, but having reached a certain threshold, it produces a large action potential which is insensitive to the precise value of the stimulus, provided the latter is larger than the threshold value. Moreover, the nerve fiber is not a mere conductor of electric impulses, but a source of new pulses that are much stronger than the stimulus, and that are propagated along the axon by means of a regenerative process that compensates for losses, see Fig. 24. And when nervous tissue builds a differentiated nervous system, the transmitting and self-exciting functions combine to constitute a shock-absorbing mechanism that protects the whole organism from its environment, Pavlov's inhibitions and Freud's defense mechanisms. That sensations, images, and ideas may persist even after the removal of the agents triggering the processes ultimately producing them is a fact of immediate daily experience. It was not, of course, denied by the empiricist school of the tabula rasa, but memory was regarded by this school as an engraving, as a more or less permanent modification in the percipient subject, not as a process lasting for a time. The contemporary tendency, on the contrary, is to regard memory not as a static storing place but as a permanent dynamic process, not unlike Hartley's vibrations. According to the theory propounded by David Hartley 2 centuries ago, sensations do not die as soon as their causes or stimuli cease, but are stored in the nervous system in the form of miniature vibrations, which may last for years. Modern theories of memory reject, then, our peripatetic maxim, and to that extent they are non-causal. Examples of self-sustained processes that last after the cause. 194. What causal determinism does assert unchanged, deigning them is over can be multiplied. What is difficult to find is, rather, a concrete process in which the effect ceases as soon as the cause ceases. If one should be found, previous experience ought to suggest the hypothesis that the time of recovery from the externally induced disturbances is simply so short that it has escaped available measuring devices. 7.4. Summary and conclusions. Those who accept the principle concerning the activity inherent in every concrete, material or cultural, object, and the thesis that the world as a whole has no cause but is self-existent should not fail to realize th3.t. The consideration of efficient causes as sole determiners leads to an incomplete determinacy, that is, to a partial indeterminacy. Indeed, if we know that the concrete object contributes its own specific mode of being and of ceasing to be, a change that may even oppose and consequently modify the external agencies acting on it, then it is obvious that efficient causes do not determine effects completely, that is, that causation only contributes to the determination of the effects but does not produce them entirely. Lack of freedom is, then, not the rule of natural law but the serious hampering or distortion of self-determination by external constraints and disturbances. Freedom is not a violation of law-like behavior but a type of it, namely, self-determination. In the field of the sciences of man, causal determinism leads to exaggerating the importance of the environment and of the concours de circonstances. It suggests the distorted image of man as a passive toy at the mercy of unsurmountable powers, whether natural, such as geography, or artificial, such as society. On this essentially conformist view, liberty is largely illusory, since it is conceived solely as a negative value, that is, as the impossible absence of bonds. It is freedom from, not freedom to, the active and eventually consciously planned self-determination. As soon as self-determination is taken into account, as soon as it is realized that nothing is the exclusive consequence of external conditions, however important they may be, an element of voluntarism illuminates the historical scene, not, of course, a voluntarism asserting the arbitrary, irresponsible, and lawless will of enlightened Führers, but one consistent with scientific determinism. Liberty is then seen as a positive value, namely, the active endeavor to attain the optimum self-determination. And fatalism is then seen to be a bad dream, for nothing can be regarded as the inevitable consequence of either past occurrences pushing events along predetermined paths or present causes operating ab extrinsico beyond the reach of man's material and spiritual work. The act of releasing a bow is usually regarded as the cause of the arrow's motion, better, of its acceleration, but the arrow will not start moving unless a certain amount of potential elastic energy has previously been stored in the bow by bending it. The cause, releasing of the bow, triggers the process, but does not determine it entirely. In general, efficient causes are effective solely to the extent to which they trigger, enhance, or dampen inner processes. In short, extrinsic, efficient causes act, so to say, by riding on inner processes. Or, as Leibniz put it, every passion of a body is spontaneous or arises from an internal force, though upon an external occasion. 25 The principle that the efficiency of extrinsic determiners depends on the intrinsic ones may be regarded as an induction from the most varied fields. Moreover, it is implicit in Francis Bacon's golden rule, natura non vincitur nisi parendua - nature can be mastered only by obeying her. As a consequence, causal determinism is incomplete. If causation is regarded as the sole possible form of determination, indeterminism is unavoidable, as illustrated by the story of natural radioactivity which, being so far as we know a spontaneous process, was wrongly regarded as an instance refuting determinism in general, while it actually just contradicts causal determinism. However, the opposite exaggeration, which consists in regarding inner processes as if they could actually arise and subsist in complete isolation from external circumstances, may lead to equally ridiculous extremes, such as solipsism. Every concrete object is self-acting, but nothing in the world, save the world as a whole, is self-sufficient. Concrete things are not self-sufficient because they actually stand always in interaction with an unlimited number of other existents, nor are ideal objects, which lack self-movement altogether, self-sufficient, since for their very existence they depend on some mind. It is a common event in the history of knowledge that what at first is regarded as altogether spontaneous is shown on closer investigation to be caused or at least influenced by external determiners, and vice versa, and what at first appears as structureless ends by displaying its internal complexity. The explanation of the object's properties in terms of external causes alone is but a stage of a process in which various further categories appear in succession, notably those of internal structure, interaction, and self-movement, see Fig. 25. Complete self-determination, that is, total freedom, is as illusory as efficient causation, understood as external compulsion, is insufficient. An adequate picture is provided by a synthesis of self-determination and extrinsic determination, in which external causes are conceived as unchangedness of inner processes rather than as agents molding a passive lump of clay. The two exaggerations of environmentalism and innatism, with their sequels of relativism and absolutism, are thereby avoided. Now, if extrinsic efficient causes are regarded as efficient solely to the extent to which they inhere in inner processes, room is made for the may at the expense of the must. Novelty is seen to be possible, not only as a result of the external chance encounter of initially independent lines of development, but also as emerging from the non-additive grafting of one process on another process. But the problem of newness deserves a new chapter. Causality is undoubtedly a theory of change. But does it succeed in explaining radical change, that is, the transformation that consists in the emergence of things endowed with new properties? This is the problem that will concern us in the present chapter. Two extreme answers to this question have been set forth within the frame of the theory of causality. According to one of them, efficient causes alone can bring forth novelty. On the other hand, what can be regarded as the strict doctrine of causality has often been invoked just against the possibility of the emergence of newness. If the synthesis of self-determination and extrinsic determination, sketched in the previous chapter, is accepted, the two solutions will be found inadequate, and a synthesis will again be sought. The one here suggested is simply this: causation is insufficient to produce qualitative changes, but it usually does take part in them. Yet before approaching the change of properties we should consider the impact of causality on the very concept of property. Substance whose sole peculiar property is the capacity of receiving properties, being otherwise immutable, independent, and simple, if, in short, substance is incapable of changing and serves only as the receptacle, carrier, or support of attributes, substans accidentibus, then any of the following consequences is possible: the substance and the attributes can exist separately from one another, the former as the unqualified ends of the schoolmen, and the properties as Platonic ideas. The substance can exist by itself as an unqualified entity, but the attributes cannot exist without a substratum to dwell in, like Aristotle's forms, which inhere in a passive matter without having themselves an autonomous existence, or like Aquinas' accidents, which are added to the immutable essence and are dependent on the substance. The properties can exist by themselves, the existence of the substratum being contingent. In all of these cases the substance and the attributes are regarded as unchanging, as if there were in the world a limited stock of different qualities or properties that can add externally and stick on the resubstant as ready-made labels. These views on the nature of properties and change exclude the emergence of authentic novelty in the sum total. They just allow for the circulation, not for the appearance of novelty. Notice that they are not merely worn-out pieces of scholastic metaphysics.